Hello everyone, my name is Mohit and welcome to First Mentor. I'll be your mentor throughout this course, and today we are gonna study what is C and what we can do in C, who have developed C and many more stuff, right? So let's get started. Introduction. As you all know that C is a programming language developed at AT and T Bell Laboratory of US in 1972, designed and written by Denny Ritchie. So the name of the developer of C language is Denny Ritchie, and C is a very highly portable language. That means C can be used in different the programs or the software written in C can be like used and run in different computers, like on different OSs, right? And C can extend the important feature of C, which makes it like very important in today's world. Also, is that its ability to extend itself. That means it can add on features while like throughout the year or throughout the period of time. And a C program is basically a collection of functions. That's the main reason it can extend itself, because we can add on the functions as well as we can make new functions add in the previous functions. That's how it extend itself, right? So the last point says that in beginning C was intended to be useful for busy programmers to get things done easily using functions. So, as the point says, that it was basically introduced for the programmers who used to have a lot of work and they can easily do their work using the inbuilt functions in C. So, that's why C was introduced. Yeah. So, now moving on to the next slide. Uh, all about C. A C is a structured programming language and also a object oriented language. In this, we can like make objects using a special keyword known as struct, right? So, moving on to the next point, C supports functions that enable maintainability of the code by breaking large files into small modules. Suppose we have to make a very huge program. Since C support functions, we can break our big program into small chunks of functions, and we can make that program maintainable or more readable or more understandable by the person who is looking at our program. So that's why C is very important or very useful, we can say. Comments in C provide easy readability. The comments we make in our code make our code more readable. That means anyone who is going through our code base can easily read using that comments that what we are trying to do in that piece of or that chunk of code, right? And the programs built in C have four main key features. That means they are built using 4 points. That is variables and type declaration. Second point by declaring functions. Third point by by using statements, and fifth point by using expressions. So these are four main points using which we can build our C program. Right. So moving on to the next slide, this is our very basic structure of our C program. Right. These are two header files. We'll tell you like what header files are in our as our course will move forward. We'll tell you what header files are and why we use header files or why we have to include them in our program. Right. So you can just see these are header files in the top. Then there is a main function. It is the entry point of the program. When the compiler read this, that means from now onward, we'll be entering the main logic of the program, right? So these are two curly braces, opening curly brace. This is opening curly brace, and this is closing curly brace. Everything, every main logic would be written inside these two curly braces, and this indicate our compiler that here our program is starting. So that was pretty much about the introduction of the C. In next video, we are gonna like set up our ID for writing programs, and I'll see you in next video. Thank you everyone. Hello everyone, welcome back to First Mentor, and in this video we are gonna set up our IDE for coding, and the ID which we are going to use is code blocks. And for those who do not want to install any external ID, I have solution for them as well. But let's just install code blocks first. And what you are supposed to do is just come on your Google Chrome and type just a second. Type download code blocks and just click on the first link. This window will appear and you have to click on this link, download the binary release. And this window will pop up and you have to download this version of code blocks 20.03 MinGW, right? So we are downloading MinGW version so that GCC compiler is already inbuilt in it, and we do not have to like use external GCC compiler, right? So we'll simply click on force hub, and after that it will start getting it will start downloading by itself. Let's just wait for it to get download. It depends on the internet connection of people to people. Like it may take some time for like 5 to 10 minutes in different PC depending on the internet connection. Now if I simply click on the file, and the the installation window will pop up. Let's just wait for the installation window to pop up. It may take some time depending on like configuration of your laptops or PCs whatsoever you are using. So it may take some time in your laptop or PC. Here you just simply have to click on next. I agree. Next, you do not have to change any default setting, and just remember where you are installing your code blocks. I'll tell you why. And simply now install, since I have already installed, so I'm not installing it again. So after installing, uh, what you are supposed to do, just go on your my computer, and since in my laptop it's installed in C drive, I'm opening my C drive, and in C drive it's stored in program file, and here it is. And after going to code blocks, you have to go into the MinGW, and in MinGW you have to go in the bin drive. And what we are supposed to do, we just have to like copy this like path what is shown in here. We just have to copy this. Right, now we'll click on our search of Windows, and what we are supposed to type is uh, environment variable. Like, yeah, this will appear, and just have to open this. This window will pop up, and here you have to click on environment variable, and here you are supposed to click on path, and here now click on edit, and this window will appear, and here you just have to click on new and paste the path which you have copied, right? Since I have already pasted it, I am not copying it or pasting it again. Now just you have to simply click on OK, OK, and OK again. So now to check if your compiler or MinGW or like code blocks is installed correctly or not, we just have to click open our command prompt and write gcc dash dash version. And if this kind of reply appears, that means it have installed properly. And then what we are supposed to do, we just have to open our code blocks application. Like shortcut have already appeared here, so I'm just opening it because I have already installed it, so I'm just opening it directly. So now what we are supposed to do, we are supposed to make a new file, and empty file, right? So what I'll do, I'll save this file as like first. I'm naming this file as first.c, right? It just got saved. Now I'm just trying to run and check whether it's like working properly or not. So what we are supposed to do, we'll be including the header file as we have seen in our like structure of C program, and the header file I'm including is studio.h. And I'll tell you in the later videos why we are including these header file, and then we'll be using void main. And I've told you why we include void main. It indicates the like compiler from here that program or the logic is beginning. And I'm writing this return 0 because whenever we are using this void main, in the end we just have to write the statement return 0. It's a norm, right? So after this I'm just printing hello world. Printf is used to print the statement. I'm just writing hello world. And yeah, that's it. Let's just try to run this. With this button, we can build and run our program. And with this button, we can simply run without building. So I'm clicking this. Let's see if it works or not. So yeah, we can see like hello world appears. That means this program executed fine, worked finely. So this is how we can use code blocks IDE. This is the way we can install it, and this is how we can check that whether it's working fine or not, right? So now for those who do not want to install like code blocks or any other external IDE in your laptop, so I have a solution for you all as well. So what we can do, we can simply open our Chrome and write GFG IDE and just click on the first link up here. Right. So this is an online ID by provided by GFG, and we can simply write our code and compile in here. And since it is an online ID, it's not getting installed or it's not using any space in our laptop because we are not installing it on our laptop. Right. So it have bunch of languages available since we are doing like programming in C. So I have selected C, and now we'll simply try to print hello world. So let's see if it works or not. So this is the structure which they are providing us before, and we have got the output hello world. That means it's just working fine. So this is how we can like use both the IDs depending on your like convenience. You can use any of them. As per my convenience, I'll be using either GFG ID or code blocks throughout the course. So yeah, that's all about setting up the environment or IDE in your laptops. I hope you all have set it up your IDE in your laptops, and from next video onwards, we'll be moving forward. So yeah, thank you everyone. Hello everyone, welcome back to First Mentor. And today, I hope you all have setted your ID and everyone's ID is working and everyone is fine with it. So today we are gonna study about variables as well as constant. So as the name suggests, variables, as we can like imagine through the name of variables, that it is something which is varying. Right. So as we can see in our first point that variables can hold a number or a data of other type. That means they are something which are holding something. Right. It always holds something. As I told you, it always holds something. The data save in variable is called value. So whatever data we are storing in a variable is known as value, and like it is varying throughout the program. That's why it is named as variable. Uh, like it can be vary at different places according to the needs. So that's why they are named as variable. As we are able to come across the first point, and we are able to conclude that the data stored in it is named as value, right? So in the second point, variables are implemented as memory locations and assigned certain memory address. The exact address depends on the computer and compiler, right? So the point says the like variables are stored in the RAM memory, and what would be the address of that like where variable are storing, that depends on the computer as well as the compiler of different computers, right? So coming on to the third point, we think as through the memory location are actually labeled with the variable name. So we do not have to like memorize the address of the variable to like access that value of the variable. We just simply have to assume that whatever name we are giving to our variable is the name of that address, and we can simply get that variable or that value stored inside the variable just by simply writing that variable name. So as you can all see in this diagram that this is our memory block, and here it's a variable created, and the address of this variable is this, and it will vary on different computers because different computer have different configuration, and this is the value we have stored in our variable, and this is the name we have given to our variable. So we can simply assume that whenever we'll write this name, it will eventually access this value, and we do not have to remember this whole address all the time, right? So coming on to the next slide, that is constant. So, as the name suggests, constant are something whose value stays constant throughout the program. Let's just go through the like this paragraph and let's see what it says. Constant and C are the fixed value that are used in the program. As I told, these values are fixed throughout the program, and its value remain the same during the entire execution of the program. I've told you this before. And constants are also called literals. Other name for constant are literals, right? So constant can be of the data types, and we'll be studying data types in upcoming slides. So till now you just have to remember that constant are those whose values stays constant throughout the program, and we like the value stored inside the constant are not changing, and the name of constant is literals. So yeah, that was pretty much it about constant and variables. And in next video, we are gonna study about identifiers and keywords and variable declaration. So yeah, thank you everyone. Hello everyone, welcome back to First Mentor. Previous video we studied about variables and constants, and in this video we are going to study about identifiers and like keywords and how to declare variables. So let's get started. So identifiers basically are, as the name suggests, are used to identify something, and what that something will be in our program is, let's see. Name of variables or any other item you define in program is called identifier. So like any name of the variable or name of any other thing, or should I say constant in our program, is known as identifier, right? So identifier must start with a letter or a underscore symbol. This is the underscore symbol. So there is a particular norm to define a identifier or to do the nomenclature of a variable or a constant in our program or in C language. And that nomenclature norm is that it should always start with a letter or it should always start with a underscore. The rest of the characters should be letter, digits, underscore, and the first letter should be character or a underscore, and remaining rest of the letters in our name or variable name could be anything like digits, like letters or underscores, right? And they like the followings are the valid identifiers. That means like these are few identifiers which are valid on our C language. And let's see, like this is X, it's just a character name and it's just a simple letter, and X1 it's starting with the character, and here it's digit after character, so that's why it is valid. And it's X underscore 1, And this is also valid because starting with the character, and then after that there is an underscore, and then after that there is a like digit, right? And it's underscore ABC, and it's valid because it's starting with underscore, and after that there are just letters in this name, right? And it's sum, and it's also valid because it's starting with the character and also have character in this name only, right? So these are the following identifiers which are not valid. So like 13, it's itself a constant. Like we cannot use a constant as a variable name, right? So 3x, it's starting with a digit. We cannot start our identifier with a digit, right? Percent %x, we cannot start our identifier with a special character like hashtag or a percentage sign, right? Data -1, it's a equation itself, and it is also including a like constant in it, so that's why it's not a valid identifier. So these are the few basic overview, like these were the few things about identifier, and it was all like overview about the identifiers, right? So moving on to the keywords. So if I talk about keywords, keywords are identifiers reserved as a part of language. Like keywords are nothing but the identifiers itself, but they are reserved by the language. That means we cannot use these keywords as identifiers throughout our program. And these are few keywords, that is int. We, as you have seen in the variable video, that int we used to declare a type of a variable, so it have a special meaning to the compiler. That's why we cannot use this in our like as an identifier, right? Return, float, double, these are few keywords which cannot be used as identifier. That means these are reserved by our program, right? So moving on to the next point, they cannot be used by the programmer to name things. Like as I told you, these are reserved. So these keywords are reserved. So we cannot use these keywords throughout the program to name anything, right? Moving on to the next point, they consist of lowercase letter only. Like as you all can see in this, like it only consists of lowercase letter. So that's what our this point says, that it only consists of lowercase. There are no other like alphabets or digits in it, right? And last point says they have special meaning to the compiler. That means when a compiler compile these words or keywords, it indicates something to the compiler, some special meaning to the compiler, and which only compiler can understand. And we just have an overview of that what it will mean to a compiler, right? So now moving on to the next slide. So these are few like keywords in our C language. There are actually 32 keywords in our C programming language, and these are few of them, like auto, double, int, struct, break, else, long, switch, and you can go through all of them by like pausing the video, and you can just have a look over these keywords. And just remember, we cannot use these keywords as an identifier in our uh, program, right? So now moving on to the next slide. So here it comes to a very important part. We till now we have discussed about variables and like identifiers and keywords, but all of these will come into role only when we will be declaring a variable. So that's why declaring a variable is a very important part. So let's just go through these points and understand what they have to say. Right. So every variable in C program needs to be declared. Like before declaring, we cannot use them. Right. It have to be declared. Right. Coming on to the next point, declaration tells the compiler what kind of data is going to be stored in a variable. When we declare a particular variable, it whenever we are compiling our program and we have declared a variable, the compiler will get an idea that what data value will be stored in it and how much space it will be taking in our memory, right? That's the importance of declaring, right? So moving on to the next point, the kind of data stored in a variable is called it's called a type. So the data type which we are storing in a like variable is called its type. That means if we are storing integer type value, that means the data or the variable is of integer type. If we are storing a character type like variable in our variable, so it would be of character type, right? So moving on to the next point, a variable declaration specifies these 2 points. That means we have to include these 2 points while declaring our variable, and these 2 points says that first we have to specify our type, that what type of the variable it will be, and the second would be name of the variable, that like what name we are giving to our variable, right? So declaration syntax in would be like type and name. Like first we will define the type, what type it would be of, and then the name of the variable. Right. So now moving on to the next point, like it says an example. Like for example, suppose we want to store a integer in a variable, then we declare it like int a. Here int mean integer, and a is the name of the variable, right? So int is a keyword, as we have studied in our keyword videos, that it specifies the compiler that the variable or the type of the variable would be of integer type. That means it would be only storing integer values in it, and a is the name of the variable, as we have as we have discussed in our variable videos, right? So yeah, I believe that's pretty much it in this video, and we'll meet you in the next video. Thank you, everyone. Hello, everyone. Welcome back to First Mentor. In previous video, we discussed about variable declaration and everything about variable, like how to do nomenclature of variables and so on. So, in this video, we are going to study about data types. Yeah, they are the same thing which we write before the name of the variable that defines the type of a variable, right? Like in previous video, I told you an example in the variable declaration that suppose we want to like declare a variable of which will be storing only integers. So we'll type int in front of that name, and that will be its type. So that is nothing but its data type, right? So let's just go through this point, and let's see what it have to say, right? So in the C programming language, data type refers to a broad system used for declaring variable or functions of different type, right? So in C language, like type refers to a broad system used for declaring variable. That means like it defines what a variable is, or what type of a variable is, or what type of a function is. We'll discuss about the functions later on in our course. You just have to if you want to uh, know a bit about it, it's like data type defines what kind of value the function will be returning. So yeah, that's a brief introduction or brief about it. And moving on, the type of variable determines how much space it occupies in the storage and how the bit pattern store in the interpreted, right? So the data types define to the compiler that how much amount of space our variable will be storing, variable will be taking in our memory, right? So this is very important point, because only then our compiler would be able to know that how much memory it have to read, or like how much space it have to see to check what variable actually or what value is stored in the variable, right? So now moving on to the next slide. So this is a basic flow chart which defines everything about every type of data type, or everything about data type. So let's just go through it quickly. So data type, and it have like basic three types: primitive, aggregate, and user defined. Primitive means which we have already defined in our like programming language. Those are like int type. We'll study like what int type data types are. float type, double type, and character type. So these are four primitive data types which we are getting with our C language. That means we can simply write int and declare a variable in front of that, and we do not have to write a whole bunch of description in front of them. We can simply write these name and use them, right? So if I talk about aggregate data types, these are of array type. Arrays are basically a collection of memories, and we'll be studying brief about or more about and deeply about it in the upcoming videos. For now, you just have to remember that it is a aggregate. It comes under a aggregate data type. That means it is a collection of memory. Right, it's not just storing a single data, it is storing a bunch of datas in it, and that bunch of data would be of same type, right? You just have to remember this as of now, right? And talking about user defined, that is third type of data type. It is of like two types, that is structure and enumerator, right? We will study about structure and enumerator like deeply as we move on with the course. So as of now, you just have to remember that structure and enumerator help us. That means a user to define a data type, which will be convenient for us to store a particular type of data or any kind of data which is more related to a real world problem. That means suppose you all are students, right? So a student must be having a name integer, a name, a roll number, a phone number, and a class or a course, right? So suppose we want to make a variable of name student, and we want all of these properties, that is name, roll number, course, and phone number, to be stored in a particular just one variable. We do not want to declare uh, different variable to store these things, right? So their structure and enumerator will come into the role, and we'll be studying deep and more about them in the upcoming videos, right? So now moving on to the next slide. So int data type. Let's talk about int data type. So integer are whole number with a range of values. Range of values are machine dependent. Generally, an integer occupies 2 bit in the memory. Right. This is important. It just occupies 2 bits in the memory space, and its value range limited to the minus 32768 to plus 32766 67. Right. So the value in the integer data type just varies between this interval, and it just take 2 bytes of memory in our memory space. And generally we store a whole number in int data type. It could be positive or it could be negative. That means whole number, with the whole number I mean that it would not be having any kind of decimal values, right? So here data type int, we can take input of like int type by using %d. We'll be studying out input and output in upcoming videos. You just have to remember that with %d we can take input of a int type, and it takes 2 byte of memory in the memory space, and it range goes from 32768 to 32767, right? And there is a long int, as the name says, it's a integer type, but it says the long in front of it defines that it would be storing a bit of a large range of values, right? And with percent ld, we take input of a long int type of data type, and it takes 4 bit in the memory space, and it range goes from minus 2 to the power 31 to plus 2 to the power 31. So it's a very huge range as we compare to int type. It is storing a very huge range of variables or whole numbers, right? And there comes to unsigned int. An unsigned int is basically it just store the positive values, right? And with the %u we can take the input of a unsigned integer, and it also take 2 bytes of memory in the memory space, and it values range from 0 to 65535. This is the range of values a unsigned integer is storing. So this was a brief about int data type. Now moving on to the next slide. Character data type, right? Character type variable can hold a single character. This is important. It just store a single character. That means it could be like A, B, C, D. It like just a single character, right? As there are signed and unsigned integer, either short or long. In the same way, there are signed and unsigned character, both occupy 1 byte. Like either it could be signed character or unsigned character, both would be storing just 1 byte of memory each, right? But having different ranges. Unsigned character have value range from 0 to 255, that is 255. As we all know, like unsigned integers or unsigned variables only stores the positive range of values. So similarly, unsigned character is storing values between 0 to any character whose SKY value range from 0 to 255, right? And signed character have values ranging from minus 128 to plus 128. Any SKY character who is having value ranging between minus 128 to plus 127, right? So that was brief about character data type, and now moving on to the next slide. Float data type, right? This is one of the important data type because it's like it help us in storing the decimal values also, because it's not like we always store a whole number. There could be possible chances or possible cases where we have to store the decimal character or decimal integers also, or decimal numbers also. So that's where this float data type comes into the role. So let's read the point, what it have to say. The float data type is used to store fractional number, that just said to you that decimal numbers are stored in float. Real number with 6 digit of precision. That means after decimal, it just store up to 6 digits, right? Float point number are denoted by a keyword float. To declare a float type of data type, we have to write float in front of the in beside the name of the variable name, right? Where the accuracy of the floating point is insufficient, we can use the double to define the number. So as we studied in int data type, that int data type is storing a small range of variable small range of numbers. Similarly, float store a small range of number, and in case where like float range is not sufficient to store data, there double comes into the role. It is having a wider range of storage, and wider range to store integers or decimal numbers, right? The double is same as float, but with long precision. In float, it is having 6 digit of precision, but in double it have longer precision and takes double space. That is, float was taking 4 bytes, so uh, like double takes 8 bytes, right? To extend the precision further, we can use long double with the occupied 10 bytes of memory. uh, like if double is not sufficient to store our variable, we can go to the long double. Long double we can use, and it takes 10 bytes of memory space in our memory, right? So here is the table which shows data type, size and value range and its precision, right? So data type float have 4 bits and store values from 1.2 to the power minus 38 to 3.4 to the power 38, right? And it is having precision, like it takes up to 6 decimal places, right? And talking about double, it is having 8 takes 8 byte in the memory, and it ranges from 2.3 to the power minus 308 to the 1.7 to the power 308, and it takes the values up to 15 decimal places, right? And talking about long double takes 10 bytes of memory in our memory space, and its range will varies from 3.4 to the power minus 4932 to 1.1 to the power 4932, and it takes up to 19 decimal places. So that was pretty much it about the primitive data types. Now here comes the derived data type or the aggregate data types. Arrays are aggregate or derived data types that derived from the primitive only. And let's see what it have to say. And array is a C language. Array in C language is a collection of similar data types. That means an array can hold a value of particular data type for which it have been declared. That means array is a collection of memory, and it can store only a single type of data type. That is, either it would be storing only integer type of values or character type of values or float type of values. That's what this line means, particular data type, right? Array can be created from any of the C data types, any of the primitive C data types, right? And pointer C and derived data types may there are also pointers comes under derived data type, and we'll be studying out pointers in deep in the upcoming videos. So let me just give you a bit of introduction in this video. C pointers is a special variable that can be used to store address of any of any of other variable. So pointers are those variable who store address of different variables, right? Suppose I declared a pointer of int type, so it would be only storing address of another int type variable, right? So that was about derived data type. Moving on to enumerated data type, right? So enumerated data type is a user defined data type, as we have seen in the flow chart, that enumerated is a user defined data type having finite set of enumerated constants. The keyword enum is used to create enumerated data type. That means to create a enumerated data type, we have to start the variable with the keyword enum, right? Enumerated data type contains of name, named integers, and constant as a list, right? It can contain named integer as well as lists, right? It starts with 0 by default, and value is incremented by 1 for the sequential identities in the list. That means if we are having similar identities, the counter will increment by 1, right? That what this line means, right? The syntax is simple: enum data type, whatsoever data type we want to declare, and then the list of the variables which we want to declare, right? Here is a example of enum data type, that is enum months. Here we are declaring one type of data type, and month must be created by the user before, because a month is not any primitive data type. So month must be a user defined data type, which user must have defined in his program. So enum month and the list of the month, right? So by writing this, what we are doing, January, February, and March variable will be assigned to 0, 1, and 2 respectively by default. That means these variables will be defined a value of 0, 1, and 2 automatically, right? So that's what enum data type do, right? And if we want to start our data type from 1 or any other value, here we can see in example, we can simply define or declare the first variable, and the counter will move on according to it. Like in this example, January is starting from 1, so February will be storing 2 and March will be storing 3, as you can see here. So yeah, that was pretty much it about enumerated data type. Now moving on, type defined data type. Basically type define is once a variable is declared of another data type, and then we can write a name, and we can transfers all its property to that particular type or the name which we have given. So let's just read and see. It will give you a better vision or clarity about this, right? It is used to create a new data type, but it is commonly used to change the existing data type with another name, as I told you, to give another name to the existing data type, right? So the syntax is type define data type and new data type name, or should I say the name we want to transfer all its property to. For example, in example, we are transferring all the property of int to the new name integer, right? So what we have done, type define int integer. Now, if we are writing int, it will be like now if whenever we'll write integer, it will be treated as int only, right? So this is the example. I hope it gave you a clear vision or clarity about type defined data type. So yeah, that was pretty much it about data types. And in next videos, we are going to study about inputs and outputs. And yeah, thank you everyone. Hello everyone, welcome back to First Mentor. And I believe in previous video we studied about data types and everything about data types. And yeah, and in this video, we'll be studying about input and output. That means how to take input and how to give output. But before moving on to the input and output, we have to study about header files because they play a very important role in taking input and giving out outputs, right? So let's just go through these points and see what they have to say. A header file included at the top of any C program. That means a header file is always included or is present at the top of any program or any C program, right? In second point, it's we are given the syntax of the how to include the header file. It's like hashtag include the file name. We'll be studying what kind of file names are present, but just remember we have to use hashtag include to include the header file, right? So coming on to the next point, all header files have .h extension that contains C function declaration. That means every header file is having a .h extension after the file name. It shows that we have to include this file from the header directory or header preprocessor directory, right? So coming on to the next point, header files are imported into C program with the help of preprocessor hashtag statement. That's what I said, that preprocessor hashtag statement is important because it helps in including or importing the header file into our program. So yeah, moving on to the next slide. So these are few header files, as we can see, like studio.h, which help in taking input and output functions or writing input and output functions. Ponyo.h, that is console input and output functions. Math.h, which help us in including all the available math function in C program. And time.h, which helps in including date and time function. String.h helps to include string functions, and standard live.h, which include all the standard or general utility functions from our preprocessor or header directory, right? Complex.h, a set of functions for manipulation of complex numbers, and ctype.h, character handling functions, and assert.h, diagnostic function. So I believe that was pretty much it about the header files. And now moving on to the next slide, coming to the input and output. So as we studied in the previous slide that studio.h is very important function or header file which we have to include to take input and output functions or to include input and output function in our program. So just remember, whenever we are writing our program, we'll always include or we'll always write hashtag include studio.h so that we are able to take input and able to give output from our program, right? So coming on to this slide, input and output, generally we use scanf and printf. scanf we use to scan the variable or scan the value from the user side, and printf we use to like print the value of the variable from our side. So let's just see what they have to say. Input statement scanf. Scanf is used to give data type. Scanf is used to give data to variable using keyboard. Scanf work very well when the viewer's input has no space. That means scanf we use, as I told you, we used to like take input using scanf function, and it works very well when there is no spaces available in the like input provided by the user, right? So coming on to the output statement, printf is used to give the output. Printf is used to show the result of the program through the display device. That means on the device of the laptop or screen, right? So that was about scanf and printf. Moving on to the next slide, gettys and puttys. I believe those are these two are used to manipulate string or take string. Let's just see. Input statement gettys statement gettys function accept entire line of input from the standard input device, that is keyboard. Like it can take a complete line of input. That means if it is having a spaces in it, it can also take that complete line as an input. Using gettys we can do this, right? Output statement, it is like puttys is used to use in the output statement. It is complement of the gettys, right? Gettys takes the input, so puttys just gives the output. It displays a string on the standard output device, that means on the laptop or on the screen of your PC, right? Moving on to the next slide, scanf and gettys. uh, we are just comparing scanf and gettys in this slide. So here these are the things about scanf. Let's just read them. Cannot read multiple word string, such as computer programming is it's read only computer. Like suppose if we are giving input as computer programming, like we are giving a string as an input to our program, that is computer programming. So scanf will only read computer. It will not be able to read the whole line, that is computer programming. It will consider space as the full stop. That means it will consider the word only till here, because it considers space as like termination of the string, right? Scanf terminates its input when it encounter a blank space, such as space, tab, new line, or like fault feed and carriage return. As I told you, that it terminates the input whenever it encounters space, tab, or new line expression, right? So let's just read about gettys. Overcome the disadvantage of scanf. We use gettys so that we can have a complete line as an input. That means we can also take a string as an input which is having space in it, right? It can read any string length without any number of blank space. With any number of blank space, that means it could be having any number of blank space. If we give input as a computer program and we take input as input using gettys, we'll be able to read the complete like computer program using gettys, right? So moving on to the next slide, these are few examples. Like let's just go through them and see what they have to say. So first example, like we have included the studio.h so that we can take the input and output, and include conio.h so that we can console the input and output. You just have to ignore because it's the declaration of array and we have not studied array yet. So we can only focus on these input and output lines, right? So by printf, we are displaying this string on the output device, that is screen of the laptop or PC. And by using scanf %s, we are able to like scan the input given by the user, right? And here and subject we are writing, because we want to like this says that whatsoever the input we are writing or we are getting from the user, just write it in the address of subject. Like whatsoever value we want to store, we will write in the address of the or the like memory allocated in this address of subject, right? This is what this and subject means, right? So we can see the output, sorry, we can see what will be the output of the first program. Enter subject name, computer programming, and your name is computer. So that means scanf is only able to read the computer and not the complete line, that is computer programming, right? So now moving on to the next example, again they have included two header files, that is studio.h and conio.h. Studio.h to take the input and give the output, and conio.h to console the input and output, right? So again ignore this declaration because it's an array declaration, and we will just focus on these three lines, that is printf, getis, and printf and putis, right? And let's see what it have to say. And like again we are printing the line, enter the subject name, and then we are taking input in the subject, and getis takes the complete line as an input, as we have discussed before, with any number of blank spaces. That means if now the user would be inputting computer programming, so it will be taking the computer programming as whole input, right? So your name is Potes, like Potes is used to print, right? So that was pretty much it about the taking input and giving output. So yeah, I believe it is clear to you everyone. And now we'll meet you in the next video. So yeah, thank you everyone. Hello everyone, welcome back to First Mentor. And in previous video, I believe we studied about data types, and I hope it was clear to everyone. And in this video, we'll be studying operators and type of operators, and we'll be seeing few practical examples. I'll be typing code on IDE, and we'll be seeing how to type or how to use operators on IDE. So I believe we should start now. So operators, the symbol which are used to perform logical and mathematical operations in a C program is called operators, right? So the symbol which are used to perform like logically or mathematical operations like addition, subtraction, or multiplication, those are called operators, right? The C operators join individual constants and variable to form an expression. Basically, they are used to join constants or variable to form an expression, right? Operators, functions, constants, and variables are combined together to form an expression. Functions, constant, variables, and operators are combined together to form an expression. So that was pretty much it about the theory of operators, and I believe it gave you a clear vision about operators. So now moving on to the next slide, type of operators, and here we have bunch of types of operators, and let's study one by one. Arithmetic operators, as the name says, arithmetic, like in this I believe addition, subtraction, multiplication, all that stuff could be done using arithmetic operators. And let's see, perform mathematical calculations like addition, subtraction, multiplication, division, and modulus. So for those who don't know like what modulus is, it's used to like determine the remainder of a division, right? Coming on to the next operator type, assignment operators. Assignment operators are generally used to assign values to the variables, right? Relational operators, these are used to determine relation between two variables, or should I say compare two variables, right? Moving on to the next, logical operators perform logic operations on the given two variables, right? Bitwise operators. So bitwise operators are very important operators, though we do not use a lot of bitwise operator in our program, but it's good to know what bitwise operators are, because they perform operations directly on the bit form of the constant or stored value in the variable, right? So that we do not have to like convert the constant or the value to the bitwise form and then operate the operators. It directly operate on the bitwise form, right? Conditional operators, conditional operator, as the name says, like depends on the condition. If a particular condition is true, then a like uh, particular output will be given, and if that is not true, another output will be given. Increment and decrement operator, as the name says, it is used to increment or decrement a particular variable, and it increase or decrease the value just by one. Right? Special operators. In special operator, we have an ampersand operator. It is used to like get address of a particular variable. Star operator, it is used to like denote pointers, right? And size of variable is used to like determine the size of a particular variable. And ternary operators, like similar to the conditional operators. So now moving on to the next slide, let's study a bit more about arithmetic operators in C. So arithmetic operations are like addition, subtraction, multiplication, division, and modulus. Like addition is given by plus sign, minus sign, and multiplication is written by star sign, division by slash sign, and modulus by like percentage sign. And this is how we denote them, right? So I believe just like seeing few examples on the slide would not be enough. So I believe I'll be showing you and typing the code in the IDE so that you'll be able to get a better vision or better idea that how to type code or how to use operators in IDE, right? So as I have told you how to declare a variable, I am declaring int type variable, two int type variable A and B, and let me also show you like how assignment operator works. Like it's just use equal sign, and we are able to assign value to the variable. I have assigned 10 and 15 to our A and B variables respectively, and now I'm gonna make another variable name as addition or add equals to A plus B. Here we are doing addition of A and B, and remainder, I am writing remainder as REM and doing B remainder A. As I told you, modulus operator percentage sign is used to determine that, right? And let's say multiply. I'm just using let's just write multiply. Yeah. So let's just try to print and see what they print. Printf addition, and here we have to write percent d as well. As I told you, like in the previous video when we were talking about input and output, that for integer value we have to write percent d, and now we'll be writing add here, and it will print add printf, let's remainder percent d and rem. Just a second, guys. Yeah. So I'm printing multiplication also. Percent d and 1. Right. So I believe these will be able to show the output. Let's see if it works or not. So as we are able to see like hello world, I believe, yeah, it just commented out, and run it again and see what's the output. Like we can see addition as 25, that is 10 plus 15, 25, that is correct. And remainder, if we do like 15 divided by 10, remainder would be 5, right? And if we do 15 multiplied by 10, the answer would be 150. So we are getting the correct answers. So this is how we do use arithmetic operators in our IDE. Now moving on to the next slide, assignment operator. Okay, talking about assignment operator, we have seen this equals assignment operator, And like plus equal assignment operator is basically used to add uh, the value present in the RHS that is present here to the value present in this variable. Like suppose if test is storing a value 5, and like we just have to add this 10 in the 5, and we'll be getting the answer as 15. And we can also conclude it like this, like if test plus equal to 10, then this is same as test equal to test plus 10, right? Minus equal to similar as plus equal to, this can be same as test equal to test minus 10. Multiply equals to test multiply equal to 10, it is same as test equal to test multiply 10. And with divide equal to as well, modulus equal to as well, and ampersand equal to as well, and like this and is bitwise operator, and this is XOR operator. Like the XOR operator will be studying that in bitwise operators, right? So now moving on, relational operators. So relational operators are used to find relation between two variables, as I have told you before, that is to compare the value of two variable in C program, right? So here we have bunch of like relational operators, greater than, less than, greater than equal to, less than equal to, equal to equal to. This is like to compare two values are having equal values or not. Not equal to, that means to compare if the two variables are not having the same value. So I'm not showing these on IDE because we'll be using these mainly with if and else condition or flow control, and we'll be seeing that in upcoming slides, right? So now moving on to the next slide, logical operator. So logical operators are like and. So I believe since you all are in big classes, and like you must come across and or and not operators, right? So in and, both the conditions like before and after and have to be true to return a true value. As we can see in the example, a greater than 5 and b less than 5, to for this expression to return true, this is only possible if a would be greater than 5 and b would be less than 5, right? And for in case of or, like any one of the condition can be true and it will the expression will return true, right? If a is greater than equal to 10 or b is greater than equal to 10, any of the expression like calculated as true, this complete expression will return true, right? Not operator. So we can use not operator with and or operator also, and you can see in the example that not, if like if this value, this complete inner expression returns true, then this not will turn that true to false. And if complete inner expression return false, then this false will be turned to into true using this not operator, right? And similarly with or operators also. Right, now moving on to other slide, bitwise operators. So these operators are used to perform bit operations. Decimal values are converted into bit values, which are sequence of bits, and bitwise operators works on these bits. Right, followings are the bitwise operator. So as I have told you that they convert the value into bits, and then perform bitwise operators. And there are 6 bitwise operators, that is bitwise and, bitwise or, bitwise not, bitwise XOR, left shift and right shift. We'll be studying more about them in upcoming videos or in upcoming course. So you do not have to stress about like what they are and what where we have to use. We'll not be using a lot of them, but it would be good if you are having knowledge about them, right? So moving on to the next slide, conditional operator or ternary operators in C. It is very important, right? Because we'll be using it a lot depending on the condition, or to provide condition or make our program more dynamic, right? So conditional operator return one value if the condition is true and return another value if condition is false. Like as I've told you that it return value depending on the conditions, right? This operator is also called a ternary operator, right? So syntax is here, like we just write condition and question mark, and then if the value is true, this value will be returned, and if the value is false, this value would be returned. For example, a is greater than 100. If this is true, if this is evaluated as true, then 0 will be returned, and if this is evaluated as false, then 1 would be returned. So that was pretty much about conditional operator. In previous videos, we studied about operators and we saw a few examples also on IDE. And now I believe we'll be studying about flow control. And flow controls are those statements or those things which help us in maintaining a flow of our program, or like depending on our will and depending on our wish, like in what way or in what statement we have to like use what things and how many times we want to use a particular statements. So those all things which help us in doing these things are will come under flow control. So we'll be studying about if and else statements. We'll be studying about loops, and if I talk about loops, we have three loops, that is while loop, do while loop, and a for loop. We'll be studying about them in details. And moving on, we have break and continue statements, and we have switch statements, and we have go to statements. So we'll be studying about all of them in details in flow control lectures. And so I believe now we should get started. So first topic, if and else statement. If and else statement, as the name says, these are those statements or those things which help us in executing few operations or statements according to the conditions. So let's just go through this point and see what it have to say. The if statement is used to conditionally execute a statement or a block of statements. That's what I said, that depending on a condition, it will execute few statement or block of a statement. That means a bunch of statements, right? Condition can be true or false. Execute one thing when the condition is true, and something else when the condition is false. So if you remember in operators lecture, we studied about the conditional operators. It is something similar like that, right? So in just in this, we separate the conditions by using if and else statement. We can like use multiple ifs, and we can use if separately, but we can use else only when we are using a if, right? We cannot use else without using an if, right? So moving on to the next slide. If we talk about syntax of if and else statement, it's like if, then the expression which we need to evaluate, which will be evaluated as true or false, and depending on that, like true or false, this statement will be executed. If and only if this expression will be like calculated as a true, right? Well, when this expression will give us true, then this statement or block of statements will be executed, and otherwise this else statements will be executed. So that's what I was saying when I was saying about like conditional execution of the statements, right? So moving on to the next slide. Multiple if and else statement. We can have like multiple if and else statements, like if expression one which we want to evaluate as true or false, and if it is evaluated as true, then this statement one will be executed, and if this is like evaluated as false, then we'll move to this if else else if statement. And in else if there is one thing that we can give a condition as well. If we just use a simple else statement, we cannot give any condition to that else statement, right? But if we use else if statement, we can give like an expression to evaluate in its bracket, right? If this expression is evaluated as true, then this statement will be executed, and so on. But remember, in the end, we have to like put a else statement, so that if all the conditions like all if and else if conditions are false, or statement will be evaluated as false, then this statement will be executed, right? So this was pretty much it about the if and else statement. Let's just move to the IDE and see what we can do using if and else. Let me just clearest bit, like, so that you can all have a clear vision of the IDE, right? So I believe this was the code which we used in previous operator section. So I believe we can use these statements in this also, right? So we all know how to like declare a variable. We have declared two variable, a and b, and we have simply like given a value by using assignment operator, and b a value by using assignment operator again. So now what we can do, let's see if both of them are equal. We'll be simply printing both the values are equal, and if they are not, then we'll be simply printing both the values are not equal, right? So how we can do it? I believe by using if statement we can simply do it. And when we studied about relational operators, we studied about this equal sign also. And this equal sign tell us whether the expressions on the LHS or the value on the LHS is equal to the value on the RHS or not, right? If it is equal, then it will return true, else it will return false, right? And we'll simply print both the values are equal. And if this condition false, then we'll be entering this in this else block, and in this will print both the values are not equal, right? So that's how this if and else works. Let's see what it shows when we run our program. So it shows both are not equal, which is true because A is 10 and B is 15, which is not true. So let's see if both of them are 10. Will it print both are equal or not? Let's see. So as you all can see, it is printing both the values are equal. That means it is working fine. And yeah, that was pretty much it about if and else statement. And let's just try to make like two like multiple if and else statement and see how it will work. Just make variables and take input for from the user, right? And I'm making three variables, or just take one variable, right? That would be sufficient, right? And what I will be checking in this, I'll be taking input of this variable scanf. As you all know, we use scanf to take the input, and then %d for the integer value, and then the variable, and then comma, and then the variable in which we want to store the value, right? Now what we'll do, let me just comment it out first. Now what we'll do, we'll check if this a is equal to 0. Then what we'll do, we'll simply print the number is 0. Printf num is 0, right? Else if a is greater than 0, then we'll print the number is greater than 0, or should I say we have a positive number, right? And else if both are not the situation, that means it will be just it will be a negative number. So we'll simply print we have a negative number, right? We have a negative number, right? So let me just tell you, in this ID we just have to put in the input here, and it will scan automatically, right? Let's see, I just have inputted 5, and let's see if it works or not. I was doing a mistake that I was using ampersand here, though I was supposed to use ampersand here. So like we all like know we can do like syntactical mistakes. So let's see if it works now or not. Okay, so it shows we have a positive number. That is correct. That means our code is working fine. Let's see if it works for 0 or negative value also or not. Okay, the number is 0, which is correct, and let's see if it's able to detect the negative number or not. And then and we have a negative number, so that means it is working fine, and you all get an idea that how to use if and else statement in our program, right? So that was pretty much it about if and else statements, and we'll meet you in next video. Thank you everyone. Hey everyone, welcome back to First Mentor. And in previous video, I believe we studied about if and else statements, and also saw some examples on the IDE, right? So in this video, we'll be studying about loops. So this video will be divided into two parts. First one would be the loops introduction, and we'll be studying a theory about theory and its theory. And in next video, I'll be showing you practical example of the loops and show like coding them will be coding them on the IDE, right? So let's get started. Loops like statements in program are executed one after other. As we know that in our program, statements are executed sequentially, but sometimes the user wants to execute a set of statements repetitively. But there could be like certain possibility we want to repeat, or we want to do a particular thing again and again. So in that case where loops come into the role, because we cannot like write those statement that many number of times or till the condition satisfied. So that's why we use the like we take the help of loops, right? So loop statements are used to repeat the execution of statement or blocks. It will be or and like it helps in repeating the execution of statement or block of statements, right? And iteration of loops. Just remember that the meaning of iteration of loop, because we'll be using this word iteration again and again while using the loop. So it means the number of times the body of loop is executed, right? So now moving on to the next slide. Types of loop, basically we have two like by structure wise we have two types of loops, right? One is entry control loop or pre-test loop. Another one is exit control loop or post-test loop, right? In entry control loop, as the name says, we check the condition at the time of entry itself, right? And in exit control loop we like first execute the statement and then check for the condition, right? Let's see pre-test versus post-test. It's the same thing what I have told you yet, but let's just go through the lines again and see what they have to say. Pre-test condition is tested before each iteration to check the loop should occur or not. As I told, like we'll check the condition before iterating over the loop, right? Post test and the condition is tested after iteration to check the loop should continue or not. Like in this, at least iteration will be like least iteration would be of one number of times, like at least once it will be occurring or it will be running, right? And let's see the flow chart. Let's say our program is coming and we hit the condition, right? If this condition will be evaluated as true, then only will execute these bunch of statements, right? And then again we will check for the condition. If it again repeats to be true, then again we'll execute these statements, and we'll be doing so till the time is condition is true, right? When the condition will say false, we'll simply exit the loop, right? And let's see about the post test loop. In this we come to the statements, we execute the statements and then check for the condition. If the condition occurs to be true, and then we again like run the statements, and if it falls, then we simply go through the loop, like exit the loop. So that's what happening in a exit control loop. So now moving on to the next slide. Type of loops, basically we have three type of loops, right? While loop, do while loop and a for loop. Among three of them, only do while loop is a exit control loop. That means uh, the statements are executed first and then we check for the condition in do while loop, right? And while and for loop are entry control loop. So just remember so just remember till now that do while loop is the only loop which is exit control loop, right? And all rest of them are entry control loop. So we'll be studying about the loops more in the next video, and we'll be coding them simultaneously with the explanation, right? So thank you everyone. We'll meet you in the next video. Hey everyone, welcome back to First Mentor. And in previous video, I believe we studied theory about loops and we also studied types of loop. So let's just dive into the type of loops and study a bit more about them. Okay, so starting with the while loop, it is a loop. It has a loop condition that is tested before each iteration to decide whether to continue or terminate the loop. That's what I told, that it is entry control loop. That means in at the time of entry, it is just checking, it is just testing for the condition whether it's true or not. If it's true, then it's continue. Elsewise, it's terminate the like execution of the while loop, right? The body of while loop will execute zero or more times. Like if the like condition tested to be false, then zero number of times, and if it is tested to, then we don't know like how much or how many of times it will be executed, right? So the syntax of while loop is while we write the keyword while and then give the condition and then write the statements which we want to execute till the time condition is not satisfied, right? And what we can also write in this, that after this statement we also do increment or decrement of the decrement of something, right? So let's just come to the IDE and see like how to code them, right? How to code a while loop, right? So this is our ID. As you all know, I'll be coding on the GFG ID, and you all must be familiar to this ID till now. And this is the code of previous uh, like previous video. Let me just clear it off and let's see. So I'll be taking input a number and we'll be printing that number, or running our loop till that number of times. So let's just print a number from 1 to the number what our user is providing us, right? So let's say if user is giving us 5, then we'll be printing the number from 1 to 5, right? So let's just initialize our statement. uh, like what I haven't told in the example, or in the condition, or in the theory of while loop, is that there are three things for the loops. That is a initializer, which we initialize outside the loop in case of while loop, and do while loop also. Let's just say I am initializing my variable with 1, and then we'll type the keyword while and give the condition while I is less than equal to a, will be running this loop. And what we'll be doing, we'll be simply printing if the number, right? Percent d and number is I, right? And after this statement, we'll simply increment the number by 1. We all know that we have studied about the like increment or decrement operators, that is plus plus and minus minus operators. So I'm using that here, right? And it will simply do our job, right? Let's see if it works, and I'll be giving 5, and let's see if it works or not. I believe it will work. So it is working. It is giving all the numbers from 1 to 5, and let's see for 10 also if it works or not. And I believe it will work just fine. So yeah, it's giving all the number from 1 to 10. That means this is working fine. So I believe it gave you a clear vision that how to write a while loop. and what are the things we have to keep in our mind while doing that. So let me just tell you once again, we have to initialize a variable or initialize initializer, uh, or should I say initialization, and after that, after then we have to write condition. Till the time we have to run the statements or run the loop or iterate over the loop and statement. I am just writing S because S is conditional. Like it could be a statement and it could be statements also. And then we have to write the increment or the decrement operator. Right. So this is the basic overview about the while loop. Now coming back to our PPT, and we'll be studying the next loop. We'll be studying about the next loop. Right. Just give me a second. Okay, so studying about a do while loop. Do while loop has a loop condition. Do while loop has a loop condition only that is tested after each iteration. Right, it have only one condition, and that is also tested after each like iteration. Like first, we'll run the code or run the statements, and then we will check for the condition. Right, and iteration to decide whether to continue the next iteration or terminate the loop. First we will run and then we will check the condition whether we have to run it again or not. So this is the basic like syntax of the do while loop. That is, we write the keyword do and then start our do while loop with the curly braces, and then write our statements, and then write the while keyword and the condition in it. Right. So, what we'll do, we'll simply just give me a second. We'll simply try to run this on our ID and see. Let's just go to our ID and see. Let me just comment it out. Comment the code of our while loop and also write while loop code. Right. Now let's write do while loop. Right. So what we are supposed to do again, will be coding the number from 1 to whatsoever number our user will be giving us. Till that number will be printing the numbers, right? So again we have to initialize a variable, that is let's say I again, and we are initializing it to the 1, and then we'll be doing do, writing do, and here we'll be printing our number. And then again we'll be initializing or incrementing, we'll be incrementing the initializer, and then we'll check the condition that whether it's true or not. Right. Again, now we'll be checking this again by running, and let's see if it works fine or not. Let's just see. Yeah, it's just working fine because it's giving all the numbers from 1 till the number which our user is giving. Let's just also try it for a bit of small number and see if it works or not. Right. So I believe it will be working fine. And yeah, so it's just working fine. And this is how we write a do while loop. And now moving back to our PPT and moving on to the next loop. Right. So here comes to a for loop, and we'll be using for loop a lot. So it would be good for you all if you understand it very clearly, so that you will not be having any doubts in it. Right. So in for loop, it have three parts. That is, initializer is executed at the starting of the loop. In while and do while loop will be the initializer was outside the loop, but in for loop it's inside the loop itself. Right, we'll be seeing how. Right, The second point, the loop is tested before iteration to decide whether to continue or terminate the loop. And again, like after initializing, we'll check for the condition whether it's true or not. If it's true, then only we will continue, else we will terminate the loop. Right? Then we will be having increment and the decrement operator to check, like depending on the loop or depending on the question, we'll be doing incrementation or decrementation, right? So moving on to the next slide, we have the syntax of for loop. So we have to write the for keyword, and then we have to write the initializer, then we have to put the semicolons, then we have to write the condition, then again semicolons, and then incrementer or decrementer, right? And then starting with the curly braces, and inside the curly braces of the for loop, we will write the bunch of statements or statement which we want to execute till the condition is satisfied, right? So this is the basic syntax of for loop, and we'll see the flow chart of for loop as well. Let's see, our program hit the uh, like loop, and then we will be initializing a variable, and then we'll be checking the condition. If that turns to be true, then we'll be executing the statements, and then incrementation will be taking place, and then again initializing and checking the condition, and so on. If the condition returns to be false, we'll simply exit the loop, right, or terminate the loop. Let's come to the IDE and see how it works. Right, just a second, let me increase my size of the screen so that it will be giving you a clear vision. Let's just comment the code of do while loop and for loop code, right? So again, we'll be taking input from the user, and we'll be printing the numbers till that number, right? So here this is how we are initializing. We declared a variable, and then we initialized it to a number. Let's from here I am initializing it with 1, and then we check for the condition, and then we increment the our number or our variable which we defined, right? And simply print the number, and this will do our job. And this is having the least amount of code, as you can see, among all the like loops, and till the time I was saying, it have gave us the output, and you can see it's giving us the correct output. And let's run for 10, and it should print all the numbers from 1 to 10. And let's see, and I was saying that it is having the least amount of code among all the loops, and it is easier also. So I would prefer, depending on the condition, we should use the loops, and we can see it's running fine. It's printing all the number from 1 to 10. So that was all about loops, and I believe it gave you all a clear vision about the loops. So yeah, thank you everyone, and we'll see you in the next video.
Hey everyone, welcome back to First Mentor, and in today's lecture we'll be studying about break and continue statements. And if we talk about break and continue statements, these statements come under the flow control. That means they help us in maintaining the flow of our program. So let's get started and let's just go through these points, right? So break cause immediate exit from while, for, do while, or a switch structure. We'll be studying switch structure later on, but for now you can like consider it as like a bit similar thing like if and else conditions, right? So break causes an immediate exit from these things, right? That means it immediately terminates the program or terminates the loop, right? Program execution continue with the first statement after the structure. We can consider here structure to be a while, for, do while, or a switch structure, right? And when the break hits the program, then they just terminate that structure and continue with the first statement, after that structure, right? So common uses of break statements are to escape early from the loop, right, and to skip remainder or remaining cases in a switch structure. Don't worry about like what cases are there in switch structure. We'll be studying switch structure later on in the course, right? And you'll be getting an idea why we use break in there, right? So now moving on to the next slide. So this is a basic diagram or basic pseudo code where we are able to see like how we have to like use break here. Like this is a structure of while loop. While we all know like how to like use while loop, right? So this is while loop condition, and then after inside this while loop we are giving a if condition, and if that condition becomes to be true, we simply breaks the code, and when it breaks the code, it came out of the loop, and whatsoever written in here, it will start executing from this statement onward, right, till the end of the program. So this is how break works. It just terminates the structure. This we can consider as a structure of while loop, and since it is hitting break inside the while loop, so it will just skip this while structure, the structure of while loop, and will continue like execution of the program just after that while loop structure, right? So that was pretty much it about break statement. Now moving on to the next slide. Here we have continue statement, right? Continue statement do what? It simply uh, skips the breaking, or should I say like skips the moving on process, and like uh, let's just go through this example first, and we'll be giving a clear vision. You will be having a clear vision about it through this example. So this is a structure of for loop. So in this, what we are doing, we are running our loop from 1 till it's less than 9. Sorry, it's less than 10, and simply incrementing. You all know how to like write a for loop, right? So it's the structure of for loop, and in this we are writing a statement. Do this by writing do this, we can simply assume that we are writing or printing something, or doing some operations, right? And if this conditions occur to be true, what will be happening? Instead of moving forward in the loop, it will just simply return from here to the starting point of the loop. That means we will not move after this continue statement. Whenever the continue statement hits, we simply return to the starting point or the initial point and start executing again. Till the time it's not true, we'll simply check this condition, and if it's not true, we'll move on with the statement, execute this, and then go back to the start. But if this statement is becoming true, we'll simply like hit the continue statement and return from here itself, and we'll start executing from the initial statements again, right? So we have an example of continue statement. You all can see like studio.h and conio.h we have included in our header files, and we all know like why we include these two header files, right? Then here is a main function, and we all know like the compiler starts reading the main logic of the program from main function, and inside this, let's see, we have like declared a variable j, and CLR SCR is just used to clear the screen or the clear the console. Right now we have a for loop structure, and in this we are running from 1 till 50, right, and doing increment of j, right? So what we are doing in here, if j modulus 5, what we all know like what modulus do. Modulus simply divide the numbers and returns the remainder is not equal to 0. That means if j is not a multiple of 5, will simply continue. Continue like will simply hit the continue statement, and will simply start iterating from the starting point again, right? Else what we'll be doing, will printing the j, right? And here slash n means new line. Backslash n is generally used to say compiler, hey, print everything on the new line, right? So this is what happening in this loop, and this was a like working example of a continuous statement. I believe you should all try this to code by yourself, and I believe that was pretty much it about if and uh, continue and break statements. So we'll meet you in the next video. Thank you, everyone. Hey everyone, welcome back to First Mentor. And in today's lecture, in today's class, we are going to study about switch cases. And if I talk about switch cases, it's another type of flow control statement which help us in maintaining the flow of our program. That means we can make decisions for multiple cases in this using this switch cases. It is we can imagine it to be similar as if and else condition or if and else statements. So let's see what these points have to say, right? So switch cases allow us to make decision for multiple choices, similar as if and else condition, if and else statements. Just in it's a bit different in terms of syntax and orientation. We'll see how it is different, right? So it is doing nothing but allowing us to make multiple decision for multiple choices, right? Next point, integer expression must yield an integer value like 1, 2, 3, etc. The key case is followed by a the keyword case is followed by an integer or a character constant, right? So whenever we are putting in expression in the in case, then that expression should must yield an value, and that should be a constant. And we always use any constant that could be integer or a character in front of our case keyword. We'll see where we use case keyword, because I haven't showed you the syntax of this switch cases. So remember this point, that we have to use a constant in front of uh, keyword case, in front of our case keyword, right? So moving on to the next point, each constant in each case must be different from the other case. That's like, you should not use the same constant for different cases, right? Then the compiler will get confused that in what case you have to run which case, right? Or which statements, right? So moving on to the next statement, break is always used with the switch statement to terminate the switch statement or to prevent entry in the other cases. So this statement says that using break in switch cases is mandatory, so that we can prevent entering into different cases, or so that we can also terminate the switch case after running our after running the particular case, or the case which is favorable for the condition, right? So moving on to the next slide. So it's the syntax, or we can say overview of how we use switch cases. So let's see, we suppose we are getting a variable from the user, or you have defined it by yourself, or assigned the variable by yourself, right? But generally when we'll be making our program dynamic, we'll be taking input from the user. So assuming that you have taken in input from the user, right? And that integer have stored in this variable named role, right? Now how we will write switch cases, first we have to write the keyword switch, and then the brackets, and we have to write the name of variable in the brackets, right? Which we are taking input from the user. After that we will start from the curly braces, and here we have opening curly braces, and here we have closing curly braces. So remember that we have to put in the curly braces, every case will be the cases which we want to write will be inside these two opening and closing curly braces, right? So after this, the like program will jump to the case, and since here we have assigned 3 to the case, so that means it will check case, as I've told you, we are using the word keyword case, and after that keyword we are writing the number. And this number is not a serial wise number, that this is case 1 or this is case 2.
This represent the possibility of inputs which user can give, right? So this is one possibility that user can give one, and in that case, the our like program will printf I am Pankaj, right? That means it will just like show the output as I am Pankaj, and after that it will terminate the program, right? If we will not write this break statement here, what it will do after this case will be true, it will not check for the other cases, it will simply execute all the statements written in these cases. So that's why we write this break statement, right? This is the importance of the break statement in this switch cases, right? So first possibility is of getting one, second possibility is of getting two, right? In two it is like we are just showing I am nickel, right? And then break. Just remember, this is the like syntax I am showing you, right? So after every case, we are using semicolons, sorry, colons, and writing the statements which we want to execute. Here we are just printing out, right? And in case 3, we are printing out John and then breaking. In case if both the like all the cases fails, right, there we have to give a default case. It's not important that we have to give a default case always, but it's like considered a good thing to give a default case, so that like if we, like the same thing we do in if and else statements, that we are writing multiple if else statement, then we what we used to do, like if then else if, and used to give conditions in all of them, and if all the conditions fail, then we used to just execute a simple block in or simple statements inside the else, right? So similarly we are using default here, and then again colon and printing no student found, and then break and coming out of the loop. You can just remember that in the default, it's not important to write break, because we are generally writing default in the end of the switch cases. So if this default becomes to be true, it will simply terminate after like printing this, it will come out of the loop, it will be not executing some other cases, right? So that was the like uh, syntax or how to write switch cases. Now moving on to the next slide, and there are some more points which we have to remember, and let's just go through them. If there is no default in switch, then error will not be there. If no case is matching, the statement after switch will be executed, right? So as I told you, like default, it's not a mandatory case which we have to write in our switch cases, but it's a good practice to do, right? If in case suppose we are not writing default here and all of the cases fail, so what the program will do, it will come out of the loop, sorry, it will come out of the switch cases and execute first statement which is written after this switch case, right? So moving on to the next point, relational expression like I greater than 5 are not allowed in any case. So we can only give constants in case, like in front of case or beside case, right? We cannot like use expressions in the condition part, right? Even float values are not allowed in any case. Just remember, even float are not allowed. We can only use constant, like integer constant and a character constants. Moving on to the next point, we can check the value of any expression in a switch case. Thus, the following switch case are legal. We can check the values inside the switch brackets, right? Not in the case, right? That what it means is like we can write an expression here but not here, right? Here you always have to give a constant, but you can write an expression in this like brackets. Okay, so that was pretty much it in these points. So you can see like these are the expressions, they are showing through the examples that you can write these things in the switch cases. And so I believe, yeah, it gave you a like clear vision about switch cases. So now moving on to the next slide. uh, okay, switch versus if else ladder. As I told you, switch is similar to if and else statements. We can assume it to be similar as if and else statements. So now let's just compare them and discuss the disadvantages of switch over if and else, right? First point says a float expression cannot be tested using switch, as written in the previous slide, that we cannot use a float expression inside switch, right? And moving on to the next point, cases can never have variable expressions, right? In cases, we always have to use a constant character or a integer. For example, it is wrong to say case a plus 3, but in if and else, we can check this condition, right? So moving on to the next point, multiple cases cannot use same expressions. We cannot like use same expression in multiple cases, as I have told you before in previous slide. Thus, the following switch is an illegal. Like we can see in the example that switch I and case 2 and case 1 plus 1 will not be considered because it will evaluate to be 2, right? And we cannot use this like we cannot use the same values, right? So now moving on to the next slide, advantages of switch over if and else, right? uh, Compiler generates a jump table for a switch using compilation, right? So a jump table is produced while like compiling the switch cases. As a result, during execution, it is simply refer to the jump table to decide whether case should be executed rather than actually checking whether case is satisfied. Like we can simply assume it to be a table in which on one side we are just putting in the values, and like and on the other side we are putting in the statements which we have to execute if that number matches, right? So this is what we this point is saying, that we can simply assume it to be a table, and like the compiler assume it to be a table in which LHS in on which like in on which like in table on LHS, like compiler puts the constant values which we give in case, and in front of that those constant values it just write the statements which it have to execute in case it like any similar case or constant is found. Moving on to the next point, as against this, if and else are slower because they are evaluated at the execution time. Since there are no expressions we are writing or allowed in the switch cases, so they are a bit faster than if and else, because in if and else we are allowed to write expressions, and those expressions are executed or evaluated at the time of execution. That's why if and else are a bit slower than switch cases, right? So moving on to the next point, next slide. So yeah, that was pretty much it, I believe, about switch cases. And so yeah, thank you everyone. We'll meet you in the next video.
Hey everyone, welcome back to First Mentor, and in this video we'll be studying about go-to statement. It's another flow control statement. That means it also helps us in maintaining the flow of our program according to our will, right? So let's just go through these points and see what they have to say, right? So the go-to statement is provided an unconditional jump from the go-to to a label statement in the same function. It is saying that the go-to statement just provides us a jump from label to the point where that label is pointing to, like from go-to to the label, and that label could be anything. So moving on to the next point, syntax, right? Go to, we just write this go to and then label, and then label is like this. We write label, then colon, and then statements which we want to execute, right? So moving on to the next point, here label can be in any plain text except keyword, and it can be set anywhere in the program above, below to the go to statement. That means we can set like this label statement either before the go to statement or after the go to statement. It totally depends on our willing and where we want to set, or what how we want to use the go to statement, right? So moving on to the next slide, we have a flow chart of go to statement, how it works. So suppose our program is coming and we hit our statement, and from this statement we have a go to like jump or flow control statement, and in this jump or go to statement we are totally like we are straightforward jumping to the label 3, right? So what we'll be doing, like we came to this statement, and in this statement after this we have a go to statement. After hitting the go to, we'll simply jump off to the label 3 and we come here and simply like executed this statement and then simply terminated the program. So we skipped this label 2 statements, right? So this is how the go to uh, like go to statement flow of go to statements works, right? So now moving on to the next slide, we have a code example for go to statement. We can see like we have studio.h to take inputs, and int main we are declaring a variable, then we are like taking a variable input from the user, then we have a start label with colon, and then we are printing like the a in the new line and then incrementing the a. If a is less than 10, then we just simply like do go to start, right? Till the a is less than 10, we will be simply hitting this go to statement, will be reaching this statement again and again till a is not hitting the value 10, right? So this is how it will be working. Like we coming here, we scanned the input, we compiled this and we hitted this statement. Remember this print and this additional add function will be running only when this go to will be calling it, right? Else it will be just compiled, it will not be run before calling it, right? So when we hitted our a like less than 10, we simply called our go to statement, we went here, then we executed the statement and then incremented a. Again the process happened till the time a is less than 10, right? So that was pretty much it about go to statement, and thank you everyone, we'll meet you in the next video. Hey everyone, welcome back to First Mentor, and in today's video we are going to study about functions and type of functions, function types. Just do not like think that these two are same thing, because in type of functions we are gonna study like what type of functions C programming language offers us, and in functions type it is like something what value do a like function returns and like that. And then we are gonna study about scope rule, and then we are gonna study about recursion or recursive functions, right? So let's get started. Functions. A function is a block of code which is used to perform a particular task. Like it is a block of code in which we define like what kind of task do we have to perform, right? And next point, instead of doing a task particular, like doing a particular task several times, you can write these line inside a function and call that function every time you want to perform that task. Like you can like as the point say that like it is like do not like we can use the function so that we do not have to like repeat a particular task or repeat a particular code again and again. We can simply like make that code encapsulated or written inside a function, and we can call that function whenever we need that, like or several times. You like might be some of you having a doubt that we can also use loops for this to like repeat a particular line several times, but here is the catch that functions we do not like do like call on these lines again and again in the same part of the code, but we do like calling those particular lines or bunch of code at different part of the code. That's why we use
or we prefer to use functions here instead of using loop, right? So moving on to the next point, this would make your code simple, readable, and reusable. Like by reusable, we means we do not have to write that particular piece of code again and again. Readable, we can simply read those line once and we can understand what a function will be returning. And simple, obviously, like we will be reducing the repetition in our function, right? So now moving on to the next slide. Types of functions, library functions, that is built-in functions, and just a second. Yeah, I believe I just have uh, swapped the slides. This was the slide which I used to show you first. Like here you can like ignore C++. It's you can simply it to be C, because C and C++ are like subsets of each other. So they both have same type of functions, right? So one is built-in functions and another one is user-defined functions, right? So as the name says, built-in functions are those functions who are already like present in a C language, and user-defined functions are those functions which are defined by user, right? So moving on, uh, built-in functions. These are written in the header files. When we include header files, we are easily able to access those built-in functions. To use them appropriately, header files should be included. Like as I told you that they are included using the header file. So these are the header files and these are the functions we can use. So by using studio.h, we can simply use printf, scanf, like you have used already, like these functions, and these are used to scan and print the particular value or string, right? Get character, put character, also used to like get character and put character, get as, put as, f open, f close. These are few like built-in functions which we get with studio.h head file. And conio.h, we have clear clr scr to clear the scheme and to clear the console, to be particular, right? And get ch and C type dot h, with this header file we get two uppercase, two upper. This convert the lowercase to the uppercase, two lower to convert uppercase to the lowercase, and is alpha. You can also like search about the functions to get to know more about them, right? And it will be like more knowledgeable for you when you search it by yourself. You will be like getting more knowledge about them, right? So then we have mat.h file, and with that, with this we have pow, square, cos, log function, and then we have standard live .h function, std lib.h function that have rand and exit, and then we have string.h, and with this we get the functions like strlen, strcpy, and strupr. So these are few like built-in functions we are getting in C++. So now moving on to the user-defined functions. So if I talk about user-defined functions, in user-defined functions, like as I told you, these are the functions which are defined by the user, right? So moving on to the next point, elements of user-defined functions are like there are few key elements which are there in user-defined function. First one is function prototype, that defines what type or what kind of the things that function will be returning, right? Uh, and then we have function call to call the function, obviously. And then we have function arguments and parameter. Arguments are those things which are getting passed in inside the brackets of function. I'll be showing you in the code and in like upcoming slides also what are arguments and what are parameters, right? And then last point, we have function definition, like when that function is called, like what things it would be doing, that comes under the function definitions, right? So now moving on to the next slide, function prototype, right? It specifies the type of value that is to be returned from the function. As I told you, what function would be returning is defined using the function prototype. and that is to be passed to the function, and also the arguments which we have to pass to the function, right? Moving on to the next point, it is defined in the beginning before the function call is made. It is always defined before making the call, right? So syntax, we have like return type, then name of the function, and then list of the arguments, right? And then semicolon. This is how we define prototype of a function, right? For example, void means null. That means this function will not be returning anything. Then we have name of the function, that is sum, and then we have two arguments of this function, that is int and int, which defines it will be taking two values of integer type, right? So now moving on to the next slide, function call, right? Function call can be called by specific name. A function call can be called by specific name and list of arguments included in parentheses and separated by commas, right? So as I told you in previous slide, that this is the name of function, and these are the two arguments it is taking, right? So we just, whenever we are calling the function, we have to pass those like arguments in that call, so that this function will be receiving the values of those arguments in the variable we define in our function definition, right? And we have to separate them using commas, right? Moving on to the next point, if there is no argument, empty parentheses are placed after the function name. Like suppose if our function does not take any input or any argument, in that case we can simply like write the name of the function and then put a pair of parentheses in front of that function name, right? So now moving on to the next name, if the function return a value, right, function call is written as assignment statement. Suppose your function is returning a integer value, then we will create a integer type variable and we'll assign a value to it which our function will be returning. As we can see in this example, suppose our a is a integer type variable, and the value assigned to it would be the value which our some function will be returning, right? Here our some function will be a integer type function, that means it will be a returning a integer value, right? So now moving on to the next slide, function arguments and parameters. Arguments are also called the actual parameters. Like another name for the arguments are actual parameters. Arguments are written within the parentheses at the time of function call. We write like suppose in this example we can see we are writing we are passing x and y in this in these parentheses, and these are nothing but the arguments of this function, right? So this is what this point is saying. Arguments are written within the parentheses at the time of function call. Here we are making a function call and we are passing the arguments in it, right? So now moving on to the next point, parameters are also called the formal parameters, right? These are written within the parentheses at the time of function definition, right? Actual parameters or arguments are the things which we are passing in the parentheses at the time of function call. That means at the time we are calling it, right? And parameters are those things which are written in our function definition. We will see in the next or upcoming slides what are parameters, and we'll be showing you with the example so that it can get clear to you, right? Let's just first see function definition, right? It is independent program module. Like we do not have to write this program or function inside the main function. We can write it outside it, like on the upper side or on in the downside. We will see in the upcoming slides where or how we have to write, right? It is to return to specify the particular task that is to be performed by the function. Like the code which is written in the function definition is the task which that function is supposed to do, right? The first line of the parameter is called function declaration, and the rest line inside the parenthesis or curly braces is called function body. Like the first line is called function declaration, and then inside the curly braces it's its body, right? Now moving on to the next slide, we have an example, right? Here what we are doing, like this, we are including header files. Then we are making a function, and we are like making the prototype of a function here, like as we have seen in our prototype video or slide, that first we have to write the return type of the function. Here it is void, that means it is not returning anything. Then we have function name, that is sum here, and then we have parenthesis, and inside parenthesis we write the number of arguments we want this function to like take. Here we are taking two arguments, or so these will be int and int, like we are just defining the what type of values it will be taking, and here it is like of integer type, and we are separating them with a comma. Like this is a function prototype. Right. Now our main function began, and here we have declared two variables a and b, and then we are taking a variable from the user, and then we are calling our function, right? Sum a and b. Here when we are passing this a and b, these are known as arguments, as you can see here, and this is called the function call, right? And then get ch, and after this void function we are declaring this function. That means we are defining this function, right? What how we are defining? We are simply like as we wrote our prototype, simply following that rule to declare our function. That means void, that is return type, the name of our function, and then the parameters, right? Here we are calling it parameters, and here we are not just writing the type of arguments or the parameters it will be taking, but we are also writing the name of variables with it, right? Here it is int a and int b. These are the type of or name of the parameters, right? This is called function definition, right? And here the parentheses begin, and here the end, and everything inside the these parentheses are called as function body, right? Here what we are doing, we are simply printing the sum of the number, like this. So now since we have defined our simple function, now we can call this function anywhere inside our uh, like main function, obviously after receiving the uh, like variables from the user. So that was pretty much it about the function and function type. And next video we'll be studying more things about functions. And thank you everyone.
Hi everyone, welcome back to First Mentor. And in previous video, we studied about functions in C and the variety of functions provided to us by C programming language. And in today's lecture, we'll be studying about types of functions. So let's get started. So basically, we have these four type of functions. If I talk about overview of them, like we basically have these four type of functions, and let's just go through them, and we'll be discussing them in detail in upcoming slides, right? So the first function we have is function with no arguments and no return. That means it will not take any arguments and it will not return anything. The second type of function we have function with argument but no return. That means it have some arguments but do not return anything from that function, right? Next type of function we have function with no argument and return. That means this function do not have any argument but it returns something, right? Another type of function we have is function with arguments and return. That means this function also take arguments and also return something, right? So now moving on to the next slide. Here we have an example of function with no arguments and no return, right? This is our basic structure of C programming language or C program. We have header files, then we have prototype of a function, and then we have a main function. And in this main function, what we are doing, we are calling this sum function, and in the end we are terminating the main function, right? So in the our sum function, what we are doing, as you all know how to declare a function, let me just give a quick overview. This have void as a return type. Like in the starting we have to write the return type, then name of the function, and then
like parenthesis, and then the function starts with the curly braces and also ends with the curly braces, and all the code written inside these two curly braces is known as function body, right? And this is also known as function declaration, right? So now let's see, this function have a return type as void. That means it is not returning anything, right? As we are able to know that it is a no return function. So its return type is void. Then we have name of function as sum, then parenthesis, and then curly braces. It is having like two variable declared in it, int a and b, and then we are asking our user to return or to give us input of two integers, right? And then we are taking input of those integers, and after that we are simply returning or printing the sum of these two integers, right? So this is an example of uh, no return and no argument function, right? So now moving on to the next slide. Here we have an example of function with argument and no return. That means this function will take few arguments, a argument or few arguments. Like it can take one single argument as well as many arguments, right? And it is having no return. That means it will not return anything. So this is again the structure of our C program. We have header files. Then we have our prototype of the function, and with the prototype we can see that it is a void type function, that is it is not returning anything. Then we have name of the function, and in the parenthesis we declare the type of our like arguments. Here we have int and int. That means we will be taking two variables as an arguments, and those arguments will be of integer type, right? Then we have main function, and in this we declare two variables a and b. Then we again asked our user to give us an input of two integers, and then we simply scanned the integers, and then we called our sum function and passed these two integers in our sum like sum call, right? Then in this sum call, what we in this sum function, what we can see, it is having void type return, then function name, then the arguments, that is int a and int b, right? As we can see here, we both the arguments will be of integer type, but in declaration we also type the name or the type the name of the variables, right? So inside the body of the function, what we are doing, we are simply printing the sum, right? So this is an example of with arguments and no return type function, right? In previous function, we were just calling the function and everything. These we were just calling the function without any arguments, and all these printing and scanning was done in the inside the function, right? I hope it's clear to everyone. Now moving on to the next slide. So we have another type of function, that is function with no arguments and return. That means it is taking no argument, but it will return something. Let's see. So again, this is our like basic structure of C program. We have header files, right? Then we have a like a prototype of our function, that is int sum, and we can see like here we can see that int is the return type of this function. That means this function will be returning int, and then we have name of our function, and then we have empty parenthesis. That means it is of like it is not taking any arguments, right? And then we again semicolons, which is like norm in our C statements, that we end the statements with parentheses, right? Then we have a void main function, that is our main function, and then we declared a variable, and in this we what we are doing, we are calling the sum function, and whatever the function is returning, we are storing that in our x function, sorry, x variable, right? And then what we are doing, we are simply printing the x, right? The sum of the numbers you enter is x. That means everything, that means like scanning and printing would be done inside the scanning, printing, and summation would be done inside this sum function, and it will return that sum and will store this that sum in x, right? Let's see. Coming to the function itself, like we can see return type is int, then name of the function,
then empty parenthesis, that means no arguments. And in the function body we can see we have like declared two variables, then we have asked our user to enter those two variables, then we have scanned and we have simply returned our a plus b, that means sum of these variables, and then we stored these sum in our x, right? So now moving on to the next slide, we have function with arguments as well as return. That means this function will take arguments as well as return something. Again, we have basic structure of our C programming language. Then these are header files. Then we have a prototype of our function, that is int type function. That means it will return an integer value. And then we have name of our function. Then we have int and int as our arguments. That means it will take two values of integer types. Then again we have semicolons. Then we have our main function, and in main function we have like we have declared three variables, that is a, b and x, and then we have asked our user to enter two variables, two integers. Then we have scanned these variables, then we called our function with passing these two variables or integers which our user input or gave us as an input, and whatever the sum function have returned, we have simply stored that value in our x, right? And simply we are printing x as sum of these two. So now let's see the function itself, right? This int is like return type, then sum is the name of the function, then integer, that int a is the variable or the argument we'll be receiving, int b is the variable we'll be receiving, and then simply we are returning the sum of these two functions. So these were the overview about type of functions, and like I hope that you got a clear vision about it, and that was pretty much it. We'll meet you in the next video. Thank you everyone. Hi everyone, welcome back to First Mentor, and in previous video we studied about types of function, and I hope it's clear to everyone. In today's lecture we will be studying about methods of calling a function. So basically we have two types of method of calling, that is a call by value and a call by reference, and I'll be telling you like both of them theoretically as well as with an example, and I have also a snippet of code by which I'll try to explain you all what the difference between them, and let's get started. So in call by value, what we basically do, we just pass the value of our variable, whereas in our call by reference we pass the address of our like variable, where address, by the address I mean the place where our variable is stored, right, in our memory. So moving on to the next slide and try to understand it a bit better. Call by value copies the value of actual parameter into the formal parameter, and moving on to the next point, during execution whatever changes are made in the formal parameter are not reflected in the actual parameter. So I hope you all remember what are formal parameters and actual parameters. I have told you all in the beginning of functions. So just to like let me see, like let me just make you all a bit like revise you, like so that you can revise what are actual and what are formal parameter. So here we can see in swap function we have made a function named swap, and we are calling it here, and then when we are calling our swap function we are passing two values, right? These two parameters or variables, these two variables are its actual parameters, and in the function declaration the variables we are using are formal parameter. So the point what the first point says, the they copies the value of actual parameter into the formal parameter. That means whatever the value a and b here are storing, this a and b variable will just copy those values, right? It will not make hold the address of the same like place where these two variables are stored in our memory, right? It will just copy the values what a and b are storing in our main function, right?
So during execution, whatever changes are made in the formal parameter are not reflected in the actual parameter. So this point, the meaning of this point is whatever the changes we will make in these two variables will not be reflected in these two variables. That means if we like change the values of these this a the but like if we change the value of this a, the value of this a will remain the same, right? Same for this b. If we change the value of this b, the value of this b remains the same, like it will be as if it was untouched, right? So this is what called by value. So if I talk about a real world example, suppose there are some guests in your house and you all are taking coffee for them, and your mother has given you a cup of coffee to give to the guests, right? So what you have done, the same amount of coffee and this same cup, you just have taken another same cup and taken the same amount of that coffee in another cup, and you gave that another cup which you took to the guest, and the original cup which your mother gave you will remains with you, right? In that case, if the like coffee in the mug which you have gave to the guest is empty, like if the guest drinks all the coffee, it the coffee in the original cup will stay untouched, right? It will stay like of same amount as it was before, right? This is what happening in call by value method, right? So now moving on to the next part, call by reference. In call by reference, reference of original variable is passed. That means we pass the address where the actual value or actual value is stored in our memory, in our main memory, right? Next point says function does not create its own copy. It refers to the original value by reference, right? That I told you that it does not create value like copy of it. It just you point to the same address location where our original value or original variable is stored in our main memory, right? The function works with the original data and changes made in the original data. That means whatever the changes the function is making, it will make changes in the original data. Like move like continuing with the same example of guest comings in your house. Suppose a guest have came to your house and your like mom have gave you a mug of coffee to give to the guest, right? In this case, what you are doing, you just gave that original cup which your mom gave to you to the guest, right? And whatever the changes, that means if the cup is fully empty or half and half empty or like fully filled, it is like the changes are made to the original mug which your mom gave to you, right? This is what happening in call by reference value. The changes or any updations are made in the original variable, right? Let's just see in our code. I have this snippet of C program. We have the header files and then we have the prototype. And just remember, this star means the like pointers, or should I say the reference to the actual memory, right? We'll study the concept of pointers in upcoming slides in depth, so that you can understand these like very clearly. But for now, you can just assume that this is the norm how we pass the values by reference. In like call by value, what we were doing, we were simply writing int and int, but in this we are writing like in call by reference, we are writing int star and int star. That means uh, pa- uh, two values are getting passed in our function, and it is returning nothing, right? Again, we have CLR to clear the console, printing to enter, like asking the user to enter the numbers, scanning the numbers, and then saying something, and called the swap function. Here, if you see, we are calling the swap function with ampersand sign, right? This is the norm how we pass the value by reference in our function, right? And to receive this like, or should I say ampersand a is nothing but the address of the place where a is stored, or it's the address, or it's the place where original value is stored. Like in our coffee mug example, it was the original coffee mug which your mom gave to you to give it to guest. You can assume that it is the original cup which is getting passed to our guest, right? So now whatever the changes is made by our guest will be reflected in our original mug, right? So this is how you can assume it to be. And you can assume this ampersand and ampersand, like ampersand a is the norm, like the way we pass our value by reference, right? So you can assume it to be like that. And in swap, if we see int temp, and in temp we are what we are doing, we are writing value as star a. Here this star means that we want the value here, like here this guest will be holding the address, right, or the original cup, but this temp want the value or the thing inside that mug. So what we'll do, what we'll say, star a, and this star a will represent the value inside that mug or inside that address, right? So this is how we deal with call by reference values. So these were two important methods of calling a function, and I hope it's clear to you all. And that was pretty much it about the calling methods. I hope you got a clear vision about it. So yeah, thank you all. Will meet you in the next video.
Hi everyone, welcome back to First Mentor. And in previous video, we started about functions, types of functions, and methods of calling function. So in this video, we are gonna something very important, like very important, or you can say base of a lot of things in programming, and it's recursion. And we'll be studying recursion, and we'll be understanding what recursion is and how we use it in our problems, and how we are gonna use it in our future problems, right? So let's get started. When a function call itself within the same function, it is known as recursion in C. Like when a function is calling itself inside that function, then it is known as recursion, right? The function which calls the same function is known as recursive function. So the function which call itself is known as recursive function. Or in other words, if you want to define recursion is, we can define it in such a way like when we can solve a problem with same function but with different problems, with a smaller problem, with a different and a smaller problem, then we call a recursion. Or you can say it is one of the use of recursion. There we use recursion, right? So moving on to the next point, a function that calls itself and does not perform any task after function call is known as tail function. That means there must be a function which is like not performing a function because it would be the end call of on that function, right? In tail recursion, we generally call the same function with return statement, right? We generally like return whatever return by calling that function. We'll see and understand it in more deep with the example, or should I say with the code. But let's just cover the theory part, and then we will move to the coding part. And I believe you it would be clear like what recursion is like when a function called itself, like when function is calling itself or function is calling the same function, is called recursion. And when the function call itself is also known as recursive function, right? So moving on to the next slide, advantages of recursion. So since I have told you that it is very important and it is like making base of a lot of things in programming, so like we should like know the advantages of recursion. So the advantages are that it make our code shorter and cleaner. Like we are just making a simple bunch of code or a function out of our main function, and we are just calling it whenever we required, like the you or whenever we want to use that function, or the like output which that function is giving. Whenever we need that, we can call that function anywhere in our main program. So that's how it will make our code more shorter and clean, right? Next point, recursion is required in problem concerning data structures and advanced algorithms such as graphs and tree traversal. as I told you that it will be making base of a lot of things, and these things are those that a lot of things that data structures, graphs, and tree. These are like totally based on recursion. Like if recursion will not get clear to you, you will not be able to like uh, think in the graph and trees problems. But that's of way too far in data structures and algorithms. Let's just understand the basics and let's just get over with the theory part. So moving on to the disadvantages of recursion, uh, it takes a lot of stack space compared to the iterative program. So as you all know, whenever we are performing a program or a program is like executing, then it is allocated some sort of memory via our OS, right? So when we are using when we are using recursion, uh, then a lot of like stack space is used by recursion, like as compared to the iterative program, right? Next point, it use more processor time since it is taking a lot of time, then it would be taking a lot of like processor time to get that space solved or space cleared, or all the problems in that space, like clearing or solving that all the problems in those space will take much more time than iterative program. Next point, it can be more difficult to debug compared to an equivalent iterative program, like since it is like taking a lot of program and like a very deep thinking is involved in it, then obviously it will take or it may take more time to debug, right? And the last point, the stack might overflow sometimes, uh, like recursive program goes so much in deep that it take a lot of space in our memory, and it that stack space gets overflow. That means it get completely filled with those recursion calls, and a point comes where it was not able to handle those calls, and eventually it shows that stack overflow, right? So this was pretty much it about the theory of recursion. And now let's move to the coding part, and let me just take you to the IDE. Let's move to the IDE, and I'll be using GFGID, that is an online compiler, and I'll be showing you code over here. And I believe that it's clear and visible to everyone. And let me just tell you what's the question is. So basically the question is, we just have to take an input from the user, and user will give us an input of a number, and we simply have to uh, like print the factorial of that number. uh, I hope you all know that what is a factorial. For those who don't know, let me just tell you what a factorial is. Just give me a second. So factorial is nothing but factorial of 1 is always 1 and also 0. Factorial of 0 and 1 is 1. Factorial of just give me a second. Factorial of 2 is 2 into 1. Factorial of 3 is 3 into 2 into 1, and factorial of 4 is 4 into 3 into 2 into 1. So I believe it's clear to everyone how we are calculating the factorial of a number, and this is how we define a factorial. That means factorial of a particular number is equal to that number into all the numbers less than that number till 1, right? So what we are supposed to do, we will be simply taking input of an integer from the user, and then we will be calculating the factorial of that number and simply printing it out. So in this problem, I will be using like we can do it iteratively, but I am gonna do it recursively. But I'll be showing you both the ways, iterative as well as recursive, right? So let me just give you a brief what I'll be doing. I'll be making an integer,
type variable, and then I'll be taking input. Hmm, yeah. So now I can like write a code, or I can write a loop here to calculate the factorial of a. But instead of that, I'll be making a function, since we have studied about the function. So I'll be making a function, and a function of type like int. That means it will be returning integer type. And like, I hope you all have seen that video in which we discussed about type of functions. So in this question, we'll be using a return as well as argument type function. That means it will be returning something as well as taking a factorial, taking a input, right? So let me just write fact and pass me, let me just pass the number, and assuming that it will give me the factorial of a, and I have stored that variable in our stored that factorial in our variable b, and now I'll simply print, right? Just a second. Hmm, yeah. So this will work. So let me just write the function. So the function would be of int type. As we all know, it will be returning a like integer, and the name of the function is fact, and it is receiving an argument, that is a. And now if a is 1, or should I say a is less than equal to 1, it will always return 1. Like, we do not have to calculate anything, it will return 1, because factorial of 1 and 0 is 1, and we are assuming we'll be getting the positive number always. So right, so if we are receiving 1, we have to simply return 1, because we do not have to calculate any factorial for it, as well as for 0. So I have just generalized this, that if I am receiving any number which is less than equal to 1, uh, we just have to return 1. And assumption is also that we are always receiving a positive number, right? So now here the recursion comes into the play, right? Since So now I will call this function again, but with a smaller number, and I will call this function saying that, hey, go and find the factorial of number which is just one smaller than my given number, right? And I am assuming that it will return me a value which will be factorial of just a second, which will be factorial of a minus 1. That is, a is the number I am receiving from the user, and this function is returning me the factorial of all the numbers till a minus 1. So we are just left with simple work, that is, I just have to multiply our number with the factorial of all the numbers smaller than it, right? As you can see, if I have to find the factorial of 4. So what we are doing, if I'm having this if I'm having the answer of factorial 3, then I'll be simply multiplying 4, right, in that answer, and that would be the factorial of my 4, right? This is what happening here. Suppose I have received 4, and I'm asking my function to find me the factorial of 3, and assuming that after calling this, it have returned me the factorial of 3, and now I'm just left with a simple task, that I'll be just multiplying my number with the factorial of that number minus 1, right? So let's just see, uh, for 3 the factorial would be 6. Let's just see if it works or not. So the fact is 6, that means it is working fine. That means this function is returning correct value. So this was the function I made using recursion, or we can call call this function as recursive function, right? So now I will try to make another function, but using iteration, right? So let's make another variable. The function I'll be making would be of like again return an argument type. That means it would be having a return type. That means it will be returning something as well as it will be taking an argument, right? Again, I'm just making the name of the function same as fact, but I, that means iterative. Here I stands for iterative, and I'm just passing the number and assuming that it returned me the value, and simply printf fact of fact using iteration. So I hope you all remember that \n is used to command the compiler that print, or from after this statement you just have to use the next line or new line, right? Let me just make the function that is int fact I, and it is receiving a variable name. It is receiving an argument, and now what should I do? So I'll be simply making a variable as C, let's say, or B, and just initializing it with 1, right? So what I'll be doing, I'll be running a loop from that number till that number is greater than 1, right? And will be decrementing it. And what else I'll be doing? I'll be updating B with B into I. So I believe that's it, and I'll be returning B. So I believe this should work. Let's just see by running this function and see if it works or not. So both of them are giving me the correct answer. That means both of the functions are right. Let's just try for a bigger number, 5. So that's correct. The like factorial of 5 is 120. So these functions are right. So this was the recursive function and this was an iterative function. So I believe it's clear to you all now, and we'll meet you in the next video. Thank you everyone. Hi everyone, welcome back to First Mentor. I believe like functions is clear to you all, and in today's video basically we will be doing questions. I'll be doing one question, and I'll be giving you one question to do so that you can like get a brief idea that how you all are supposed to use functions. And so let's get started. So the question I'll be doing is this one, and you all are supposed to do the like second question by yourself, so that you can get like a good idea that how to use functions. And just like you do not have to worry because it's an easy question, so you will be able to do this question easily. So let's get started. So the question I'm going to do is this one, and this question says a person is eligible to vote if his or her age is greater than equal to 18. Define a function to find out he or she is eligible to vote or not. Basically, the question says we have to write a function so that we can identify whether a given person is of a particular age is eligible to vote or not. So let's move on to the IDE and see how to code it. The first thing I am thinking of is to take the input from the user. So basically, I'll be defining a variable of integer type because age is an integer, int age, and I'll be scanning that. Just a second. And this how we'll be able to scan the variable. This is how we'll be able to scan the variable from the user. And now I'll be sending like I'm making another variable name as result, and in this result variable I'll be storing uh, whatever our check function will return. Basically I am making a function which will be of like
return as well as argument type. That means it will be taking an argument and as well as it will be returning a particular value. So the value which it would be returning will be of bool type. That means it would be returning true or false. So I am just passing age in the check as a argument, and it will be returning by checking that whether the given age or age of the user is greater than equal to 18 or he's eligible to vote or not. So like if result equals to true, then print simply printf that you can vote, right? You can vote. Simply write this. What else we can do? In else statement we can simply print you cannot vote. So that's it. In the main function now I'm writing our check function, and it would be of bool type. That means it would be returning a boolean value, right? And the name of the function is check, and it will be taking an integer type argument, and the name of the argument is age, and we are simply checking if age is greater than equal to 18, will simply return true. Or like if there is only one statement in our if or else condition, like we can simply write like this. Or what you can do, you can make the parenthesis also. Just a second, guys. Yeah. And in else condition I'll be simply returning false. So that's it. Let's see. Here is a integer I have written 5. Let's check if it's work for this integer or not. Okay. Okay, it's showing that it's not uh, declared. That means I'm not able to include some like header function. Let me see. So I believe we should include the header file in this, and that will work for us. And the name of the header file I'm gonna include is stdbool.h. By including this header file, we are able to like include like the boolean variable or boolean data type in our function, and we can see it's working now. And our input was 5. That means the person is not eligible to vote, and it's showing you cannot vote. That means it is showing correct. And let's try for another variable. You can vote. So it's simply uh, f- like working fine. What else we can do in this? How, like, what different kind of function we can make is like we can simply make a function in which will be inputting like we will be like inputting the variable and would be checking there and printing there only, like that would be of not return type and not taking any argument type, right? Or like let me just show you, and let me just comment it out. I'm making another function of type like which would not be having any return function or return type, right? Let's name this as check again, uh, like check 2, and it would be just taking an argument and simply it's done, right? So it's check 2, it's of void type. That means it is not returning anything, and we'll simply check the age is greater than equal to 18. If that's the case, we can simply print you can vote, right? Else you cannot vote. You can not vote. So that's it. This function will work fine. Let's see. You can vote because our input was 18. Let's try for 1. So you cannot vote for the person with the H1, which is correct. So this function is also working fine. So let's just try to make another function in which it would be of like no return as well as no argument type. That means it will not take any argument as well as no return type would be of that. Like it will not return anything. Let's make check 3 and it would not take anything. So let's just make the variable in it and scan the variable in it only, right? So how we can scan the variable? You all know that it's %d and ampersand n, right? And you can like simply, yeah. So I was saying we can simply input by scan statement and by this and simply do if age is greater than equal to 18, we can simply do printf. You can vote, right? In else statement we can simply do printf, you cannot vote, right? So that's it. Let's try to see. And for this, what we have to do in main function, we simply are supposed to call this function only and will not be making any argument in the main function, and everything would be taken care of. Let's try to run this and see if it works or not. So you cannot vote for age 1, and let's make someone of age 50 and let's see. So it's showing you can vote. So yeah, that was pretty much it about this function or about this question. So let's just go to the next question and see like what the question says. So in the question, what we are supposed to do in the next question, you all are supposed to do this question by yourself, and if you'll do this question by yourself, it will make your concepts more clear about functions. And try to do like try to make functions of all 4 types which we have discussed in our previous videos, right? So let me just go through the question and tell you what you are supposed to do. So write a program in which just a second. Write a program which will ask the user to enter his or her marks out of 100, right? Define a function that will display grade according to the marks enter as below. Like you are supposed to like ask the user for their marks out of 100, and you are supposed to return the grading to the user, right? So if the marks is 91 to 100, you are supposed to return AA. If it's 81 to 90, you are supposed to return AB. If it's 71 to 88, it's BB, 61 to 70 BC, 51 to 60 CD, 41 to 50 DD, and less than equal to 40 is fail, right? So I would say try to do this question using functions, and inside the functions to check these number. Try to make if and else statement as well as try to do it with switch cases, right? So it would be helpful for you to like get a clear vision about both of them. So yeah, that was pretty much it. Thank you everyone. We'll meet you in the next video. Hi everyone, welcome back to First Mentor, and in today's lecture we'll be studying about arrays and uh, just a second. Yeah, so we'll be studying about arrays, multi-dimensional arrays and functions. So these all are the things we'll be studying in upcoming videos, right? So let's get started and start with what are arrays. So an array is a collection. An array is a collection of similar items stored in continuous memory location. In programming, sometimes a simple variable is not enough to hold in all the data. So basically, an array is collection of similar kind of data, and like similar, by the similar means that the type of data, that means whether it's of integer type, boolean type, character type. That's what I mean by type of data. Similar, it is like collection of similar items or similar data stored in continuous memory location. That means in memory it is provided a continue memory location or memory block, right? In programming language, sometimes a similar simple variable is not enough to hold all the data. Sometimes like so far we have seen our variables of int type, character type, and so on, like, right. So sometimes we are supposed to store like various datas, and we for that we are supposed to make a lot of int variables or character variables. But but it's a very like long and a tough task, right? Suppose if I'm supposed to make 100 int type variables, right? So instead of that, we can simply make an array of integer type. That's what this array or this statement means in programming language. A simple variable is not in not enough to hold all the data, right? For example, let's say we want to store the marks of 500 students, right? Having 500 different variable for this task is not feasible, as I was told in that in previous example, right? So what we can do, we can define an array with size 500 that can hold the marks of all students, right? As you all know that it's a continuous memory block. That means we would be able to store the marks of all the 500 student in continuous memory block, which would be like helpful to us in accessing those marks and all that stuff, right? So you can see in the diagram that this is how we should imagine an array, that it's a continuous memory block, and it is having like space to store the value, right? Suppose in this memory block 7, 7 is its value, 11 in this, and 6 in this, 55 in this, 98 in this, 45 in this, and so on, right? So what we call this this was the values, and these are the indices. That means the place or the positions are like how we will uh, get to know at what position it is stored. Since these all are in continuous memory blocks, so we always number those memory blocks, and those numbering starts with 0. So for the first block it's always 0, and then 1, then 2, then 3, then 4, then 5, and so on, right? So the first index is known as lower bound, and the last index is known as upper bound. So we can see the length of the array is 8. It's like this, right? So this is how we are supposed to imagine, and this is how we uh, give the index or the address to our array, right? So now moving on to the next slide, declaring an array. So we have basically three methods to declare an array. First method is this, by writing int, that is its type, what type of continuous data we will be storing in our array, right? Suppose we have defined int, so now we are only supposed to store int type of variables in it, right? So int, the name of the array, here I have written ARR, you can give it A, B, C, anything, right? And then square bracket open, and then square bracket close, and in the square bracket I am supposed to write a number, and what that number will be, it would be the size of the array. That suppose I want 5, here we can also write 500. So it will be making, or you can imagine the this kind of array or memory block creating in the memory by writing this number. Suppose I have written 5, so it will be making this kind of 5 blocks empty, that means not holding any value initially in our memory block, and simply we can access those memory block by this, right? Writing A0, as I have told you, like indices. I have told you what are index, right? So at 0 index I am storing 10, at first index I am storing 20, and so on. So this is how we are declaring, and this is how we are storing, right? And second method is again the type of the array, then name of the array, then square bracket, and then without giving any number in between those square bracket, what we can do, we can simply assign uh, array in it, right? How we can assign, simply assignment operator, and then curly braces, and write the numbers or the character or the type of variable which you have defined of this which you have defined is this array to be of, right? Simply write or give the values in this like between those curly open bracket and close bracket, and those like values of would be of any type or any amount of, like, you do not you are not supposed to like define that it would be of 5 type, like, sorry, it would be of like length 5 or 10 or 20. It will be like taken care of by its like it will be taken care of by the compiler. You are just supposed to initialize it in this way, right? And compiler will take care of what would be the size of array, right? So the third method is we can also define the size here and then give the values, and this is also a way that we are not defining the length and simply giving the values. So this is a this is the way of declaring array. So now moving on to the next slide, accessing array, right? So this is our basic program having like header file, then main function. Inside the main function, I have made a like array, and we can simply access any value in this array by using its index, right? So the index of 11 would be 0, index of 22 would be 1, index of 33 would be 2, index of 44 would be 3, and index of 55 would be 4. So I can simply write the like write the name of the array, then square bracket, and then the index number, like here, and that would be able to access the value written inside the array at that very index, right? So this is how we are printing and accessing those value, right? So let's move on to the next slide and see the advantages of array. So let me just go through these points, and let me try to make you understand what are the advantages of using array, right? So random access of element using array index, like you can simply access whatever like you can simply access element at whatever index it's present on, like just the condition applied that index should be inside the range of array, right? Suppose index like length of the arrays of like arrays of length 10, and you can like access any element randomly between 0 to 9, right? At index in like element present at index 0 to 9, right? Moving on to the next point, use of less line of code as it creates a single array of multiple elements. Like we are just writing a single line and we are able to create like a continuous memory block of similar elements, right? Next point, easy access to all the elements. You have seen like how we were accessing the element inside the array, right? And it was pretty much easy. So moving on to the next point, traversal through the array become easy using a single loop. Suppose you are having an array of 500 size or length of 5 like 500, right? So you will not be like using this way to access all the memory blocks or all the values. You can simply loop the array, like, and you would be writing just a for loop or a while loop and writing accessing the memory inside it, and that's it. You can easily access all the memory, right? And next point says sorting become easy as it can accomplish by writing less line of code. Like we can simply uh, sort the array by writing less amount of code, right? So moving on to the next slide, disadvantages of an array. Okay, so let's go through these points. Allow a fixed number of elements to be entered with which is decided at the time of declaration. Like, right. That means suppose we want at like beginning of the program, we thought like we will be only entering 100 numbers or 100 like marks of 100 students. But by the end of the year, you are having 110 students. So then in that case, what you are supposed to do, you just simply have to create a new array of bigger size. You cannot increase the size of array because it's already declared in the beginning. So that's the one of the disadvantage of array. Like it's not dynamic. Simply you can say that. Next point is insertion and deletion of elements can be costly since the elements are needed to be managed in accordance with the new memory allocation. Suppose you are having an array of 10 size or length 10, right? And you are supposed to delete a element which is present at element 5 and you deleted it. Then all the elements like after that 5 index are supposed to shift one index before, right? So this is how like it's a bit difficult or costly to insert or delete element in between, right? So that was pretty much it about the array. So we'll meet you in the next video. Thank you everyone. Hey everyone, welcome back to First Mentor. And in previous video, we studied about arrays and should I say one-dimensional arrays, at advantages and disadvantages. So in this video, we are gonna practice a question about array so that the concept of array will get clear to you all and you'll get a clear vision that how to play with arrays, right? So the question we are gonna do is we are gonna make an array and in that array at every index where 0 is coming we will update that 0 to be 5. What I mean, at every index there would be a certain number in front of that index, either 1 2 3 4 5 or so on. So at every time 0 will be occurring, will be converting it to be 5, right? So this is the question. So I'm just like initializing the array at the time I'm making it. But the question, you all have to do the same question, but the difference is that you all have to take the input of the array from the user, right? And also the size of the array from the user, right? So I'm just making an array, and you all know we can make the array by this 0 5 1 sorry 2 1 0 0 1 1, and I this is the array I have made. So let's just see what the size 0 1 1 2 3 4 5 6 7 8. 8 is the size of our array. So what we are supposed to do at every instance where 0 is coming, we are just supposed to convert that 0 into 5. So what we'll do, we'll iterate over this array. And how we'll iterate over this array? By using the for loop, right? How we write a for loop, I believe you all remember, right? And why I'm writing I less than 8? Because we all know in arrays the indexing goes from 0 to the size minus 1, right? So that's why from 0 the I should move from 0 till less than 8, that is till 7, right? It will the time it will become 8, the for loop will get terminated, right? So inside this for loop, what we'll check, we'll check if this array the element at ith index is equals to 0. If this condition comes true, then what we'll do, we'll update that element to be 5, and that's it. Now let's just try to uh, print this array and see if this array is updated or not, right? So printing, we simply have to print using printf and array percent d arr I. So what does syntax mean? Print the element present at index I. So that's it. Let's just try to see. Let me just adjust the screen for you all so that it can become a bit more clear to you all. Right, I believe now it's clear to everyone, and the explanation must be clear to you all. And let's just try to run it and see if it's working or there is any error coming. So it's working fine. Let me just try to give a space in it. And so how we can give the space? We can simply do this, and I believe this will work. Okay. So first there was 0 coming at this index, it is converted to 5. Then there was 0 0 here, then it is also converted to 5, which means it is working fine. So this code is working fine. So you all are supposed to do the same question, but there is a simple update that the size of the array you will be taking from the user, as well as the array or the elements of the array you will be taking from the user. And I'm just giving you the hint that you will be like taking input again by using the for loop and the scanf statement, and it will be similar to the we used to like take input of a variable, right? So that is it. So that was all about this. So thank you everyone, we'll meet you in the next video. Hey everyone, welcome back to First Mentor. And in previous video, I believe we studied about arrays, and I hope it's clear to everyone that how we should imagine an array while working with an array, right? And imagination is very important so that you'll be able to like think about a particular question or something while doing a array problem, right? So I hope like it's clear to everyone because we did few questions in previous videos, and it's been like clear to you all. So let's just move on, and in this video we'll be studying about multidimensional arrays. So let's get started, and let's see in the presentation. So this is the general syntax of a multidimensional array. The first of all, we'll like write the type of the multidimensional array. We'll be using type. By the type, I means like integer array or a integer multidimensional array or a character multidimensional array or so on. Right. So this is the first thing we'll be writing for declaration of our multidimensional array. That would be its type, then name of the array, and then the size we want. And you'll be seeing there are a lot of square brackets and size written in them. But generally, if I talk about a multidimensional array, we'll be using a 2D array most of the time. Like in 99% of the time we'll be using two-dimensional array, and that would be sufficient like in 99% of the problems. So you do not have to worry about like how many like of what size or how many rows or columns do we need to allocate. So you just simply have to get used to of two-dimensional array, and we'll be getting through that also, that what a two-dimensional array is. Like an example, if we see it's an integer type two-dimensional array. In two-dimensional array, we just have written like two square brackets and integer between them. I'll be telling you what this integers means. Let's just go through it first. This int means int stands for the type of the multidimensional array. Then ARR is the name of the multidimensional array. And then we are having two square brackets and two integers written between them, right? So the first integer, we can first of all, let me just tell you, for the two-dimensional array, we can just simply assume it to be like a matrix. Like in maths, we used to have a matrix, right? So similarly, like in two-dimensional array, we can assume it to be like a matrix, and the first integer shows the number of rows, and second integer shows the number of columns. And as we all know, in arrays, the numbering starts from 0. Similarly, in here, the numbering will start from 0 and go up to 3, go up to 2. Like for 3 rows, we would be having 0th row, first row, and second row, right? And for two number of columns, we will be having zeroth column row, zeroth column and the first column. So that would be it. So I believe the general syntax is clear to everyone. Moving on to the next slide. So two-dimensional array, as I told you, will be mostly using two-dimensional array, and that would be sufficient for like most of the like problem or throughout the curriculum, right? So for two-dimensional array, we generally have like general syntax, that is integer type, type of the two-dimensional array, like int type or character type, and then we have name, and then we have two square brackets, and then we have x and y. Those would be the constant, and these will represents the number of rows and columns, right? Here we can see the example that int, the type of the array, type of the 2D array, then arr, name of the 2D array, and then we have 3, that would be our number of rows, then we have 4, that would be our number of columns. And you can like imagine this like multi-dimensional or 2D array to be a matrix like this, where the number of columns are going from 0 to 3, since we had 4 number of columns, and 3 rows. For 3 rows we are going from 0 to 1, right? So to like access the elements, we can simply do it like this, that 0 for like first element of the first row, we can simply say 0th element of the 0th column, then for 0th like first element of the 0th row, like 0th row and 0th column, this is a particular element, then 0th row and first column, we have a particular element, and so on, right? So I believe this is clear to everyone, and it is similar to like accessing elements in a matrix in maths, right? So now moving on to the next slide. Coming to the initialization of the 2D array. So basically we have two types, two ways of initializing a 2D array. The first way is like at the time of declaring, we can simply initialize it like this. First of all, we have like declared our 2D array, that is like, as you all know how to declare a 2D array by now. And then by assigning statement or operator, we can simply assign, and then we have to like start with the curly braces, and then we have to like write all the rows and the elements in those rows. Like for the first row I am writing 0 1 2 3, and then for the second row I am writing 4 5 6 7, and for the third row I am writing 8 9 10 and 11. This is how we can initialize our 2D array at the time of declaration, right? So another way which I have not mentioned here is by using the loop, by using for loop, mostly 2D, nested for loop. We can initialize or take input or make our 2D array more dynamic by taking the input from the user, right? Here I am just showing you that how to access element in the multi-array, multi-dimensional array or 2D array, right? So in 2D array, we have seen we have rows and columns, and we can simply like type the name of the array, and then the number of like the element or the row in which we want to access the element, then the column in which we want to access the element. So by writing this statement, what we are saying to our compiler that, hey, like we want the element present at the like third row and fourth column, right? So there would be a single element present at this particular position, and our compiler will be returning that element to us. And I believe, like, like why I have written here fourth, because in arrays we go from 0 to the counting -1, that is the size -1. Suppose if we are having like row of 3, like suppose I have initialized our, like here, suppose I have initialized my 2D array from to have like 3 rows and 4 columns, then the numbering of the rows would be 0 1 and 2, and for the columns we would be numbering from 0 1 and 2 and 3. Like this would be the numbering which we'll be getting. So that's why like here I have written one the element +1 1th column, right? I hope you are getting what I am trying to say. and it will get more clear when we'll be doing questions of 2D array. Thank you everyone, and we'll meet you in the next video. Hey everyone, welcome back to First Mentor. And in previous video we studied about multi-dimensional arrays. So in this video we are just gonna practice a question in this multi-dimensional array so that the concept should get clear to you, or you should get a clear vision about how to use multi-dimensional arrays, right? So let's get started, and I'm using GFG IDE, as you all know. Let me just adjust the screen so that you'll be able to see it a bit clearly. And I believe it's clear now to everyone. And let me tell you what we are going to do. We are going to take a matrix or a two-dimensional array, and then you can either initialize it by yourself. I will be initializing it by myself. And then I have to count that how many number of zeros are there in that matrix, right? So so that it will get clear to you all, right? So as you all know, we declare a matrix by let's say name is ARR, and by this we can either declare the size by at the like beginning, or we can uh, leave it to like leave it for the compiler to guess that what will be the size, and we can simply type now the rows. This is one row, and uh, just a second guys. And there I'm writing the second row, 1 0 0 1 0, right? 1 2 3 4 5 1 2 3 4 5. That's correct. I am making a 3 cross 5 array or 2D array, that is 3 rows and 5 columns. We have 0 1 1 1 1. Let's just count it by ourselves and see 1 2 3 4 5 6 7. We have 7 zeros in this array, right? So now I have initialized it, and I hope you remember that we can initialize our 2D array like this also. So now what we'll do, we have to print the number of zeros in it. So I'll make a variable name as count and initialize it with 0, right? Then I'll make a loop which will go from 0 to like 0 to, it will basically this outer loop will iterate over the number of rows that will be less than 3, right? Because we all know the in the arrays or 2D arrays, the indexing goes from 0 to the size minus 1, right? So here I will go from 0 till 2. It will never become 3, right? So I am writing another loop that is a nested loop, and I am using j here, and j will be less than 5 and j plus plus. I believe you all remember that how to use for loop. So I believe like nested loop is a new concept for you all. So I believe you should understand it a bit clearly, so that it will not create a problem to you all when you will be using it again, right? So this is how we use a nested loop, and for 2D array or matrix, we always use to like nested loop to iterate over it, right? So now what I will say, in our if condition, if I and j is equals to 0, then what I am supposed to do, I am just simply supposed to update my count by 1, right? So what this line mean, right? It means the same thing which I have explained you in this uh, like place or in this slide, right? That means the element present at ith row and jth column, if that element is equal to 0, we just simply have to increment our counter by 1, right? And that's it. And simply printf the counter, count of 0 of 0% D is count count, and that's it. So let's just try to run and see if it's working fine or not, and if there is any error we can resolve it. So it is saying array it is incomplete. Okay, let me just see what's the issue with it. So let's just see what's the issue. So I guess we should use numbers here to like declare the size, I believe, because we can use the square brackets simply in 1D array, but in 2D array I believe we should you declare the size, right, so that compiler can get to know it should not throw any error. Like before updating of the in like primitive C++, they used to like run with the square brackets, but now they want the size. So let's just try to run now and see if there is any other error. So now it's working. So I believe that was the only issue, that I was not giving the size and was assuming that compiler will assume it like declare it by itself, but that was not the case. So just remember, we always have to declare the size in 2D array, right? And we are getting count of 7 as count of 0 as 7, which was correct. We counted here that 1, 2, 3, 4, 5, 6, 7, which is a correct count. And that was pretty much it about two-dimensional array. So I want you all to try the same question by yourself, but the thing you're supposed to do is you have to take the input from the user, that what will be the number of rows, what will be the number of columns, and then you are supposed to take the input of the matrix also from the user, right? It will be simple, like I'm just giving you hint. You just have to make two nested loops. The outer one will be iterating over the rows, and the inner one will be iterating over the columns. And like inside these nested loop, you will simply input a variable like you used to do for a simple variable, right? And that's how you will be taking the input of the 2D array. So that was pretty much it. I believe it is clear to you everyone, and I like you all should try this question which I just said to you, that you will be taking input of rows from the users, and also from a column from the user, and also you will take the input of the matrix from the user, and then you will count the number of zeros in that matrix, and that's pretty much it. So it will get clear to you everyone, right? So thank you everyone, we'll meet you in the next video. Hey everyone, welcome back to First Mentor, and in today's video we'll be studying about pointers in C. So let's get started. So in pointers, we'll be studying about pointers in array, pointers and functions, and dynamic memory allocation. So do not worry about, like, you must be thinking there are a lot of new things to study, but I'll try to make them as simple as possible for you all, right? So let's get started. And pointers, so let's just go through these points and try to understand what pointers are. So a variable that holds a memory address, right, that does not hold a particular variable, but holds the memory address, those are pointers. uh, this address is the location of the another variable in the memory. So basically what this point is saying, so these variables, that means these pointers, like pointer holds the address of another variable in themselves, right? For example, let's suppose we have made a variable like int type variable, and we have assigned the variable value as 10, right? So there must be a memory block made in our like memory, who would be storing the value 10, right? So that memory block must be having an address. So when we make a variable and we store that memory block address which is storing 10 in our memory in that another variable,
those variables are known as pointers, right? Basically, these pointers point to the particular memory block in our memory, right? So that's why they are named as pointers. Moving on to the next point, not all the pointers contain address. Like it's not necessary that all the pointers must be containing a address or of some variable, some other variable. Some pointers are also known as null pointers. Like here you can see in the example, a null pointer is those pointer whose value is 0. That means who is not storing address of any other variable, right? So I hope it gave you a brief idea about what are pointers, right? So moving on to the next slide. A pointer can have three kind of content in it. The first kind is the address of an object which can be dereferenced. We'll be studying what a dereference means. For now, you can just imagine it to be like something through which we can access the value stored in the address, like stored in the memory block, which whose address is stored in our pointer, right? So I think like I have made it a bit complex in the statement, but I'll be explaining you with an example, and you'll be like getting a clear vision what is dereferences. So for now, you can just imagine it to be like something through which we can like access the value whatever value, like access whatever value is stored in the address which our pointer is having, right? So second kind is a null pointer. That means it do not store anything. Third is invalid content, which does not point to any object. That means it point to some memory block which is not having any kind of value or anything in it, right? So the next point says p is a pointer to the integer. Then let's suppose a p is a pointer to a integer variable, right? So then we will be defining that. So we'll be defining p as int star p, right? So this star is a special character we use with the pointers to show to tell our compiler that hey, this is a pointer variable, right? So it will be storing a address of something, right? So moving on to the next slide, declaring a pointer. So here comes to be a very important part, how we declare a pointer. So as you have seen in the previous video, like in previous slide, that when we were having a pointer to an integer type, then we will be writing int star p, right? So similarly here is the declaration of the pointer. First of all, we have to write the data type, which kind of uh, variables address our pointer will be storing. Like in this, it was storing address of a integer type variable, so that why its type was int, right? So here it would be the data type. First of all, we have to define our data type, then star, and then name of the pointer, right? So now the first point says star is a urinary operator, also called as indirection operator. So star is a urinary operator, as you can see, and also known as indirection operator, right? The next point says data type is a type of object which the pointer is pointing, right? So data type will be of that type to the variable, like to whom our pointer will be pointing, right? Next point says any type of pointer can point to anywhere in the memory. Uh, like uh, like there could be any type of pointer which can point anywhere in our memory, right? So next point says star is used to declare a pointer and also to dereference a pointer. uh, so as we have seen in the like declaration of a pointer, we use star, right? But star is not only just used for declaring a pointer, it is also used to dereference a pointer. So dereference is like dereference means suppose our variable is storing address of a integer type variable, or our pointer is pointing to a integer type variable, right? So what our dereference will mean? Dereference will say, hey, to our compiler that hey, go to this address and access the value whatever stored in this particular memory block or this particular address, right? So this is what dereferencing means, right? So moving on to the next slide. So what so yeah, moving on to the next slide, we have just a second, guys. So yeah, moving on to the next slide, we have few more points to remember about the pointers, right? So pointers is a very important concept in C and C++. That's why I have a lot of point listed for you all, so that it's get clear to you all, and you will not face any problem while using them, right? So yeah, moving on to the points. When you write int star, the compiler assume that any address that it hold point to a integer type, right? That's why we write its data type to be a int, right? So the next point says m equals to address of ampersand count, or we can read it to be address of count or ampersand count. Like it depends on the like people to people, but I'll prefer to say address of count, so that you are also saying it and remembering it at the same time, that what this sign means, right? Suppose we have declared like integer type where pointer m, and then we'll assign value of count as this address of count, right? It means the memory address of count variable is stored in m, as I said you, right? And is a urinary operator that return the memory address. Like the and ampersand is a urinary operator that returns the address of the memory block with whomever variable is used with. Like if we use it with the character variable, it will return the address of memory block of that character variable or int variable, and so on, right? So yeah, ampersand orally is yeah, as I told you, orally as ampersand it return the address, right? So it means m receive the address of count, right? So moving on to the next slide, address of operator, like ampersand or address operator. This is the sign you have seen in the previous slide, right? Moving on to the points, it is used to reference the memory address of a variable, to get the memory address of a variable, or to refer to the memory address of a variable. We use this ampersand operator, right? So the next point says when we declare variable, three things happens, right? What are these three things? Let's see. Computer memory is set aside for the variable. Like the computer memory, the compiler like books a memory for the variable which we make, right? The second thing happens is variable name is linked to the location in the memory. We generally link the name of the address, link the address to the name of the variable, right? The third thing happens is value of variable is placed in the memory that was set aside, right? The value which we are storing in the variable is stored in that memory which our program or the computer have kept aside for the variable, right? So now moving on to the next slide, let's see, let's suppose this is our pointer which we have declared to be of int type, right? Declaring a pointer which hold the value of address of int type, right? So like int well is a variable which is storing a value as 1, assigning int the literal value of 1, as we can see here, right? Now we are assigning this pointer the address of this val variable by this, right? So dereference and get like we are just simply using the address operator and getting the address of val variable, and this is just saying the same thing, right? Now, so now what we can do, so we can this is what we say to be as dereference. We use star to like create a pointer variable or declare a pointer variable, also to derefer or to dereference that address stored in that variable. So let's see what this dereference means. Let's just make a variable derefer of int type, and then assign the value of whatever this dereference pointer or dereference PTR will return, right? And simply print. So the output would be 1. That means if you are able to see, if we use star operator with our PTR and assign this to a variable of int type, what we are getting nothing but the value which is stored in our that particular memory block, right, which is 1 here. So I hope it's clear to you all now what this dereference means. So now moving on to the next slide, pointers arithmetic. So pointers arithmetic is one of the important concept which we can use with the like arrays. So let's just get through this and let's see what it have to say. And just a minute, guys. Yeah. So the point says there are only two arithmetic operations that can be used on a pointer. Only two arithmetic operators, that is addition and subtraction, right? So the next point says to understand this concept, let's p1 be a integer pointer with value 2000. Like address is stored, like p1 is a pointer variable, and the address stored in it is 2000, right? And it is of integer type. That means it would be it would be taking 2 bytes in the memory, right? So int is a 2 byte, right? After the expression p1 plus plus, you all have seen this post increment operator before in previous videos, and what it do, it just increment the value by 1. Since previously point p1 was storing the 2000, but now we are doing plus plus, that means we are adding 1. So like according to the mathematic, it should store 2001 as in it, but it will store 2002 because it is of integer type. That means whatever the type of the pointer is, it or like incrementing, it will increment by that like bytes, right? Since int of is of 2 byte, so whenever we'll use the increment operator on a pointer of int type, it will increment by 2, right? Like this you can see in this example. I hope it's clear to everyone. Now moving on to the next slide. Each time p1 is incremented, it will point to the next integer, right? Like in array, if we assume an array to be a like let's just assume an array, and p1 is storing the first element or the address of the first element of that array. So whenever we'll do p plus plus, it will point to the next like element of the array, right? That what this statement means, right? So now moving on to the next point, the same is true for the decrement. Like as on increment we were able to like increment 2 in our integer type pointer. Similarly, when we use the decrement operator, it will decrease 2 on our pointer, right? So the next point says each time a pointer is incremented, it points to the memory location of the next element of its base type. And that means if base type means the previously it was pointing to, previously if it was pointing to an integer type variable, then on incrementing again it will point to an integer type variable, right? So this is what this point means. The next point says if if decremented, then it points to the previous element location. That means if we decrement it, then it will point to the location of the integer of the previous element or the previous element of integer type, right? The last point says let's just update with p1 equals to p1 plus 12. This statement will make p1 point to the 12th element of p1 type. That means of integer type, right? So now moving on to the next point or next slide, arithmetic rules. The rules which we should follow while using arithmetic operators with our pointer are: you cannot multiply or divide a pointer, right? You cannot add or subtract two pointers. We cannot add or subtract two pointers. We can only add or subtract a literal to our pointer, right? You cannot apply bitwise operator to them, right? You cannot add, subtract, type, float or double to from a pointer. We can only increment or decrement of integer type, right?
and we cannot like use float or double type of pointer for them, right? So benefits of using pointers are used in a situation where passing actual value is difficult or not desired. Like suppose we are using a array, right? So and we are having the address of its first element, but we do not want to pass the complete array. We can simply pass the address of the first element to the function or somewhere some place where we want to pass it, right? By you passing that first address or address of the first element, we will be able to access all the elements of that array, right? The next point says to return more than one value from a function, we can simply return the pointer to that, right? To increment the execution speed, like when we pass a like variable, it creates either copy or it like process it to the bitwise operator, bitwise, right? In bits, right? By passing the address, uh, we are simply able to locate that memory location, and it will increase the execution speed. Or should I say, like when we are passing a variable, it is like compiler is checking where that memory location is, and it will take some amount of time, not much, but some amount of time. We can decrease that by simply passing the pointer to that memory location, right? The pointers are more efficient in handling the data types. Okay, so pointer reduce the length and complexity of the program, obviously. So that was pretty much it about the pointers. So we'll meet you in the next video, everyone. Thank you. Hey everyone, welcome back to First Mentor. And in previous video, we started about pointers, and I hope it's clear to everyone what pointers are. Right. So in today's video, we'll be trying to understand the relationship between a pointer and an array, and we'll be studying pointers and array using the example so that it will be more clear to you all. Right. So let's get started. So here I have an example like which shows a relationship between an array and a pointer. So let's just get through this and try to understand what it have to say, right? So example says like which address does each element have, right? We all know like when we talk about array or single dimensional array, we always imagine a continuous memory blocks like this, right? We have like studied in our arrays videos that how we have to imagine our 1D array, and I told you that you all have to imagine our 1D array as continuous memory blocks, right? And we have a name of our array, and then we access our elements of array like num0, num1, num2, num3, and num4, and so on, right? So here the example asks a question that which address does each element have. So simply, since we all know that it is a continuous memory block, but every memory block is different from the previous one because everyone is storing a different value, right? So suppose our first element is stored in our like address present at 1000, right? And it contains 4 bytes, right? So the next element would be at address 1004, and the next element would be at address 1008, and we'll keep adding on 4 till the like end of the array, right? Why we are doing so? Because we know that array is a continuous memory block, and whenever a pointer, or should I say whenever we are talking about memory, it always when we talk about like address arithmetic or pointers arithmetic, or should I say whenever we add something, or should I say one in our previous address, it always adds up the amount or the size of the like the element contained in that address, right? We have studied in our previous array or introduction of pointers video, right? So this is how we are getting the different and different address of our different elements in an array, right? How we can we all would be having like question how we can get an access or get to know what address is of an element, right?
for that we can simply use our ampersand operator. We have also studied that in our introduction of pointers video, that what ampersand do. Just to revise, let me just tell you that ampersand help us or return whenever we use this ampersand in front of our variable, right? Here num0 is a variable which is holding a particular value, right? So whenever we use ampersand in front of besides our variable, it just returns the address of that particular variable, right? So this is what it is doing. So since we have used the relational, or should I say comparison operator, right? So you all must have must be familiar to this by now, and it always return true and false, right? So this will return true value if we put it in a conditional statement, right? And so for everyone, right? Because it is nothing but the address of the element, address of the memory block where our zeroth element of the array is stored, right? So this was it in this slide. Let's just move to the next slide and see what it have to say. So since we have named our array as num, so the example says what is num. The question is what is num. Yes, it's right that it's the name of the array, but to the compiler it have much more meaning. To the compiler, the num is not just a name. It have more meaning to the compiler than just a name, right? Here is the answer. Num is also a constant pointer of value, which is the starting address of the array. Or in simple word, should I say that num is not just the name of the array. It is also the pointer to the starting address or the first element of our array. Right. Suppose if we are just having the name of our array, so we can simply access to the complete array just by adding 1 and 1 to till the end of the array, right? Because num is not just the name, it is also the pointer to the first element of our array, right? So this is these expressions are equivalent, right? If I write num or ampersand of num0 or 1000, these all are equal, right? So now moving on to the next slide. Relation exam we are here we are talking about arithmetic of pointers. We have talked about arithmetic of pointers in introduction, that on adding 1, we are not just incrementing the pointers value by 1, we are moving our pointer to the next address, right? We have studied in our introduction of pointers. If you have not seen that video, just go through the introduction to the pointers video and you will get a more clear vision about what this means, right? Pointer plus 1 does not means incrementing the pointer by 1 exactly. Pointer plus 1 is the address of the next element, right? As I told you. And pointer minus 1 is the address of the prior element, right? So also so now we have known this relation that num is equivalent to the ampersand of num0 and is equivalent to the address of the first element, right? So suppose we are having just num. So by this num, how we can access different elements of the array by using arithmetic of pointers, right? Since num is the pointer to the first element, by adding 0 to it, we will be simply accessing to the 0th element by adding 1 to the first, by adding 2 to the second, and so on, right? So this is how we are utilizing the arithmetic of pointers with our arrays, right? So now moving on to the next slide, the arithmetic of pointers. We have seen that we can add, subtract, and to our pointers. So let's just see what things we are doing here. This is our array, and again the usual things. It is an array of size 5, and it is having elements from 0 to 4, and these are the memory address of those elements. So in first block, what we are doing, we are just assigning the elements to our memory block, right?
At num0 we are assigning 10, at 1 we are assigning 20, 30, 40 and so on, right? So now how we can access the like element at particular address without using these square brackets? Some of you might have guessed correctly that by using dereference of pointers. We have studied about dereferencing in the introduction video. Again, I will say, if you have not watched that video, just go through that video so that you will get a clear vision that what dereference is, right? So just a short overview I can give here, that this star we use at the time of declaration of a pointer as well as to dereference a pointer, right? By dereferencing I mean, suppose a pointer is storing like, not just supposing, always a pointer stores a address or it's a null pointer. For a chance, suppose it is storing a address and we want to access the element present at that like address or the memory block of whose address we are having, right? So what we'll do, we'll use this star pointer, we'll use this star in front of our uh, pointer, and this will return us the value which is stored at that memory block whose address is stored in our pointer, right? So this is what we call as dereferencing, right? So simply as we can access the different element by num and adding or subtracting values to the num, and so by this what we can what we can conclude is this, that just a second, so we were able to like dereference or get the element present at a particular address by dereferencing. So num plus 1 is the address of the next element, like, or the second element of the array. So but just by dereferencing that address we are able to access the element and so on, right? And here we have in our third block, we have declared a pointer of integer type, and we have, just a second, we have assigned the address of the first element to that pointer, right? Num is nothing but the address or the pointer to the first element, right? We can also assign pointers to the pointers, right? Here we are just assigning the value of num to the pointer, right? So what we are doing, we just assigned the address in our num to this pointer, and now we are simply dereferencing like this similar way. Just the update is we are using p here instead of num, right? So and the concept is similar here, right? So again, the third block says, since we have like assigned uh, our nums or the address stored in num to this pointer, we can also access that element by using square bracket. So either we can use dereferencing or square bracket, both are equivalent expressions, right? So I hope this is clear to everyone. If it's not, you just make notes of this and revise and practice this concept. It will get clear to you more, right? So here we have, here it's an example, and I want you all to like try this question by yourself and try to get the output of this question, and the answers of this question will be in the next slide, and just try it by yourself, and then I will be then pause the video and try to answer these queries, and then unpause and see the next slide, so that you will be getting that whether it's clear to you or not, right? So these are all things, and we have all studied about these things. We just said that in the introduction video I told you that we cannot subtract pointer with a pointer, but here we can, but only in the case of an array, right? Only in case of array we can subtract pointers, else we cannot, right? So this is the like question you all should try, and pause the video and try this question, and then move on to the next slide to check your answers. I hope you all tried these questions, and moving on to the next slide so that you can tell your answers. These are the answers, and I hope it's clear to you all that how these are the answers, because these were pretty basic questions, and
Yeah, I would love to like discuss this question with you all. And basically, what this question is saying, okay, here Q is nothing but the address of fifth element, right? And it is nothing but the address of first element P, right? So by this, we are what we are doing Q minus 5, that is we can refer it to be 5 minus 1, and which is equivalent to 4, right? That's why we are getting answer as 4. So I hope it's clear to you all, and we'll meet you in the next video. Thank you, everyone. Hey everyone, welcome back to First Mentor. And in previous video, we studied about pointers and arrays. So in this video, we'll be studying about pointers and functions, and we'll try to understand what how we can build a relationship between pointers and a function. So let's just go through these points and try to understand what they have to say, right? So basically, we can also pass pointers in argument instead of passing value of a variable in an argument, right? So basically, why we use pointers with a function is to pass them in their argument, so that we do not have to pass the value of the variable in the argument, right? So why we like pass the pointer instead of passing the value? So when we pass the value in the function as a argument, the function creates its own copy of that value or that variable. By this, we are taking or using space, like the space usage of the program is increasing. But by using pointer, we can simply decrease it. And I believe this is what the second point have to say. The benefit of using the pointer will be that we can directly access the value or make changes in the value by dereferencing the pointer. It will reduce the copying of variable, and also we can directly like access the value kept in that address or memory block and manipulate it, change it, like whatever operation do we have to perform, we can do directly on that. So for this, I believe we should move on to the IDE and try to like understand it a bit more clear. Let me just adjust the screen size for you all. Right, just a second, guys. Yeah. So we are doing, we are just making a simple function to add two numbers, but here we will not pass the variables, we will pass the pointers in our function, and will like directly update the value in our first variable, right? uh, what we'll do, we'll take the input of, here I have taken input of two variables, a and b, and I'm making uh, pointer name as a function name as sum, and I'm just passing address of these two variables. I hope you all know by this video that how to pass address or how to access or get the address of a particular variable. If not, then go to the introduction of pointers video and like watch it so that you can get an idea, right? And what we'll do in this function, in some function, will add the values of these two variables and directly update the sum into the first variable and simply print it in this main function, right? Yeah. So I believe this will work, and let's just try to make the function. And this is like obviously the first return type. It will not return anything. Then name of the function sum, and then here we will make pointers instead of making the variables, right? So we are making the pointers, and which will be storing the address of these values, and like directly now what we can do, since we are having the address of these two like variables, so simply what we can do, we can dereference the value, and what we want to do, we want to update the value of a by the sum of A and B, right? So I hope you all know that this is what we are doing, dereferencing, and this is how we are using it. And now simply our work is done in this function and we'll simply return. Let's just try to run this function and see if it's returned the correct value or not. I just have given input as 2 and 3, and let's just see if it works or not. So it's just working fine, and so I believe this is clear to you all that how we can use pointers with our function. Let me just adjust the screen side and take you back to the PPT. So now getting back to the PPT, we can also pass our arrays as like in terms of pointers to our function, right? So we have all seen this, how we can take the address, or suppose we are having the address of our first element of an array, we can access all the elements of that particular array, right? So simply what we will try to pass the address of first element of our array to the function, and we'll try to access that, right? So I guess just a second, guys. So here is an example that how we can like pass our array in terms of pointers to a function. So let's just go through this example, and it will be clear to you all, right? So this is, we have made an array of 100 size, and then we have a integer variable k, and what we are doing, we are just running a loop from 0 to like 99. By less than, I mean I will run up to 99, and our value of k will never hit 100, right? And I hope you all remember the syntax of for loop. This is the simple for loop, and then what we are doing, we are simply inputting the value of we are just simply inputting the value for our array and putting inside the array. So now what we are doing, we are simply calling a function as sum and passing a, that is the first address, or which is also the name of the array, but also the pointer to the first element of our array, and 100, that is the size of our array, to the function, right? So this function is of int type. That means it will be returning integer value. Then we have name, then we have int num, and these square brackets, right? This is the way of accepting, or getting the argument as a pointer of array, right? Suppose we are passing a array in terms of pointer to a function, we will receive it like this, right? Or we can receive it like this also. These both things are same, right? So just don't get confused that whether to use this star or to this. If you can simply use this also, and then we are receiving size and then sum, and simply we are getting the sum and returning that sum. So this is as simple as this. So I believe functions and pointers are clear to you all, and will I hope you got a clear vision. I just want you all to try and practice this question, practice questions with pointers, and we'll see you in the next video. Thank you, everyone. Hey everyone, welcome back to First Mentor. And so far we have studied about pointers. We have studied about pointers and arrays. We have studied about pointers and function. So now we will be studying about dynamic memory allocation. So before getting into dynamic memory allocation, we should know that how many types of memory allocation we have. Basically, there are two types of memory allocation to a variable in a program. Basically, we can allocate memory in two types to a variable in a program. That is, first by static memory allocation. By static memory allocation, we can assume by the name static, that means it's allocated at once and cannot be resized again and again in the program. And also in this, memory is allocated to a variable before execution of the program. Like before running of that program, the memory is allocated, and there is that memory to the variable is fixed. That means it cannot be changed, right? So now coming to the dynamic memory allocation, In this, memory is allocated to a variable at the runtime. Like at the time of running of that program, the compiler allocates the memory to that variable. And also, as the name says, dynamic, the size of the variable can be changed, right? So the next point says the only way to access this dynamically allocated memory is through pointers, right? By only using pointers, we can access this dynamically allocated memory, right? So I believe now you get an idea that how we why we studied pointers and what's the importance of pointers, right? So now moving on to the next slide. Memory allocation process basically we have these two types of memory at the time of program, that is local variable, and free memory, that is heap, and this is stack, right? At the time of program running, or should I say at the time of like before compilation, at the time of like making or assigning value, making of the variables, we use memory from this stack memory, right? And whatever the memory we allocate at the time of running is used from this heap memory, right? And this is like a permanent storage area. We generally not like think about it, we just only play with these two types, right? So now moving on to the next slide. Memory allocation functions basically like when we talk about dynamic memory allocation, it's not allocated by itself, we use the inbuilt functions to allocate it. And basically there are two functions to allocate the memory, those are malloc and calloc, right? Malloc function and calloc function, these two are used to allocate the memory dynamically, right, in a program. Right. Again, the name, again, this function free, as the name suggests, is used to free the allocated memory, right? And reallocate is basically used to resize the allocated memory, right? So let's just go through these description in malloc. Allocate a requested size of bytes and for return a pointer first byte of the allocated space. Basically, we give the size or the number of bytes we want to allocate while using malloc function, and then it returns the pointer to the first byte of allocated space, right? So I hope like you are getting what I am trying to say, right? And calloc allocates space for array elements initialized to 0 and then return a pointer to the memory. So what calloc do, basically it allocate memory for arrays or array elements and initialize them to the 0 and return the first or the pointer to the first memory block or the first element. This is what calloc do, right? So it does not mean we cannot make array by using malloc. We can also make array by using malloc, but it's like more preferred to use calloc while allocating arrays, because it is made for allocate memory for these kind of types only, right? So then coming to free, it's used to deallocate the previously allocated space, right? Then reallocate changes the size of previously allocated space, right? To resize the previously allocated space, we use resize or reallocate, should I say, right? So moving on to the next slide, we have allocation a memory block using malloc, right? Let's just go through it and try to understand how we can allocate a memory using our malloc function, right? Malloc function is used for allocating memory block of memory at runtime, like as I told you that dynamically we allocate the memory at the time of running, and the memory which we allocate is in heap memory, not in the stack memory, right? The function reserve a block of memory of given size and return a pointer of of type void, right? This is very important, right? It always return a pointer of void type. Then we have to typecast this pointer or change this type of pointer to the desired type, right? So by what I mean desired type and typecasting, do not get scared. We'll be reading or studying this through the example which I have attached in the next slide, and we will be going through that, and it will give you a clear vision what this means, right? So by this you just like it returns a type void pointer. That means it does not points to any memory, right? Or the type of that pointer is void, and we all know that what the void means. It is not returning anything, or it is null, right? So let's just like understand the like a syntax of like allocating the memory dynamically using malloc function. Firstly, we have a pointer, right? Which we will be assigning the value which our malloc will be returning. Basically, like we typecast the pointer, right? Suppose we want to allocate a memory of integer type, right? So we will pass the size of an integer here, and malloc will like make a memory block of integer type, and it will return a pointer, but that pointer will be of void type, right? But here we have made a pointer of integer type. So to like store the value in this pointer, we have to like change this void type pointer to the integer type, and we are doing that using this typecasting, right? So here what we like how we do typecasting, it's simple, just write int and then star. Since we are like we want the pointer of integer type, that's why we are writing int star, and that's it, right? So I hope it's clear to you all that how we are allocating memory dynamically using malloc. And moving on to the next slide, we have a function which in which we have just a second, guys. So we can see an example here of code that, in which we are allocating the memory using malloc function, and let's just go through it and try to understand what it have to say. So firstly, we made a pointer of integer type, right? Then we assigned the value to this pointer, what this malloc function have returned, right? But we also have to typecast this pointer, because malloc always return a void pointer or type void pointer, right? So by this 5 into the size of int, we are not just like making a single block of memory, but we are making 5 blocks of memory which are of size int. That means we are simply allocating a array by using malloc function, right? So if the pointer is equal to null, that means memory not allocated. That means our heap is out of memory, and we are not able to like allocate any memory. Otherwise, we have allocated the memory, and we will simply uh, like use. We can simply use this pointer as to the name of the array. And you all know like how to play with pointers and arrays. We have already discussed it in our pointers and arrays video, right? And in the end, we just have write free and write the name of the pointer to that memory, and we are able to free that memory, right? So now moving on to the next slide, we have allocation of memory block using calloc, right? Calloc is another memory allocation function that is used for allocating memory at runtime, right? So calloc function is normally used for allocating memory to derived data types such as arrays and structures. Do not worry about structures, we'll be studying them in the upcoming videos. But here you know about arrays, and you can understand that calloc is used to allocate memory to the derived data structures or derived types like arrays, right? Again, we have the syntax of calloc. How we use calloc? Simply then pointer, we assign like the value to the pointer whatever returned by the calloc function, right? So we simply typecast the pointer which are this calloc function will return, right? So what we'll do, we'll write the calloc, then the size of the array we want to allocate, the number of elements we want in our array, and the type or the element size. That means integer type or character type, what type of array we want, right?
then the pointer will be returned by this function, and then we will typecast that pointer into the type we want, and then we will assign that value of pointer to this ptr which we have declared in our function, right? So now moving on to the next slide, it is a bit similar function to the malloc, just a single difference that here we use n comma element size. In malloc we were simply using element size, right? So now moving on, we have an example, and you can see here we have declared two variables I and n, and again we have declared a variable. It is a pointer type variable, and it is of integer type, right? Then we take the input from the user, that how many elements they want us to make in our array. Then we assign the value to the pointer or the address to the a, and we typecasted it to be of int type because we want an array of integer type, right? Then again calloc, then the number of elements, then the size of each element, that is what the type of element, right? If we want array of integer type, then we have to pass the size of integer. Then if we want this like array of character type, then we have to pass the size of character, and so on, right? And then again we can play with this pointer, like we used to play with the array and pointer, right? And again in the end we can simply free the memory, right? This is how we are accessing or making memory or allocating memory using calloc and malloc function, right? Moving on to the next slide, altering the size of a block which we have already allocated using calloc or malloc, we can do this using realloc, right? Realloc changes the memory size that is already allocated dynamically to a variable, right? How we can do that? Again the pointer, then we call the realloc function, and then the pointer to like then the pointer of or the pointer to the memory block whose size we want to change, right? Then we just have to write the new size, and simply it's done, right? It's simple, and we will be seeing the example and it will be more clear to you all. Let's just move to the next slide and see. Suppose we have uh, allocated a array of size 2 using malloc function, and then we have made another pointer which is named as pointer new. We assigned the value to the array of size 2. Then in new pointer, what we did, we simply called the realloc function. We passed the array, we passed the pointer to the array, and then we resized this array to be of 3 size, right? And then we again typecasted that pointer which is returned by our realloc function, and then we stored that in our new pointer variable, right? And then we can simply dereference and change the value, and we can play with this similarly as we play with the pointers and arrays, as we have learned in our pointer and array video. If you have not watched that video, I would prefer go and watch that, and you will be able to understand this thing more better, or much in a much better way, right? So now moving on to the next slide, releasing the space using free, right? Free function should be called on a pointer that is used either with calloc or malloc. Otherwise the function will destroy the memory management, making a system to crash, right? We can only pass the pointer to the memory which is allocated by calloc or malloc. Otherwise if we pass something else, it may lead to the crash of our system, because it will free all the memory or the wrong memory, right? And it is like free and then the pointer, right? So yeah, that was pretty much it about dynamic memory allocation, and I hope it's clear to you everyone, and we'll meet you in the next video with new topic. Thank you everyone. Hey everyone, welcome back to First Mentor, and in today's video we will be studying about strings in C, and we will be studying about strings and functions, and some inbuilt function which are provided to us by C, so that we can play with strings, right?
So let's get started. So introduction. Strings are arrays of character, that is, they are character arranged one after another in memory. Thus, a character of array is called string. So a string is nothing but a character array. That means an array which only contains characters, right? And we all know that we assume an array to be consecutive memory blocks, and in all those consecutive memory blocks, we store characters, and that cumulatively called to be a string, right? That is what we call a string, right? In another word, we say character arrays a string, right? So next point, each character, each character within the string is stored within one element of the array successively. As I told you, we assume an array to be consecutive memory blocks, and in every consecutive memory block, there is a one element or one character stored in it, right? So that's how we are storing a string in our character array. Next point, a string is always terminated by a null character. This is a very important point, that in our C programming language, a string or a character array always terminates with a null character, and this is how we represent a null character. And you do not have to worry about that how you will be writing this null character, because it is like added to the string by the like compiler itself, right? So now moving on to the next slide, arrays and strings. So as I told you that what we assume a string to be in our C, that it is nothing but a character array, right? So what the operation we can perform on a character string or a character array in C is that like we can read and write a string, we can copy one string to another, we can combine strings together, we can comparing strings for equality, like one string is equal to another string or not, extracting a portion of a string. These are few operations we can perform on our character array or strings in our C. We will study how we will do that. There are few inbuilt functions which we use to do these jobs done, right? So moving on to the next slide. A string variable is declared as an array of character. As I told you, we assume our string to be array of characters. So it is like declared similarly as we declare an array, right? Just the difference is that here the data type will be of char type, right? Then similarly, like we define a array, data type, name of the string, and then size of the string, right? Like char, name of the string, and then size of the string, right? This is example, right? Moving on to the next point, when compiler assign a character string to a character array, it automatically supplies a null character at the end of the string. As I told you that we do not have to worry about that how we will be assigning the null character to a string, because a compiler do this job for us. We do not have to worry about that how we will be putting null character at the end of a string, right? So moving on to the next slide, initialization of string variables, right? Since we now know that how we have to declare a string variable and what are string variables, or how we have to assume a string variable to be like right. So now we should understand that how we should initialize our string variables. Again, there are two forms of initializing our string, these are the two forms, this one and this one. Let's just go through them and try to understand. Like, so in this way, for what we have done, we have defined or declared our string or character array, and then size, and then what we have done, we have used the assigning operator, and then the curly braces, and since we are assigning like this, in this we have to write the null character by ourselves, right? Suppose we want a character of we want a string of size 3, then we have to declare a string or character array of size 4, right? You know, like how the character how the like size and arrays work.
we know that I have told you that it always go from 0 to the size minus 1, and it is going like this only, and we do not assume this to be a part of string. It is just an indication that here the string have terminated, like all the characters before this are the part of the string, right? So this is not considered as the like size consuming part of the array, right? So just do not get confused. This is just an example, like exception in case of character array or strings, right? This is the one way of assigning string to our character array, and the another way are just by using double quotes and writing the string inside that, right? And another way is like without like defining the size and just assigning the string like this, right? And in this what would be happening, like ram would be in ram the like zeroth character would be stored to the zeroth index, and the second a is assigned to the first character and m is assigned to the second character, right? And third character is of 4 size, and like in the last like element or the size, we just have assigned the null character. You can see here we do not have written the null character, but when the compiler would be assigning this string to our character array, it will assign the null character by itself, right? So we always have to assume, we always have to remember that whatever the size of the string we want to take input, we have to take one size greater to be the size of our character array, right? I believe I in the starting I just said the opposite thing, but I wanted to say that we always used to take the size of the array to be the size we want to take the input, but in case of string we will take the size plus 1, right? So that we can accommodate null character in the end, right? And this would be in case when we are initializing our strings, right? Like this, or in this case we do not have to worry about that how null character would be assigned, because compiler will take care of that. But here we just remember that ram is of size 3, but we are taking like size of the character array to be 4, so that we can accommodate null character in the end, right? So moving on to the next point, when we initialize a character array by listing its elements, the null terminates or the size of the array must be provided explicitly. That means we must provide the size of the array, right? Explicitly means we have to provide it by ourselves, right? Moving on to the next slide. Reading and displaying of the strings, it can be done manually. Here is a snippet of code, and we can see that how we can take input of a string as well as we can print a string, right? So we have declared a string like char name, and we have taken the size of the string array or character array to be 30, and then we have declared a character variable ch, right? And then we are running a while loop. For that while loop we have like what we have done, we have initialized a variable I in type to be 0. And why we are doing this? So that we can iterate over the like array, this array, right? And since the indexing starts from 0, we are initializing our this variable I variable to the 0, right? So what we did, print, we just simply printed enter the name, and then we initialized our loop, while loop, and here ch not equals to the next line or new line, right? This means this is a bit of advanced loop which we have used here. So I'll try to explain it to you, and I'll try to show that how we can use it with our for loop as well. Or I believe in next example there is for loop which we have taken in account, right? So here what we have done, we have initialized our character array, character variable, and we are just taking input of this character like variable, and till the time it's not equal to the new line, right? This backslash n is means new line. I have taught you in the operators video of this course. So this while the character is not equal to the new line, we will be just inputting the character, and this loop will be running,
right? What we have done, we have taken input of the character array. We can take input by get char. Also, we can take input using scanf. Right. In next example, there is scanf also. We will be seeing that how we are taking like input using scanf. Since we are not taking input using scanf, that's why we are running this loop. Right. It's a bit complex, but try to understand, and the things will get much simpler when we will try to do the same thing with scanf. Right. And it's like I'm showing you this so that you can like understand why we use scanf instead of this, right? And what are the another way of taking input except scanf, right? So I hope you understand till when this while loop will be running, and then we take input of the character, and then we put it that character inside our like the first index, right? And then we incremented the index, right? And this is how it is like filling this character array, right? And in the end, when we came out of the loop, that means there is new the like user terminated the input, then we exited this loop, and in the end we put it in the null character, right? And simply we can scan up the name by using printf percent s and the name of the string or the character array. Just by like writing the name, we would be able to print the name, right? We do not have to iterate over the array like we used to do in integer array, right? We do not have to like use a iterator to print this, right? This is an exception we get through we use or we should understand while working with character arrays, right? Moving on to the next slide, I hope this is clear to everyone. Using printf and scanf, now the things will become much easier, right? We just declared the character array, we printed that, enter the name, and then we simply scanned that name into our character array itself, like this, right? Scanf, percent s, and name, right? This is how we simply take input of this character array, and the things become much easier for us, right? And simply like how to print percent s and name of the character array or string, right? So now moving on to the next slide, using getS and putS. I told you in the like earlier videos that getS is used to take input of the string, and putS is used to put the string into character array, right? So simply let's see that how they are working. We declared the character array or string, then we like printed that, enter the name, and then we simply wrote this getS and the name of the string where we want to take the input of the string which user is giving us, right? And then simply uh, printf name and putS to display the string. Right. It is as simple as this by using getS and putS. Now it's up to you that do you want to use scanf printf or getS putS, and that's how it works. Right. So now moving on to the next slide. I believe we should keep this still here in the introduction, and in next we will be discussing about like the string functions and the inbuilt functions provided to us by the C to play with strings, right? So thank you everyone. Hey everyone, welcome back to First Mentor. And in previous video, we started strings. We studied what strings are, how to declare strings in C. And from this video, in this video, we will be studying about strings and functions. That how should we pass strings in a function, and the inbuilt function provided to us by the C, so that we can play with strings, right? So like here is an example that how we can pass a string in a function. But first of all, before like going to this example, like it is like, since we know that string are nothing but the character array in C, so it will be similar as passing a array to the function, right? So this is what we are showing in this array, in this example, right? We just like write the prototype of our function. This is our main function. We declared the string. We take input of the string. Then we call this function and passed our string in this uh, function, like display function, right? And in display function, we received it like we used to receive a array, right? And then we simply printed it, right? This is as simple as this. There is nothing much in this, like strings, like how to pass strings in a function. This is it. Like this is how we play with, or this is how we pass strings in functions, right? So now moving on to the next slide. Inbuilt functions or inbuilt string functions in C. There are few functions which are provided to us by the C, but these functions we can only use if we include string.h header file in our function. Right, and let's just go through this functions and try to understand that how this function, what are these inbuilt functions and how they can help us while writing our program, right? So the first function is strlen, which used to calculate the length of a string. That is how many characters are there in a string, right? strcpy, it is used to copy a string to another string, right? Suppose we have two strings, we can copy one string to another just by using this like inbuilt function, copy string, right? And then we have strcat, which is used to concatenate or join two strings, right? Then we have strcampr, which is used to compare two strings. That is how many characters are different in like given two strings, right? Then we have strlwr, which is used to convert string to lowercase. That means all the character of the string will be converted to lowercase. Then we have strupr, which is basically used to convert string to the uppercase. Let's just move to the IDE and try to use this function so that you can get a clear vision and you will be able to use this in your program also. So let's just move to IDE and try to see how we can use these inbuilt functions in our programs. And this is our GFG IDE, as you all know. And let me just adjust the screen so that it's a bit more clear to you all, right? Just a second, guys. I hope it is like clear to you everyone, right? So what we are doing, let me just reset the IDE and let's just start, right? So what we will do, we will make two like string or character array, uh, char s1, and I'm not taking input from the user. I'm just defining it to be uh, defining it by myself, and I'm making another uh, char array or string, and I am, let me just initialize them. I just have wrote two strings, right? And I hope it's clear to you all that how these will be working inside, because we have studied that in our introduction to strings in C video. And if you have not watched that video, I'll prefer that if you watch that video, you will be able to understand it better, right? So now let just make two variable and try to figure out what are the lengths of these two strings, right? And let just length A will be storing the length of first string, and for that there was the uh, function strlen, and we will just pass the name of the string or character array, and this is done, right? Let's make another variable and try to uh, get this length of second string, and this is done. Let's just try to print the lengths and see if these are right or not. S1 %d is A, and this would be much better if I write it like this, so that we can write we can write in the new line, right? %d \n for the new line and B, and that's it. But I hope you are able to figure out a mistake in here, that I have not included the string dot h header file, because if we not include that header file, we'll not be able to access these functions, right? String dot h string, right? So this is it. Let's just try to see if this is working or not, right? If this is working, I believe this will be working, right? So this is working just fine. Length of first is 7 and the second is 19. Just remember, it is also counting the blank spaces. You can count it by yourself and see if it's right or not, right? So that this is working fine. So let's just move on to the next function and see how to use the, like, string copy function, right? So let me just make another string so that we can copy the string in it, right? So it is string char, and I'm just naming it as S3, and for safety I'm just initializing it to be of size 100, right? Because we like, I'll be copying let's say second string in it, and it would let me just try to take the buffer, right? So that we are not like overflowing the say a third string, right, while copying strcpy, and in this we pass two arguments, right? The first argument would be the string in which we want to copy the string, and the second argument will be the string which we want to copy in the first argument, right? And now just try to printf and printf and see if it is working or not. Copy string %s and just name of the string as I told you, right? It's S3, right? Also, let's just try to add \n so that we can use it in the new line, right? And let's just try to run it and see if it's working or not, right? And it's working. Copy string is first mentor, and this is what exactly it was. And this is, I believe now it's clear to you that how we are using copy string function, copy string inbuilt function, right? So now moving on to the next function, that is concat, and let's try to see how to use this function, and its name is strcat, and in this again we pass the two character. The first character is the half string, and the second character would be the another string. These two are the string. We are passing two arguments, and both are the strings, and both are the strings which we want to concatenate or join to make a single string, right? So that we can so in concatenate function, basically we passed two arguments. The first argument, and both the arguments would be the strings, and these two strings are the strings we want to join or concatenate. And after concatenating, these two strings will be stored in the string passed in the first character, right? So let's just try to print our first string and see if it is concatenated or not, right? And uh, joint string is %s \n and s1. Let's just try to see if it works or not. So if you are able to see that this is the first mentor program, though there is no space in between, because
they are joined from the last character and the first character, right, and have made it to the one character, one string, right. So this is how our concatenate function or str concat function is working, right. I just have commented out so that we can use the strings in next function, right. The next function is strcmpr, right. In this, basically, again we pass two arguments. One is string 1 and another is string 2, and basically we will compare whether string 1 is equal to string 2, or how many different characters do we have. And I believe it will be returning us a character, and let me just store it into uh, like character variable, or sorry, that like integer variable, and str cmp is the name of the function, and we are good to go now. I believe let's just print how many different characters are there. Differ char in percent d and backslash n and c. Let's see if it works or not. And it's working, and it shows there are 35 different characters in both in s1 and s2, that means in string 1 and string 2, right. And this is how it works. And there is nothing much in strlwr and strupr. You just have to pass one argument, that is the string you want to convert into the lowercase and into the uppercase, and that's it, I believe. And let me just try to show it to you, and let me just convert it into the upper string. This is Mohit, right. And let me just try to uh, convert it into lowercase strlwr and s1, that is the string I want to convert. And let me just print, or simply put s1. Let's see if it works or not. And it will work, but there will not be it would not be in the new line. I have done some mistake. Maybe I have not uh, written it correctly. Just give me a second, guys, so that I can figure out what's the mistake. So I just remember that strlwr is a bit of primitive function which works with only old Microsoft C version. I believe like in this ID they have upgraded it. That's why it's not working. But we can see in the example of GFG itself that I hope you are able to see. Let me just adjust the screen size a bit. Right. So you can see LWR is an inbuilt function, and it just returns the string which converted into lowercase, right. And note, this is non-standard function, right, that works only with the older version of Microsoft C, right. And this is how it used to work, right. So but now I believe they have upgraded their IDE, that's why it's not working with it. But that this is how it used to work. So I believe that it's clear to you everyone that how we will be using inbuilt function and how we will be playing with strings. So I believe you should try a few questions of strings by using these tips and tricks, and we'll meet you in the next video. Thank you everyone. Hey everyone, welcome back to First Mentor. And previous videos we started about pointers, strings, and now we are moving on with the next topic, that is structure and union. And we are going to study about structure and pointers, structure and functions, and unions in this lecture, right? So moving on to the introduction. But before moving on to the structures directly, I just want to revise that data types, though we have studied them before, but I want you to revise them so that we'll be able to understand structures a bit better, right? So let's get started.
C programming language have ability to divide the data into different types, right? Since we are about to end this course and we have came across a lot of examples and we were able to see the data was divided into different types. Some was of integer type, some was of character type, some was of float type, right? So since we know this thing, the type of variable determine what kind of value it may store on, right? It may take on, right? Like the type of the variable will define whether it will take integer, float, or a character, right? So basically, we have these like few data types divided or categories divided into data types. Let's just go through them and try to understand, right? We have simple data types. Those are like int, character, float, etc. These kind of data types are called simple data types, right? And then we have structured data type. Those are arrays and strings. We have like these data types are structured and are, we all know that how we have to assume these data types to be, right? So now moving on to the next part, and this is the one of the most important because we will be working around these data types in our structure and union video, and these data types are user defined data types, right? In user defined data types, we have structures and unions and enum, right? Basically, what they are in this, a user, that means you and me define what kind of data type it will be, right? So moving on to the next slide and try to understand what a structure is. Right, going through these points, let's just get started. A structure is a user-defined data type, as we know, that groups logically related data items of different data types into a single unit. Right. What I mean by logically related data items, I mean that like suppose you are a student, right? And you have a name, you have a roll number, you have a college ID, right? So these all things are logically related to a one person, that is a student, and that student is you, right? That were by that what I mean logically related. But all of these data are of different types, right? Like name would be of character type or string type. Roll number would be a integer type, and your college ID would be also of integer type, right? And we will combine them to form a single data type. And let's suppose we name that data type to be a student data type, right? And that student data type will contain different data types, but which will be logically related to a single person or a single item, right? Right. That's what user defined function means, or user defined data type means, and that what structure do for us. Right. Moving on to the next point, all the elements of structure can store multiple data items of different data type under one name. As I told you that suppose user defined data type is student, and that is storing a name, college ID, and a phone number, right? So up in this we are having two integer type values and one character or string type value. So that's what it is saying, that it would be storing multiple elements, multiple items of different data types under one name, and that one name would be, in our example, that would be student, right? Here we have an example, as the data of an employee in a company is that like the data of an employee in a company is name, employee ID, address, salary, address, phone number. Uh, these are the basic data when it comes to an employee is stored or related to a employer, right? So in this, name would be of string type, employee ID would be of integer type, salary would be of integer type, and address would be of like string type, and phone number would be of integer type, and those are logically related to a single employee, right? And that would be stored under a single name or a single data type, that would be, let's say, employee, right? So that was a brief overview about structure or what structure do for us, right? We'll move on to the next slide, and we'll see that how we define them, how we use them, and so on, right? So now moving on to the next slide, defining a structure. So basically, we have a definition or how we should define a structure, right? A structure has to be defined before it can use.
as we know that before declaring before using a variable, we need to declare that variable. Similarly, to before to use that user defined variable, we uh, we need to define that user defined data type, right? And the syntax of defining a structure is like this is the basic structure how we define a user defined data type, right? Here first we write struct. This is a keyword which we use before like making a data type of user defined struct. Then the name of the class or the name of the data like data type, suppose int or so on, like we have in our primitive data types, right? So we have struct, then name, let's say employee, and then starting curly braces, then ending curly braces, and semicolon, right? And there would be a bunch of lines in between those curly braces, and those bunch of lines would be like a data type and variable name. For example, string name, like suppose if we talk about employee data type which we want to declare by ourselves, so what we'll do here, we'll write struct, then employee, then employee is having a name, then we'll write here string name, then employee is having a salary, then int salary, then employee is having a employee number, then int employee number, then employee is having a address, then string address. Like these kind of things we are clubbing inside a single data type, and that single data type would be named as employee. Right. I believe like it's clear to you. Right. Moving on to the next slide, you got a brief idea, I believe, like by this example or by this definition. And we'll move on to the next slide and try to dive deeply into the details of structure, and we'll try to understand it better. Right. Moving on to the next slide. Example we are having here that let's say structure of employees declared as struct employee, then it is employees having a employee id, name, salary, address, department number, and a age, right? So how we are declaring a data type named a user defined data type which is named as employee. Firstly we are writing struct, then we are writing employee, then curly braces start and curly braces end, and the ending curly braces would be having a semicolon. So in between these two curly braces, what we are writing, int employee ID character. We know like this is how we define a string in C, right? The string is nothing but a character like array. If you have not watched the videos of strings, I believe you should go and watch that so that you would be having a clear vision why we are calling this a string, right? Then we having salary, that is a float type because salary could be in points as well, right? Then next we have address, that is also a string, and we are defining a character uh, array for that. And then we have department number. For that we are using int, and then we have age. We are using int again for that, right? So moving on to the next slide and try to understand it more better. And here we have declaration of a structure variable, right? So how we define a structure variable? Suppose we let's just suppose that we have already defined a struct data type, right? That is a user defined data type. Now we are trying to use it in our main program, right? So what we will do, how we will define that variable in our main program, we will firstly type the struct. This is the keyword which we use while defining, and while declaring a variable of that data type, we will use the struct again. Struct the name of the data type which we have made. Here it is employee, so we will write it employee, then the variable name, let's say employee 1, right? Or e1, here it have written like this, right? The example to declare the variable for defined structure employee, we are using like this is the example how we are writing for this user defined data type, right? We are writing struct, then employee, then e1. It is similar to writing that it is similar to writing like int a, right? Here just this is the data type, and this is the special keyword we are adding before using this data type, right? So what we'll do here, even variable contains 6 members in it, right? That are defined in a structure, and those 6 variables are these, right? So I believe it's clear to you everyone that how we are declaring a structure, right? So now moving on to the next slide, initializing a structure member. Suppose we have declared a variable this, and now we want to initialize all these members inside that variable. So what we will do, there are basically two ways the member or individual structure variable is initialized one by one or in a single statement. There are basically two ways which we define, which we use to initialize the variables or the member inside that structure, right? So these two ways are one by one or by in a single statement, right? So here is an example, or these two are the ways I am talking about. Like suppose I have defined this variable. So what we can do, we can simply initialize it here like this, right? Firstly, we have put it in one, that is the employee ID. Then we have put it in the name, right? Then we have put it in the salary. Then we have put it in the address. Then we have put it in the uh, then we have put it in department number, and then in the end we have put it in the age. Here it will not end with the like here it will end with the curly braces, like here it is starting with, right? It will also end with the curly braces, and in the end it's semicolon, right? The another way which we can initialize our like variable or the members inside our variable is, suppose we just declared our variable like this, right? And then now what we'll do, we'll try to access all its member one by one and try to put a value in it. How we will try to access the members one by one? Firstly, we will type the variable name, that is E1, right? E1 dot, this dot means get inside this E1. This dot means get into the employee or get into the variable, and like this is the member function which that variable is holding, right? Employee ID, name, salary, address, department, and age. So what this dot will convey to the compiler, that this dot and get into this variable and fix its employee ID to be 1, and similarly with the department number, and then with name, and then with age, and similarly with the salary, and similarly with the address, right? So now moving on, I believe now like initialization is clear to everyone. So that this video will not get too long, I'm dividing into the two parts, and we'll meet you in the next video. Thank you everyone. Hey everyone, welcome back to First Mentor. And in previous video, I believe you all have watched the previous video, and that is the first part of introduction to the structure. And in that video, we studied till that how to like initialize our structure or the variable which we have declared using our user defined data type. Right now, we will try to study that how we will access a structure member. What is a structure member? That is all the variables which we have defined or made inside our user defined data type. In case of our employee, we had employee ID, salary, name, address, etc. So all those numbers are structure members, right? So let's just get through this paragraph and try to understand what it have to say. The structure members cannot be directly accessed in the expression. Like we cannot simply write employee ID and put it a value. We cannot do that, right? They are accessed by using the name of the structure variable followed by a dot, and then the name of the member variable. Right, as I told you, the variable which we have declared using that user-defined data type, that name of the variable, then dot, and then the name of the member variable which we want to access. Right, the method used to access the structure variable are E1, that is the variable name, dot,
employee ID, that is a member function or a member variable, right? So this is how we access all the members inside our struct. Right, I believe in our initialization video we went through them, like how we will access them and update their values, right? So the data within the structure is stored and printed by this method using scanf and printf statement in C program. Like if we want to scan the values from the user, we'll use scanf using these kind of methods. We can write scanf like ampersand e1 dot like emp id and like e dot name, e dot salary, and this so on, like, and similarly with printing statement, right? So I believe it's clear. Now moving on to the next slide. uh, Array of structures. Like similarly, since we can make array of any kind of data type which we have in our programming language, right? So structure is another type of data type which a user defined, right? So we can also make a array of this structure or the user defined data type, right? So how we will make them? Let's just go through it, right? C language allow us to create an array of variable of structure. Right, the array of structure is used to store the large number of similar records. We all know that array is used to store the data of similar types, but in like bulk, like we can store a lot of that similar data, right? For example, to store the record of 100 employee, then array of structure is used, right? The method to define and access the array element of the array element of array of structure is similar to the way of other array. As I told you, we simply have to assume it to be a simple array, like we used to define for int or character type, right? The syntax to define the array of structure is, firstly we always use the struct while defining a variable using user defined data type, right? Then the structure name, that is the data type which we defined, and then the array name, and then the size, right? In previously in primitive data type, we just used to write the data type, name of the array, and then square brackets and the value or the size of the array. But here just one thing is added on, that is struct. Like here we can see in the example, struct employee e1 and the array size in the square brackets. This is how we are like making a array of structures. So I believe like making is clear. So moving on to the next slide. Here we have an example of like how we are taking input of the taking input of array or the array of structures, right? So this is the like header files which we have included, and this is the data type which we have made. uh, like let me just go through it and tell you all what like you all must be knowing by now, but let me just go through it, right? Struct which we defined before defining our user defined data type, then employee which is the name of our data type, then curly braces and the ending curly braces with semicolon, and between both the curly braces we have employee ID which is of integer type, then a string of name, then a float salary, character string of address, and int of department number, and then int of age, right? Then we come to our main function. We just simply declared our array of structure by this, as we learned in our previous slide, and then we declared a for loop. We can declare a variable here as well as in here for loop, and then simply we printed like enter the employee ID of the employee, right? And then simply using the scanf and ampersand ei dot ei means the ith employee ID, right? For the first employee till the 100 employee, right? Here we cannot go to the 100 employee because we are just making it to the size of 5. So we can like reinitialize or change the size of the array to be 101, because we all know we move from 0 to the size -1 in our array, or the indexing in array moves from 0 to size -1, right? So ith employees ID, and then ampersand which we use to take input. Right, and similarly, we will take input of all the things for a particular employee. Right, this is how we are taking input to a class or a user defined data type, right? So now moving on to the next slide, we have structures with structures, right? uh, this means we can declare structures within a structure. Let's just go through it and try to understand it a bit better. C language define a variable of structure type and a member of it and as a member of other structure type. Let me just go through it once again and try to make a bit clear to you all. A C language define a variable of structure type as a member of other structure type, right? As I told you, structure which we are using to be of others type, right? The syntax to define the structure within structure is like how we will define a structure within a structure. Like then firstly we'll write struct, then the name of our like data type, then we have a bunch of primitive data types or the member function, then again we are using struct and the name, so that we can what should I say, make the structure inside that structure, right? We just named it, and then curly braces here starting and curly braces ended, but here it is a there is a different. We are also defining the structure variable at the time of initializing or making of it, right? The structure or the data type which we are making inside the outer structure or the data type, user defined data type, we are initializing or giving it a variable name inside like just after defining it, and then semicolon, right? And we will it will be more clear when once we go through the example, and I believe it's on the next slide. And moving on to the next slide, and let's see, here it is a structure of employee is declared as the structure. Like we are declaring structure of employees again, like how we are declaring it, struct employee, and then again curly braces start and end with the like in the end we are using like semicolons, and then we have int employee id, string name, float salary, and department number, and then here it comes to be date. Like for date, what we are doing, we are simply defining a structure inside our employee structure, right? What we did struct date, and then curly braces and curly braces, and just after the ending curly braces, we defined a variable name for this data type, right? DOJ in this like example, right? Inside that date data type, we just declared day, month, and year, right? This is how we are using structure inside a structure, right? And we'll see how to use it in the next slide. Moving on to the next slide now, accessing structure within the structure. Now here we will understand that how we can access a structure which is present inside a big structure or a structure, right? The data member of a structure within the structure is accessed by using 2 points or 2 periods, right? This is dot symbol, right? The syntax to access the structure within the structure is it is a bit like confusing, so let's just move to the example directly and try to understand. Even is the variable name which we made for our employees, and then what we did, we said our compiler, a compiler, just move into this variable and go to dog variable, and then dog is again a structure or a user defined data type. Then we can use again this dot uh, like syntax to move inside this dog, and then again we use dog this dot to move inside dog, and then we access date, right? This is how we are doing it. So I believe it's pretty much clear to you all with this example. We should keep this video till here, and in next video we will study about pointers and structures and pointers and functions, right? So yeah, meet you in the next video. Thank you everyone. Hey everyone, welcome back to First Mentor. And in previous video we studied about structure. We digged deep into the structures, and we studied everything about structures. Now I believe you all are comfortable with using structures and how to use or how to make your user defined data types and how to declare variables of those data type, how to access the member functions or member variables of that struct, and so on. Right. So now in this video we are going to study about pointers and structures and functions and structures. Right. So let's get started. A C language can define a pointer variable of structure type. Like we can similarly treat it like we used to have pointer of integer type, character type, and we all have gone through like how to pass those pointers in our functions or how to use them to dereference and get the value. Similarly, we will be using the pointers with the structures. We have to like treat it similarly, but there would be a just simple difference, and we will see what that difference will be. Let's just go through these points first. The pointer variable to structure variable is declared by using the same syntax to define a pointer variable of data type. As I told you, we have to treat it similar to the other pointer of other data types, right? The structure to define the pointer to structure is struct. We always use this special keyword whenever we are using our user defined data type, then our data type name, and then star, and then the pointer name. For example, struct employee star emp. This is how we are making a pointer of employee data type, right? So it declares a pointer variable emp of employee type, as I told you. So now moving on to the next slide. Access the pointer in the structure. Like when we were making a variable with that was a proper variable, not a pointer variable, we were able to access the member functions inside our user defined data type, right? So when we made a structure of pointer type, how we will make or how we will access those member variables, right? So here is the answer. The member of the structure variable is accessed by using the pointer variable with the arrow operator, like the pointer name, and then we will use this arrow instead of period operator, that is dot. Instead of dot, now we will use this pointer, right, to access the member variables. The syntax to access the pointer to the structure. This is the syntax to access the pointer to the structure, right? Pointer name, then this pointer, and then the structure member name or the member name or member variable name, whatever you want to call it, right? For example, emp arrow name. Here name is the member or the member variable inside our user defined data type, right? This is what it have written here. So this is as simple as this, and there is nothing much about pointers and structures. We can similarly pass our pointers, as I have told you in the previous videos. We can similarly pass these pointers to the functions, and we can receive these pointers from a function, and so on. So now moving on to the next slide. So we are having functions and structure, and here we will see that how we are passing a structure to a function, right? The structure variable can be passed to a function as a parameter, like we used to do for int type or a character type. Similarly, we will pass our struct type into a function, right? The program to pass a structure variable, like this is the program I have written. Firstly, I just have written the header files and the struct of employee which I have made. And in next slide, I believe there would be the main function and the function in which I am passing it to be as argument, right? So this is the main function. We made the variable, then we printed the user that enter the ID of the employee. Then we took input of the ID. Then we asked the user to enter the name of the employee. Then we took input. Then we again asked for the salary. Then we took input. And then we simply called print data, and we passed our like data, we passed our variable, but here we can see the difference that here we are passing uh, the variable with its complete name, like struct employee e1, whereas when we used to declare that variable of primitive type like int or character, we just used to pass the name of the uh, variable, but here we are passing the exact name as here, right? Struct employee e1, and then we have our print data function which we are calling here. So it is again we are like void print data type. I believe by now you are all are familiar what this void means, and this is name, and then round brackets, and then struct employee, and then emp, that is the variable which we are declaring to like get this variable or the data which is passed from here, so that we can receive in this argument, right? So now we are simply printing, and you all know by now that how to print, right? And like print the values of member variables of a user defined data type. So now moving on to the next slide, returning struct from a function. Like in this function we will see how we can return a structure from a function. So we firstly made a like a variable of that data type, user defined data type. Then we received whatever this get data is returning to us in this emp, that is variable, and then we simply printed here. So let's see in get data type, get data, what we have. This is struct employee, that is the data type this function will be returning. Then we have the name and round brackets, then curly braces, and inside it we are simply just receiving the here from this to this line we are simply declaring or making the variable and receiving all its data of the or updating its data of member variables, and here we are just returning this variable name, right? At the time of returning we can simply use the name, but at the time of passing we have to pass the complete uh, like variable, right? So this was it. There was nothing much in this structure or structures and functions and structures and point, and this was pretty much it which you all have to know about it. And yeah, so I'll meet you in the next video with another topic. So thank you everyone. Hey everyone, welcome back to First Mentor. And in previous videos, we studied everything about structures, and we went through how to use pointers with structures, and how to pass a structure in a function, and how to receive a structure from a function. So now we will be studying about union, and we'll be understanding what union is, and let's just go through it. Union is a user-defined data type like structure, right? The union group logically relate the variable into a single unit as structure do. The union data type allocate the space equal to the space needed to hold the largest data member of a union, right? So here the difference is that it is just allocating the that amount of space which is required to store the largest data member of the union, right? The union allows different type of variable to share same space in the memory. Like the largest data member, we are just taking that amount of space, and that space is stored by or shared by different variables of different data types, right? There is no other difference between structure and union that than internal difference, and though that internal difference is nothing but that the space issues, right? That in union you are just allocating the data that is equal to the largest data member of the union, right, inside the member function of the union, right? The method to declare use and access the union is same as structure, as we have studied about structures. So you must be aware that how to declare and use and access in structure. So everything is similar in union. So now moving on to the next slide, we have defining a union. That is how to define a union. So union has to be defined before it used. Similarly, like structure,
The syntax of the defining a structure is, or a union is, union, union name, then curly braces starting and curly brace end, and after ending, then we have semicolons, and then we have data types of different types. It could be of different type of or of same type, right? It is similar as structure. So I believe it is pretty much clear to everyone, because there is no such big difference except from the internal difference in union and structure, right? So now moving on to the next point, next slide, we have example. Uh, the union of employees declared as union. Then we have name of the data type, that is employee. Then curly braces start, curly braces end, and between them we have int employment ID. Then we have string name, then salary of float type, then string type of address, then integer type of department number, and then integer type of age. Right. So moving on to the next point, next slide, we have difference between structure and union. Like you should understand it, because sometime like at the time of interview a person can ask you like what is the difference between a structure and a union, right? So let's just go through it and try to understand what they are. The memory occupied by the structure variable is the sum of the size of all the members, but memory occupied by the union variable is equal to the space held by the largest member of a union. So I believe this is pretty much clear because it's written in a very clear language, and I have also told you while like telling you about union, right? So now moving on to the second point. In structure, all the members are accessed at any point of the time, but in union only one of the union member can be accessed at any given time, right? We can access all the data types or all the members of structure at any point, right? We can also access them at same point of time, but in union we can only access that one at a time, right? So these are two major difference between structure and union. So these were the only differences, I believe. So now moving on to the next slide, we have application of structure. So structure is used in database management to maintain a data about books in library, items in store, employee in an organization, financial accounting, transaction in a company. So these are basic that's why we need to have a structure or a user defined data type, right? So that we can imply these data types in actual world, right? Or we can make our own variable according to our own need, right? Beside that, other applications are changing the size of cursor, clearing the content of screen, drawing any graphic on the screen, and receiving the key from the keyboard. These are the internal functions, but I believe these are the major function you should remember, right? So that was pretty much it. And so here we come to an end. So I hope you all get to know about what are structures and union, and it's pretty much clear to you all. So thank you everyone. Hey everyone, welcome back to First Mentor, and in today's video we are going to study about that how can we take input of a file from C, like using the C language, and also like give an output of a file using our C language, right? So let's get started. So, why files are needed? Like, let's just start from the basics that why files are needed. When the program is terminated, the entire data is lost in C programming. Like, it is not stored anywhere, right? So, if you want to keep the large volume of data, it is time consuming to enter the entire data, right? Or like if the data is like of large amount, it will be like very time consuming as well as space consuming to keep that data. But if file is created, these information can be accessed using the few commands. Like but if we create files for these like data, we can easily access them using few C commands, and we will see what are those commands are, right? These are large number of functions that there are large number of functions to handle input in C, input and output in C. In this lecture, you will be learning to handle like how to handle standard input or output function in C, right? So high level file input output function can be categorized as two given two files, like text file and a binary file. Like these are two basic files which we are talking about to take input as well as to give output of, right? So moving on to the next slide. File operations, what are the these are few operations which we can perform on these files. And what are those? Creating a new file, opening an existing file, reading and writing to a file, and closing a file. These are four operations which we can perform using our few using few commands in our language to manipulate our files, right? So moving on to the next slide. Working with files. How can we work with file? Let's see. While working with file, you need to declare a pointer of type file. Like firstly, we need to declare a pointer and the type of that pointer would be file. This declaration need for a communication between file and the program. Like why we need to declare this pointer? So that our program can communicate with the file, right? And this is the declaration of the pointer, if you can see, and I believe everyone would be able to see, right? So now moving on to the next slide. Opening of a file. How can we open a file? Let's see. Opening a file is performed using a library function fopen, and I believe by now everyone have studied like what are library functions. If not, you will be studying in like next or upcoming 1-2 videos, or might be you would have studied, right? So opening of a file is performed using a library function. Library functions mean this is already provided to us by the C libraries, right? That is the function name is fopen, right? The syntax for opening a file in standard input output is like pointer which we have declared before, assigning this pointer the address of this file, like, right? How we are doing that? Fopen, then file open, comma, mode. These are two things which we are giving as input. And here we have the example that what this file open and mode means, right? So let's see. F opens. Here we have given a way, or if you all have seen that when we open any file or any disk in our computer, there is this kind of path which comes to the above provided line in the computer. This is the path to the file, I believe, and this is W, right? This in the first we write the path, and let's see what this means, right? Like this is the same thing, is the location of created file, right? This is the path to the location of the file, right? And W represents the mode for writing, right? So here W represent mode for writing, and this is the path to the file. So basically the file open means the path to the file, and mode means what mode, that is writing, reading, or what type of mode we want to use on, right? So here the program.txt file is open for writing mode. That means now we'll be able to open this file and we'll be able to write anything on that file, right? Moving on to the next slide. Opening modes in standard input output. We have seen how we can open, but let's see what kind of modes we are having to open a file. The first mode is R, that is to open for reading. If the file does not exist, fopen returns null, right? If there is no file, then it will be returning null at the reading mode, right? W stands for open for writing. If the file exists, it contents are overwritten. If the file does not exist, it will be created, right? If in like writing mode, if the file is not created, it will be created. Like if file is not present, it will be created, and if it is already exist in existence, uh, like the content will be overwritten, right? So the next mode is A, that is open for append, that is data is added to the end of the file. If the file does not exist, it will create, right? Whatever, suppose we have the file already, then we will open that file and we can add on the data on that file from the the last data which is already present on that file will not be deleted or overwritten. We'll keep on adding the data after that previous data, right? And if the file is not created, it will create it, right? Then we have R plus, open for both reading and writing. If the file does not exist, F open returns null. Like F plus is for reading and writing both, and if it is not like the file is not in existence, it will simply return null to the pointer, and null will be stored to the pointer. And then we have W plus, open for both reading and writing. If the file exists, its content are overwritten, right? If the file does not exist, it will be created, as you know what it means, right? And then we have A plus, uh, open for both reading and appending, right? If the file does not exist, it will create. And you know A is for appending, and A plus means for reading as well as for appending. And if the file is not in existence, it will create it, right? So moving on to the next slide, we have closing a file. How to close a file using our C language, right? The file should be closed after reading or writing of file. Closing a file is performed using a library function. Again, the library function, that means it is already provided to us by the libraries or inbuilt functions of C, and the function name is fclose, right? And what we are passing in fclose, the pointer to that file, right? PTR is pointer associated with the file to be closed, as I told, right? Moving on to the next slide, it's like simple, pretty much simple syntax, and there is no rocket science in it we are using, right? So moving on to the next slide, the function fprint and fscan functions, right? The functions fprint and fscans are file version of printf and scanf, right? Like we have used printf and scanf, and similarly fprintf and fscanf are file version of these two commands, right? Simply we'll be able to print using fprintf, and we'll be able to scan the file using fscanf, right? The only difference while using printf and fscanf is that the first argument is a pointer to the structured file. Like the first argument would be the pointer. Like in scan, like printf and scanf, it was not a pointer, it was %d, but here it would be the pointer, right? Moving on to the next slide, here we have a function. And let's see what this function is for. We have our header file, then we have our main function, and in this main function we have declared a variable n, which is of n type. Then we have a pointer of type file, and this file is then assigned with a like assigned with a text file, and we have assigned like we have used the library function fopen, and then we have provided with the path, and we are opening with the mode w, that means only for writing, right? If the f pointer is null, that means the file is not existence, so we'll simply return error and exit. This is also an inbuilt function, but as you all remember, at the time of w, uh, when we operate on mode w, if the file is not present, it will create it, and it will create it and return the pointer, I believe, right? So what after that, we'll simply ask the user to enter for the integer n, then we will scan it, and we'll simply like, here is the difference how we are using fprintf. Firstly, well, we are using the like pointer, we are passing the first argument as the pointer, that is the pointer to the file, and the second argument is %d, and the third argument is n, right? And in then we are using fclose, and fclose, you all know how to use it, simply fclose and the pointer to the file, right? So let's see what this program is doing. This program takes the number from the user and stores in file. After you compile and run the program, you can see a text file program.txt created in C drive of your computer. When you open that file, you can see the integer you entered. So this program is nothing but to create a file in which you are able to store numbers or write numbers, right? So I believe it's like
clear to everyone that how we are using it or doing it. So fprintf is simply printing the number to the file, right? So that was pretty much in this program. And let's try to read, let's try to like understand this program, which is to read from the file. So we have our header file, then we have our main function, and then we have an variable of int type n, then we have pointer uh, like file of file type, right? Then we have a condition that if like we can also come like use our use we can also keep it like this as well as use it like this. And if this comes to be null, that means the file is not there, because we are operating on mode read. That means if file is not present, it will simply return null. So if null is returned, it will print the simply program will print the error or error in opening file and exit the program, right? If file is present, then what will we will be doing, we'll be simply doing fscanf, that is to scan the like value from the file. And we are providing the pointer to the file, then %d, that is to like scan the number. And then we have ampersand n, as it is simple, it is like similar to like we used to do while scanning a number in C. And then simply we are printing using printf, and then simply f close and pointer to the file, and that's it. And that's how we'll be able to read from the file, right? If you run the program like if you run the program above to write in the file successfully, you get the integer back entered in that program using this program. Right. So, like if you run this program and created a file and entered a number in it, or printed a number in it, you will be able to extract that number from that file using this program. And let's just keep this video till here, and from the next video we'll be studying about binary files, and we'll see how to use binary files, and how to take input, give output in the binary file. So we'll meet you in the next video. Thank you, everyone. Hey everyone, welcome back to First Mentor. And in previous video we studied about like taking input and giving output of a text file. And in this file we'll be studying about binary files. And I believe like while we work with the text file, it's clear to you everyone. If it is not, I would say just go to the previous video and try to watch it again and try to understand it better, because that's how we play around the files. And to be honest, while working with C, until and unless you are not going into development of using C, you will not be using files, like how to you will not be playing with how to take input of a file and output of a file. And let's get started with binary files. Right, depending upon the way file is opened for processing, a file is classified into a text file and a binary file, right? Like depending upon like way of opening of a file, it is classified into a binary file as well as into a text file. Yeah, if a large amount of numerical data is to be stored, text mode will be insufficient, right? So if there would be very large amount of numerical data, text mode would be insufficient. In such case, binary file is used, right? So I believe you are able to understand why we use binary files, right? Working of binary file is similar to text file with few differences in opening mode, reading mode from file, and writing to the file, right? So we will see what are the differences, but for now you can just understand there are differences in opening mode, reading from file, and writing to the file, right? So now moving on to the next slide. Opening mode of binary files. Let's try to understand what are the opening modes of binary file. So opening modes of binary files are RB, RB plus, WB, WB plus, AB, AB plus. Like I am able to like I am assuming you are all able to recognize what what are R plus W plus A plus from the while working with the text file, right? So the only difference between opening mode of text and the binary file is that B is appended to the uh, to indicate that it is a binary file, right? We are just appending the B with the command so that we are able to tell the compiler that these are the binary files, right? And meaning of R is read. I hope you all know that R plus is read plus write mode, and W is write mode. W plus is write read and write mode again, I guess. And A is append and A plus is append and read mode. Uh, so these are same commands, just be appended to the end, right? That's the only difference. Read and write of a binary file. Let's try to understand what are read and write of a binary file. Function fread and fwrite are used for reading from and writing to a file on the disk, respectively in case of binary files, right? So in the previously we were writing fprintf and fscanf, but now we are doing fread and fwrite to read and write to the file, right? The function fwrite takes 4 arguments: address of the data to be written in the disk, size of the data to be written in disk, number of such type of data, and pointer to the file where you want to write, right? So basically 4 pointers are given to writing fwrite, that is address, address data, where we want to address on the disk, right? Number of data and number of such data and pointer to the file. Let's just read from here again so that it will get clear to you all. Address of data, address of data to be written in the disk, size of data to be written in the disk, number of such type of data, and pointer to the file where you want to write, right? So function fread also take 4 arguments and similar to fwrite function as above. Like fread would be taking the same arguments as fwrite is taking, right? So now moving on to the next slide, we have a program which indicates that so let's see the program and try to understand that how binary files are working, and the program to take input or give output using the binary file, how it is different from the text file, right? So write a program to read name and marks of n number of students from the user and store them in a file, right? So we'll be taking reading names and marks of n numbers of students and from the user and storing them in a file, right? So let's get started. We have declared a string, and then we have int marks. We have declared like 3 variables of int type, that is marks, I and n. So we'll ask the user to enter the number of students, and then we created a like pointer to the file similarly as before. Then we have tried to open the text file using the W mode, that is write mode, and in this mode if the file is not there, it will create that file, right? So if the f pointer is equal to null, it will simply return error, and if not, then we'll simply run a loop from I0 to I less than n, right? Simple for loop, right? In this for loop, what we are doing, we are printing f like for student, and will we are writing the ith student. For ith student, enter the name, then we are scanning the name, and then we are also printing, then enter the marks, then we are entering the scanning the marks, and then we are simply printing those marks and name to the file. And you all know that how we are doing that. Simply first we will uh, what we'll do, pointer to the file, then we have uh, name, and then we have marks, and simply name and marks, and simply we are printing, and then in the end, after coming out of the loop, we'll simply f close and pointer to the file, and that's it, right? So now moving on to the next slide, That was pretty much in it in the input and output of files using C. So we'll meet you in the next video. Thank you, everyone. Hey everyone, welcome back to First Mentor, and in today's video we are going to study about standard libraries in C, or should I say what are the inbuilt libraries provided to us by C language, right? So when we started this course, I told you all that C was developed so that like so that the programmers can have an upper hand while using the inbuilt libraries. So we are going to study that what are the inbuilt libraries provided to us by C, right? So let's get started. So C provides a collection of library functions for programmers, as I told you. If these libraries functions are used in program, be sure to include these prototype library function. Prototypes are placed in the specific header files. Like suppose we are gonna use a particular like inbuilt function or a standard library. So we must include a like particular header file so that we are able to use that function, right? For example, a function prototype of like printf and scanf are found in the header file studio.h. Right. So, for example, like we have used like printf and scanf throughout our course, right? So, the prototype of these functions are found in header file studio.h, right? So, moving on to the next slide, to include a function prototype defined in a header file into our program, use the preprocessor instruction hashtag include. We have discussed it that to include a header file, we have to use this preprocessor that is hashtag include, so that we are able to include that particular header file in our program, right? So let's talk about math library function, right? One type of library function which provides several functions for execution of the mathematic operations is math. We see that we have performed a lot of mathematical operations like plus, minus, subtraction, and there are a lot of more mathematical operations like sine, cos, and all those functions, right? So to like use inbuilt those functions, we can simply include math.h header file in our program so that we can use the inbuilt or the functions which are provided to us by the C program, right? The prototype of these functions are declared in the file name, header file name math.h, as I told you, right? So math library function example, like square root function, we like as the name says, square root, sqrt is used to find the square root of a particular function. This function can be used to find a root of a given number, right? The function declaration, uh, like how we declare the function double, like we are using this to like do the typecasting. We have done typecasting of the pointers in like dynamic memory allocation. So this is nothing but the same thing, but here we are not doing casting of a pointer, but we are doing typecasting of a number, right? So squrt, we write this, and then double n, right? Again we are doing the typecasting. But if we do not do this double, if we do not write this double here and double here, the square root function will still work, right? The number its square root you want to get, like here, like basically it's basically shows that the number which we are putting in the square root is of double type, and the return type of this function is also double type. This is what it means, right? It is not doing the typecasting. For example, double number, we have declared a number of double type, then we took the input of that type, and then we simply like pass this number in the function sqrt, right? And we are simply able to get the square root of that number, right? So moving on to the next slide, we have abs function in our math .h header file. And what this function do, this function is used to get the absolute difference between two numbers, right? Absolute difference means whenever we are passing a negative number inside it, it will be returning us the positive number. Like it is similar as modulus function in maths, right? So the number, its absolute value you want to get, we are passing it here. The return type of absolute function is int. Like example, we can see we have declared two int type variable num and absolute value, and we have taken input of the value, and then we stored ABS of num in ABS value, right? So now we printed f these two numbers, and we will be able to see the difference. You can try it by yourself and pass a negative number in num, and then do put the ABS of that number in ABS value, and then try to print both, and you will be able to see, right? So moving on to the next slide, we have these bunch of functions provided to us by the math.h header file, and let's just go through them one by one and try to see what are they and how to use them. We have ceil function, basically rounds x to the smallest integer not less than x. That means we have studied about the estimations in math, right? So what we do used to do in estimation, whenever we used to have a particular value in decimals, suppose the decimal value is 5 or greater than 5, we used to round it off to the next value. And if it used to be smaller than 5, it used to be rounded off to be the smallest value, like the previous number, right? But in ceil function, it is always rounding it off to the next number, right? And then we have cos function. This is a trigonometric function whose range will always go from 0 to 1, and we pass x in radians. Then we have a exp function, which is exponential function, right? We also pass x or a number inside it as an argument. Then we have fabs, which is absolute value of x, right? We can simply use abs also, right? Then we have floor x. It is similar to like the decimal estimations, but here, like always, the number is rounded off to the previous value. Rounds x to the largest integer not greater than x. Like always less than, we are always estimating it to be the lesser value. Like suppose we are having 5.5, then floor of x would be 5 and ceil of 5.5 would be 6. So this is the difference. Then we have f mode. We are passing in the two arguments, and let's see what are these two arguments. Remainder of x and y as a floating pointer number. So this basically what it do, it returns us the remainder of these two value, but as a floating number or a float number. That is a decimal value. Then we have log x, a natural log of x base e, and then we have log 10x, then logarithmic of x base 10. So these are few functions which are provided to us by math.h. To be honest, like you will be using ceil, floor, and f mode or abs. Most of the time you will be really using exponential or logarithmic function, but it's good to know, right? So now moving on to the next slide. So I believe we should keep this video till here, and in next video we'll be studying few more standard libraries in C, and we'll meet you in the next video. Thank you everyone. Hey everyone, welcome back to First Mentor, and in previous video we started studying about standard libraries in C, and we studied about math.h, and let's get started and study about standard lib.h header file. And so let's see what it is. To include this header file to our program, we have to use the preprocessor directive, that is hashtag include stdlib.h, and then we have a abort function in it. What this function do, let's see. Termination abnormally terminates a program and write a terminating message on the screen. That is abnormal program termination. And then abort the program by call it
by call to exit with the exit code 3. Declaration void abort void, right? So basically abort is a function which we get in the standard lib.h, and what this do, it basically used to like abort a function abnormally, and at the time of abortion, it simply like displays the message on the user screen that abnormal program termination, and then simply exit the program. So how we declare it? Simply void abort, and then in the like in the uh, round brackets we pass void in it, right? So this is it. So then we have atf at off and underscore at told, right? Let's see what they do. At of converts a string to the floating point value. Basically at of converts a string to the floating point value, and underscore a told converts a string to the uh, long double, right? So declaration of them is double and at of, and then we pass the string in it. So basically this means it returns double value, and we pass a string in it, and it returns a long double value and we pass a string in it. Similarly in it returns a void value and we pass void in it. Right. So moving on to the next slide, we have ATOI. It is a macro that converts the string to the integer. Like it is used to convert a string into an integer. Declaration, it returns a integer value, and then we write ATOI and then pass string in its as its argument, right? And this will return a integer. So this is it about ATOI. And then we have swap as a one of the function provided to us by the standard library.h. It is like basically swap function copies n bytes from the from string to the to string. Like basically we provide from and then to, and then we also like provides n bytes, and then it copies that number of bytes from to from the string which we gives, right? Adjacent, even, and odd bytes are swapped, right? Basically it swaps the adjacent, even, and odd bytes. This is useful for moving data from one machine to another machine in different byte order. Basically like useful for transferring data from one file to or one machine to another. Declaration, it returns nothing, and then we write swap, and then we gives a from pointer, then to pointer, and then the number of bytes, right? So like if it's not clear to you, or you are like seeming like it a bit difficult, don't worry about it, because you are not going to use it. Like so far I have not even used it even a single time. So it's like good to know, but you'll not be able to like use it in a lot of time, right? So moving on to the next slide. System. Then system invokes the DOS command, interpret the file from the inside of execution C program to execute a DOS command, batch file, or other the program name by the string command. So basically this is used to like command to the DOS of the or the CMD of a computer. So that's pretty much it about the whole sum of this paragraph. And declaration, it returns an integer value, and then we write system, and then we pass a command string in it, right? So moving on to the next slide, we have time.h header file. Time.h header file converts the various function operations on time. Like basically we can easily convert the time using this time.h function, like clock time, c time, s time, time, different time. And I believe you should like search about this and read about this on GFG, and you will be able to see the program as well as the how to use it in a better way, right? Though we never use this kind of header file, or we like rarely use this header file in our program, right? To include, we always do hashtag include time.h. Then we have clock function. Clock return the number of clock ticks since the program started. Like it counts the number like the time since the program has started. Clock can be used to determine the time interval between two events, right? declaration clock underscore t, then clock, and then we pass nothing in its as its argument, right? That was pretty much it about the clocks. As C time and C time, let's see what are they. As C time converts data in time to sky, and C time converts date in time to a string. So this is like pretty much easy functions we use. And declaration are the return type is a string or pointer to the string, and then we use as time, and then we pass a string in it, right? And again for C time we are returning, we are getting pointer to the string, and C time then we are passing the time in it as in heart as its argument, right? So that was pretty much it about the standard libraries, and mainly we are going to use math.h library to like operate over the a lot of math functions and make our work easy. And that was pretty much it. So thank you everyone. We'll meet you in the next video. Hey everyone, welcome back to First Mentor. And so far we have covered almost everything in C, starting from like basic taking input and the output to the structures and unions and the standard libraries and how to handle files using C program, right? So now since we have came to an end, we are gonna make a mini project using our C language, and that mini project is gonna be our library management system. So let me just give you an overview of the project so that you'll be able to understand it in a better way. The project is gonna be a library management system. That means it will be managing the books, right? So basically we would be able to input a book, its ID, and the amount or the price of that book. And then also we are going to have a function which through which we can like delete a book, update a book, and like also like check the availabilities of books. So this is going to be our a little mini project. So it's going to be simple, and I'll be telling you the basic idea, or I'll be giving you the hints about the functions, and you all have to code it by yourself, right? And no worries, I'll be showing you my code, but it would be very raw, right? So to make it fancy, it would be on you, so that you will be able to explore the project and explore the language more, right? So I'll be helping you make a completely working project, but making it or decorating it, it's your duty, so that you will be able to explore the language more, right? So let's get started. And the basic overview, I have told you all that what our project gonna do. So you can see in the screen that there gonna be a main menu, and there gonna be a bunch of options. So in the project which I have made or I have wrote the code, it's gonna be have four simple functions, and that four simple functions would be of adding a book, deleting a book, or checking like the number of books available, and or should I say the available list of books, and to update a book, right? You can also add the functions like issue book, and like edit book. We are having a edit book record, and to view book list we are having this also. And you can simply just add this issue book, and this is like you should not I believe you should not think about this option much. And so let's get started, and let's see, and let me just show you uh, my project or my running code, so that you can get a brief idea that what you have to make. And by looking this simply, you should be having a clear vision in your mind what your program should look like, or what the things you have to add in your program, right? So let me just show you my code or my working code, so that you'll be able to have an idea, so that what you are supposed to do, right? So let me just build it and run it. uh, so finally I'm using code blocks instead of using the gfg id.
right? So you all are like free to use whatever ID you want to use. So here is our project what I have made. So it's simple. I'll be just asking the user to choose a option that whether he wants to add a book, delete a book, update a book, or want to check the available books, right? So simply let's just start with adding a book. Right. So after choosing an option one, it asked me to enter the name of the book. Let's say ABC is the name of the book, and after that, enter the ID of the book. Let's say one is the ID of the book, and it's gonna ask me what's the price of the book. So let's say 50 is the price of book. Right. So this is done. Right. We have entered a book, and uh, like this is it about adding a book. Right now we can check available books and see if we are having ABC available in it or not. So it's showing the available books, and there is book ID 1, book name ABC, and price is 50. So let's just start it again and just like try to see before adding a book the number of available books, and then to check whether like we are able to add it or not, right? So that there would be a clear vision. So let me just delete the book first, and then like add it again. So the main menu asked me whether like the choice I added, I like chose two, that is to delete a book. It showed me the list and asked me enter the ID of the book you want to delete. I simply chose one and it's deleted, right? Because after adding one, it's showing list of books after deleting books. Sorry, after it should be like list of book after deleting, right? uh just like wrong frame of sentence, right? It's showing null between it, right? So we can check also by using or choosing 4. It's showing nothing, that means we are not having any book at the moment. So let's just try to add again and try to see ABC name. 1 is the ID of the book and 50 is the price. So we simply have added, and let's just try to see if it added or not. So we are able to see that the book is added in our book, sorry, in our list, right? So let's just try to add one or two more, and we'll be exploring update books and available books also, right? Since we though we have like explored available books already, but uh, we'll be exploring like update books, right? We have also like explored delete a book option also, right? So let's just try to enter another book. Let's say XYZ, and ID is 2 and prices let's say 100. Then I'm adding another book. The name of the book is MB, let's say, and ID is 3 and prices let's say 500. Let's add another book, and let's the name of the book is NK, and the ID of the book is 4, and then we simply the price is let's say 1000, right? So now it asks me again that whether I want to add a book, delete a book, update a book. I want to update a book. Right, after clicking like choosing 3 and pressing enter, it showed me the bunch of books we are having and asked me to enter the ID of the book you want to update. Right. So let's say I want to update MB. I choose 3, the ID. It's asking me enter the updated name. Let's say MKC. Right. And it asking me to add the like enter the updated ID. Let's see, it's 3 again, and it's asking me to enter the updated price. Let's say it's becoming now 6000, and now we are having the list of updated books again, and we can see first is same, second is same, and we updated 3 and we are able to see the updated values, right? So this is pretty much it, and this is very basic program. Like there is nothing fancy I have done. It's just the blocks which are running on the C command prompt, and I would say that I'll be telling you that how these functions are made and how we are able to choose all these things. And till then, you should try to make it by yourself. And then, if you're not able to see anything, then go to the videos of these functions and see that how they are function or how these functions are working, right? And also I would say you should try to make try to look this program a bit more fancy, right? So that we are not be like going like this, and the user is not able to enjoy the UI, right? Just try to explore the different decoration options using C and on the Google, and I'll be telling you what you can do to like shift this and other options, right? So let's just get back to the presentation. And I believe let just you just try to make this program, and if you are stuck in any function, come back and see what you are supposed to do, and then try to implement it by yourself. So thank you everyone. We'll meet you in the next video. Hey everyone, welcome back to First Mentor. And in previous video, we had an overview about our function. And in this video, I'm gonna help those who are not able to understand that how he or she should start coding the complete project. Right. So let's get started and try to see how we can make this program, like if you are not able to understand what from where you should start. So I have written bunch of points. Using that you can frame or you can make your complete program, and if you are stuck in anywhere you can come back and see the video and code. Right. So basically, I have divided our project into five simple points or five simple parts. Firstly, a function to show the main menu. So the first thing first, we were able to see that at the time when our project or our code was running, there was a main menu coming in front of us, which was asking the user to enter a choice between whether he wants to add, delete, edit, or check the availability of books. Right. So firstly, we will be writing a code to take the input of the choice and to show the main menu to the user. Right. So this is the first thing we are gonna make. So I believe let me just give you an overview or hint that how you should make a main function, and the main function you should make like you should make a integer and declare a integer or in type a variable and take input of that variable, and then you should use of the switch cases. Instead of just telling you, let me just take you to the code and try to show you that what we should do. So here is the main menu function which I have made. So basically, let me just start from the start. I have bunch of files included. It's not necessary you should include all of them. I believe including studio.h, conio.h, live.h, string.h would be sufficient. It's not necessary to include all these files, right? So yeah, don't panic about what are these. We'll be coming to we'll be seeing what are these also. But the first thing first, I have declared a prototype of main menu here, as we have discussed in our functions lecture, that firstly we will be declaring a prototype before declaring or making a function, right? Or declaring or writing its definition, right? Then we have our main function, right? Inside this main function, what I am doing, the time I am entering the main function, I am simply calling the main menu, right? And here is my main menu function. So what's the type of what's return type of this main menu? It's void. That means it's not returning anything. So it's just simply I just make this to show the separations, right? So it's up to you, you want to make it or not, but I would say to make so that it would be you are able to distinguish when the main function, a main menu function is ending and other function is popping up, right? So basically I declared a int type variable named as choice, in which I'll be scanning the choice from the user, right? So simply what I did, I simply printed these statements that printf select a choice, and you all know that \n is to uh, start the new line or to end the line, right? So then we have again backslash n to show one more line or to skip the line, right? So then we have these options. I am like assuming that you all will be able to write this, right? After this, what I did, I just simply scanned the value of choice, and you all know how to scan it, right? After that, I again ended the line or said the compiler that move to the new line, right? Then we all know that how to use switch, right? And then I used switch and passed choice in it, right? Choice is a variable which can change according to the user, right? And the cases or the choices are like or the uh, like possible values a choice can have is 1 2 3 4. That is the options I am giving to the user, that is 1 2 3 4, right? If a user chooses one, that means we just simply add a book, and we'll call our this add book function, right? And then we have our case 2, uh, which is like delete book, right? And we all know why we add break after every case, right? Then we have our case 2, that is delete book. Then we have our case 3, that is update book. Then we have our case 4, that is all books, that is available books. It will be showing all the books we are having, right? Then we have a default case. I have added this. It's not necessary for to have a default case in a switch case statements, but it's preferable to have switch case. And I am adding this so that if user opt any value outside these four, it would be showing enter a valid choice, and it will simply return the program and terminate the program, right? So this is pretty much it in the main function, and I hope it's clear to you it's clear to everyone. And I want you all to try to code remaining functions by yourself, and if it's not, then you can see the hint videos, and I'll be adding the hint videos as well as the code uh, to you all. And in the end, I'll be sharing my GitHub repository where I'll be uploading my complete code, and you can simply go there and use my code or check my like get the hint from the code itself, right? So these were the 5 points in which I we divided our function into. But there is one more thing I have written, that we will make our own data type using struct, which would be having a string to save a book name, and integer for book ID, and a float for book price. So basically, what we can do, either we can maintain three different variables to maintain a book name, ID, and the price. But also, since we have studied about the structure, that is a user defined data type, we can make our own data type of book type, in which we can simply have three variables in it declared, that is name of the book, and ID of the book, and price of the book. And you can see simply here I have declared it as struct books, and I have the ID in it, I have the a name in it, and I have the price in it. And I hope you know that we declare string like this in C program. If you have not watched the video of strings in C, then you should probably go and watch that. You will be getting the better understanding, right? So that was pretty much it in this video. I hope you got the understanding, and we'll meet you in the next video. Hey everyone, welcome back to First Mentor, and we are discussing about the mini project, and we have discussed about main menu so far. And in this video, we will be discussing about add book function, that how we can add a book, and how we can make add book function, so that we'll be able to take the input of the book from the user and would be able to maintain or store it somewhere, so that whenever the user is like checking it or asking for the available books, we are able to show that, right? So since we have studied or we have completed the course, I am assuming that you all are able to understand that how we are able to store like a larger value of like variables of same types, right? I believe everyone have guessed that we are going to use array for that, or array to store. But what other thing you can do is, okay, I'll tell you in the last of adding add book function, so that you can try using that thing also. But here in my code, I have used array of books type, which and for those who have not seen the main menu book, let me just tell you, we have made our own data type name as books, and that books data type is simply storing the name of the book, integer or type of ID, and float type of price of a book, right? This is the data type I have made, right? So we will make a array of very large size, just to keep a buffer, like to like just to keep a buffer that the user is not exceeding the limit of our array, right? So I'm making an array of very large size of books type, right? So basically what I have written here, we will make an array of books type to store book, and then we will keep adding the books in it, right? So basically we all know that array is basically used to keep on adding the books. Right. So, like keep on adding the information of a similar type. So here that similar data type would be of books type, and we will keep adding. But there, like many of you may have a question that how we are gonna know that at what index we should add, like, or what the last index where we should add our book. So no issues for that. We will be maintaining index, right, which will be initiating from 0, and will be like not it's not necessary it will be reaching to the buffer value, so you can simply not define the upper limit of that index value, right? So we will be simply maintaining a index value, or and both the books type array and the index of the last like, or the index of the array where we will add the book now, will be global, so that every function would be able to use those things. So let's just go to the code and see what I mean. So I simply made a data type of books type, so that everyone like we can store everything in just one data type, and then then I have made a books type of array, and I have made of 1,000 in size. I'm just making it of very large size, so that like I'm not like exceeding the limit, right? You, I'll tell you another way also, but here I'm just using this method or this technique. And we all know whenever we make any like variable using our like user defined data type, then we have to use this keyword struct in beside that, right? And then we are also like initializing or declaring a variable of int type index, which is initially 0. That means it is the index where we will be adding our book, right? Suppose initially it is 0, then what we'll do, user called add book value, sorry, add book, and gave all the information about the book, that is name, ID, and price. So what we'll do, we'll simply keep that information safe in our uh, value, or in our index 0, and simply after adding that books information at index 0, we will simply what we'll do, we'll simply increment our index by 1, so that whenever the next index or next value will be next book would be added, it will be simply pointing to the index where we can add our book, right? So I hope I gave a clear vision about it. Let's just see the code and try to understand it a bit better. So here is my code of add books, and what I have written here. So first what I am doing, I am simply asking the user to like enter the name of the book, and then what I did, scanned it at particular index, and then we know that how to move inside the uh, like structure, right? Or the user defined variable. If you have not watched how to make a user defined like variable or user defined data type, and how to play with them, or how to like get the value or get whatever is inside that user defined function, I would say I would prefer that go and see the video of structure and union first, and then come here and make project, right? So we have a clear vision about this, I believe, since the time we have like studied about structure and union. So this is nothing basically what this line is saying to the compiler: hey, go to the ith index and uh, like try to fetch the name and store the value whatever the user is giving uh, in that particular like name of the user defined uh, data type, right? So I hope I made it clear. So similarly we are doing for ID, and similarly for price. And here if you see, I am using %s for string, %d for integer, and %f for float. And simply after adding the books to the particular index, I simply incremented the index and simply said the compiler now use the new line, and simply call the main menu. Why I am calling the main menu here again after adding the book? Because it's not necessary that the user just wanted to add the one book, right? It might possible that user want to add more books. So simply by calling main menu here, we'll be able to redirect to the main menu and ask this choice to the user again, right? So what I have done here, instead of writing the main menu again, I have utilized my written main menu code and simply called it inside the add book value, add book function, right? And I have made the array as well as index as a global variable, so that every function which I am going to define in my course or in my project would be able to like catch it or use it, right? So I believe that's clear to you everyone, and we'll meet you in the next video. Thank you everyone. Hey everyone, welcome back to the First Mentor. And in previous video, we have discussed about how to make add books function for our mini project. And I hope it's clear to you all. And now what we are gonna do, we are gonna make delete function or delete books function for our mini project. And we'll see that how we will be using or how we will be doing that. But if you have not tried to write a delete function by yourself, I would say go and uh, try to write or try to make the logic for this function by yourself, so that when you will come and look this function or code of this function, you will be able to understand it a bit better, right? So let's get started. So what we'll be doing, we'll show all the books to the users, and then we will take input ID of the book we want to delete from the user. So we will be basically showing all the books to the user first, and then we will be asking the user to enter the ID of the book he want to delete from all the shown books. And I will be telling you how we will be showing all the books to the user. And after he chose a particular ID, what we will do, we will run our loop from 0 to the index which we have made global till that end, or till the index less than that index. And if any ID matches the ID chose by the user, will simply run a nested loop from that ID, or the ID or from that index plus 1, and we will shift all the elements to left by 1. I think I made it a bit like, what should I say, complex, but it's, trust me, it's very simple. We'll just look at the code and try to understand, right? So this is our delete books function. So what we'll be doing, firstly I will be showing all the books, and we will see this function but a bit later. Let's just try to like understand delete function first. We will show all the books, then I have made a variable of integer type, and then we will ask the user to enter the ID of the book he want to delete, scan the ID he want to delete, Now here come the logical part. So the logical part says we will run a for loop, right? From where? From zeroth index till the index where uh, like our last book will be entered, right? Less than that index, right? Because this index always point to the space where we can add our new book. So that means till beside or till just before this index there are books filled in our array, right? I hope I am making sense what I am saying. Index always points to the place where we can add our new book, right? Where we can add our new book. This, I believe this is making sense, right? So what I am saying, index, like index is always pointing to the space where we can add our new book. Then what I am saying, index minus 1 will be the point till where all the books are filled in our array, right? I believe it makes sense to everyone, right? So this is what I am doing. I am running a loop from 0 till index minus 1, right? Less than index means index minus 1, and simple for loop, right? And inside this for loop, what I am doing, I am checking whether any element or any element of the array having ID equivalent to the ID given to us by the user, right? So after this, what we'll do, suppose if we came across to the ID which user wanted us to delete, or which the user wanted to delete, right? So what we will do, after when we reached that array, we will run another for loop from that index plus 1 till the last input or last book is present in the array, right? And I believe this is making sense, right? Index I plus 1 means the book just after the current book, and it is going till last index of the books array, right? After in this loop, what we are doing, we are simply shifting all the books uh, left by 1, right? So that means all the books present at I plus suppose there is a book present at I plus 1 index, right? So now what we'll be doing, we will simply move this book to I minus I index, or that is I plus 1 minus 1, or let's just keep it simple, j is I plus 1. So there is a book present at jth index. So what I did, I moved that book to j minus 1 index to delete the book present at ith index, because because the book present at the ith index is the book who is having the ID same as the ID which user want to delete, right? So after deleting or after moving all the remaining books to the left by 1, we'll simply break this loop, or this outer loop, and will come out of the loop and simply decrement the index by 1. Why we are doing so? Because initially we were having our index was pointing to the space where we can add our new book. But since we have deleted one book, there must be one space left at the end of the index, that is one white space remaining at the end of the index after deleting any book at the mid of the array, right? So I believe I am able to make sense. It is similar to suppose we are having what should I say, a pile of books, and I removed one book between them, and all the books above that book will be having a space, and all the books will occupy that space, and now we are having a book or a void remaining at the top of the book pile, right? You can simply assume it to be like that. That's why we decrement the index by 1, assuming that there is one space shifted. So that means now we are having one void space at the left of the index, and now we can simply point to the simply point to that void space to fill up the space, right? So we again let me just correct it. So this is simply we are saying that after printf list of books after deleting, and again we call this all function to show the list of the books. So let's just go to the all function and see what this all function is doing. So this all function is very simple. It is a void type, that is it is not returning anything, and I have used this to make difference, or like what should I say, separation between different functions, right? So we are just simply running a loop from 0 to I minus 1 index, and simply saying printf book id, and printing the book id at ith book id of the book at ith index, and then simply uh, like asking for the space to the compiler, then saying book name, and simply printing the name of the book at the ith index, and then price similarly. So this is a very simple function, and this is also like this is how we are gonna write our all books, or the all the available books function, right? Where we will be simply showing the list of all the books we are having in our array, right? Since we have seen this, you must be able to write the uh, function, or the function for all the available books, right? That is this. So after this all, what we did, we simply called the main menu. Why we did? After deleting, there might be chances that user want to uh, like add more books, right? There could be the chances, no? So after deleting, we will be redirecting to the main menu and ask the user to enter the choice if he want to like enter a book, or update a book, or add a book, or whatsoever he want to do. So what you can do here, you can add one more choice to the user, and that would be at 5, that he wants to terminate the program, that he do not want to enter anything anymore, right? So that was pretty much it about the delete function, and I hope the logic is clear to everyone, and we'll meet you in the next video. Thank you, everyone. Hey everyone, welcome back to First Mentor, and in previous video we have discussed about delete function for our mini project, and in this video we will be discussing about update function for our mini project. So if you have not tried to write the code for update function, I want you all to try, so that you will be able to think and would be able to build the logic for this function, and come back to this video and see what logic we are using here, and uh, see the code if you are not clear, right? So let's get started. So what we will be doing, we will show all the books to the user by using our all function, right? We have discussed that all function in our previous video of delete function, or delete books function for our mini project, right? So we will be showing all the books to the user by using that all function, and we'll ask him to enter an ID number of the book he want to update information about, right? So simply what we will do, we'll ask the user to enter an ID, and we will check in our complete list that if we are having a particular book of the ID, we'll simply uh, get that ID, or get that index of the book where that where the book of that ID is stored, and simply update the information, or ask the user to for the updated information, right? If not, we will ask the user to enter a valid ID, right? So let's go to the code blocks and see the code for this particular uh, logic or particular function. So it seems a bit big, but do not have to stress about it, because it's very simple. So first, simply what we will do, we'll show the list of all the books by using all function, and I believe you all have seen the like the previous video. If not, I have tell about the all function. So If you have not seen that, don't worry, I'll be telling you it, telling you again about the all function in this video. But let's just go through the code first, right? So firstly, we are having an integer, and we are asking the user to enter a ID to like particular ID for the book, because we have shown the list of the books. He would be able to notice that what ID he wants to update. Right? We simply took input of that ID, and then I declared a variable int j and declared it to be of -1. Right? Why I have done this, we will see in the code, in the like later on. So let's just go through it first, and you will be able to understand by going through the code. So what we did, I run a for loop from 0 to the index -1. That means to the last book, till the last book. And we all know that why index -1 is having the last book, because index is always pointing to the space where we can add a new book. So index -1 would be the place where our last book is stored. I believe I made it clear to everyone. So what we did, if we checked if array I dot id is equal to the id which user want to like update, we simply uh, like assigned that index of the array to the j and break the loop, right? And came out of the loop. If there is no such id present, we'll be running this loop and will came out of the loop, and the and the value of the j will remain -1. If this is so, what we'll do, we'll simply ask the user to enter a valid id of book and redirect to this update book function again, so that he would be able to select the id again, right? So if this is not the case, what we'll do, we are having the index where that book of the particular id is storing. So what we'll do, we'll simply ask the user to enter the updated name of the book, and we'll simply scan the scan the name of the book. And since we have the index, we can simply go to that particular place and access that particular book, and access the name of that particular book. And I hope it's clear to everyone by now that how we are doing this. If you have seen structures and union videos, you must be having clear vision about it. If you have not seen that, I believe go and check that out, and try to practice video, or try to practice functions, or try to practice structure and union, so that you will be getting a clear vision about it. Right after that, I set the compiler to choose the new line. Then I ask the user to enter the updated id. Then again I like ask the user for updated if he enter the updated id, we will be scanning it in the uh, like that book id, and similarly for the price. And we came out of the if else statement, and simply printed the new line, or asked the user to print everything from the new line, and showed all the books, and simply redirected to the main menu, because it's not necessary after updating a book he want to terminate the program. So we can simply redirect him to the main menu, so that he will be able to make the choice of uh, adding a book, deleting a book, updating a book, or checking for the available books. Right. Let's just go to the all function, so that we would be able to see. Right. So what we are doing in all function, this I have printed. So just I'll be able to make a difference between uh, different function calls. Right. So what I have done, I have simply made a for loop run from 0th index till the last index where book is stored, right? And this global index is always pointing to the place or space where we can add our new book. So that means the index -1 will be always storing a value which is having the will always be storing the last book added, right? So simply printed a book id, and then printed the id of the ith book, and similarly the name, similarly the price, and that's it. That's all about the all function. And this all function and this all function and all books functions are same, and this all book function is the function we are using for available books, right? So there is just one simple change in our like all books function, and let's see that changes after printing all the books. What we are doing, we are redirecting to the main menu, but in all we are not. So this is the minor change, and I believe by now you all are able to understand why we are always redirecting to the main menu. So I hope it's clear to everyone, and if not, like, try to watch this video again and you will be having a clear vision. So we'll meet you in the next video. Thank you, everyone. Hey everyone, welcome back to First Mentor, and I hope you all were able to make this mini project. And for those who were not able to like make this mini project, I am sharing my GitHub repository link, GitHub repository with you all. You can see, like, go to my GitHub repository and see the code of this project. And the one thing I want you all to try, that you all should try to use go to xy function in C. So basically, what this function do, it places the cursor at the desired location in the screen. So in my function, what was happening in my project, what was happening? Let's just wait for it to run. Like, it was just coming here, that is on the left side of the command prompt. But I want you all to make this project so that you all will be able to make this main menu to come here, and all the list, books, updates, whatever you want to do will be coming here, right? So just do this thing by using go to xy function in C, right? And try to make it look more beautiful. Like, my code is a bit raw. Like, this is the GitHub repository link. My GitHub username is mohit3031, and going to my like GitHub profile, you can simply see this C mini project First Mentor, and you will be able to see the code of the project. And you will be simply you can simply like copy the code and try to run it and get the idea or get the logic. But I would prefer if you if you would make the project by yourself, right? And apart from this, the another thing I want you all to try is that try to use the uh, files for storing the books and for deleting the books or to printing the books. Since we have studied about handling files using C, I would prefer you should all use that instead of like, so that it will get more clear to you all and your function will get more dynamic. Like, it would not be like whenever your command prompt is off or your program terminates, all the value stored will be gone. Because in our function or in my function, it is like this: whenever the program will get terminate, every book which we stored will get vanished. But when we will we will make a file for that input and to read, to maintain the books details, it will be like staying in your program in your laptop, and it will become a more dynamic function for you all, or for more dynamic project, you can say. And why I am not showing it? Because I have teached you how to do it, right? I have teached you how to read from a file, how to print in a file. Now you just are supposed to add 2-3 lines to do that, right? And if you will do it by yourself, you will get more confident about it. You try to Google it, you try to whatever it takes to make your understanding more clear, right? So I hope it's been a great journey for you all, and you all will be able to understand the concept. So thank you, everyone.